Hi, welcome to Pavitra Laptop Care. So your here is for learn a laptop chip level services, right? So before you start, some basic knowledge you must have because that is very essential to do the laptop chip level services. What are those? I will tell you in very simple manner. Please try to understand as much as possible. Those terms are number 1 electrons, number 2 protons, number 3 voltage, number 4 current, number 5 power, number 6 circuits, number 7 electronic components. Electrons are the part of physics science and are the subatomic particle with negative charge. Protons are the part of physics science and are the subatomic particle with positive charge. An energy will produce while negative electrons will flow towards positive protons. This energy can be obtained by connecting the electronic components with the help of electrical components in series or parallel combination is called circuits. So our motherboard will work through the circuits and is very important to understand. Current is nothing but flow of electrons in a circuit. Voltage is nothing but an energy to push or move the electrons in a circuit. Power is multiplication of voltage and current in a circuit. The unit is watt. Electronic components are nothing but semiconductor devices which won't allow electrons than conductors and won't oppose more than insulators. A motherboard will contain more than million circuits using electronic components to obtain a appropriate output. Types of electronic components. One is active components, second one is passive components, and third one is hybrid components. Active components which have the ability to control or amplifies the energy in a circuit. Transistors, MOSFETs, diodes, integrated circuits, programmable devices, display devices, batteries, CRTs, etc. Passive components which doesn't have the ability to control or amplifies the energy in a circuit. Examples: resistors, capacitors, inductors, coils, etc. Hybrid components which includes both active and passive component characteristics. Example: crystal oscillators. Non-electronic components which are the path to connect multiple circuits. Those are connectors, RAM slots, PCB strips, wires, cable, jacks, stickers, heatsink, fans, paste, thermal paste, panels, switches, screws, speakers, etc. Schematics are graphical or symbolic nodes of all electrical, electronics and non-electronic components which are connected in circuits. And here is a small introduction of a motherboard. This is actually Dell motherboard, Dell laptop motherboard. So what is the model number? So model number will be written like this. Okay. Here is the model number. Name is CAL50/DAL10/ space LA-F115P. This is the model number. It's made on 2017-9/26. Okay. Revision 1. So this is model number, and next, what are the overview of this motherboard? Just now what we discussed, basic things. Here in next chapters we can continue all the things. Just a small introduction here. See, this is called smart chip. This is graphic chip. This is processor, and I will be some other side. This is called bottom side. Okay. So now here is the components. These are coils. Active components, passive components. See, this capacitor, inductor, resistors are passive components. Here this one, MOSFETs, ICs, 3-leg ICs, diodes, transistors, MOSFETs, all are active components. These all are connectors. Here is the WLAN connector. Here is the RAM slot. Here holes for panel, and here also connector. It's a HDMI or USB. See, this is HDMI, this one is LAN connector, these are USB connectors, this is audio jack. These are our connectors, see, strip connectors. This is SSD connector, and here it's a battery connector, EDP connector. From here only we will get the output to the screen. Okay, it's a battery. Here also one more connector is there. So just introduction, that's it. See, these are the active components, ICs. What are those ICs? In next classes you can come to know. Okay, these are the tracks. How this motherboard designed and what are the layers will be there. Next class we can discuss. These are the keyboard connectors, keyboard light, backlight connectors. Okay, this is a Dell. This particular motherboard made for Dell. See. Okay, this is bottom side, and one more side is top side. This is other side. This is IO. IO is the active component, means it's a smart chip. Okay, it looks like this. See, these are a combination of active and passive components, these circuits. Here is the black color one, resistors. This one is capacitors. This is called jumpers, resistors, 3-leg MOSFET or transistors, 2-leg diodes. This is reserved for connectors, WWAN. Okay, fuse, F means fuse, PJP means it's a jumper. Here also connectors. This is polar capacitor. These are like capacitors, 0 ohms resistors. Okay, this is called introduction of the motherboard, and next chapters will identify the components. What are those, how it looks like, and what are the function of those components. That's it in this chapter. Thank you very much. Welcome to Pavitra Laptop Care. See, here is a motherboard. In motherboard we can able to see multiple components. What are those? These are electronic components. What kind of electronic components? These are passive and active components. In this, what are the passive components and what are the active components? In today's chapter we will come to see. See, here the black color 2-leg components are there. See, here. These are called resistor. These are the type of passive components. So what it is and what it does, let us check one by one. What is resistor? A passive electrical component with two terminals that are used for either limiting or regulating the flow of electrical current in electrical circuits. The main purpose of resistor is to reduce the current flow and to lower the voltage in any particular portion of the circuit. The unit of the resistor is ohm. There are two types of resistors. One is linear resistor and other one is non-linear resistors. Linear resistors. The resistors whose values change with change in applied temperature and voltage are known as linear resistors. There are two types of linear resistors. Fixed resistors. These resistors have a specific value and these values cannot be changed. Following are the different types of fixed resistors: carbon composite resistors, wire wound resistors, thin film resistors, thick film resistors. Variable resistors. These resistors do not have a specific value and the value can be changed with the help of dial, knob and screw. These resistors find applications in radio receivers for controlling volume and tone. Following are the different types of variable resistors. One is potentiometers, rheostats and trimmers. Non-linear resistors. The resistor value change according to the temperature and voltage applied and is not dependent on Ohm's law. Following are the different types of non-linear resistors: thermistors, varistors, photoresistors. Resistance in series. Resistors are said to be series when the current flow through all the resistors is the same. These resistors are connected from head to tail in series. The overall resistance of the circuit is equal to the sum of individual resistance values. Resistance in series formula. See, R total is equal to R1 plus R2 plus R3 plus and so on Rn, where R total is the sum of reciprocal of all the individual resistance. Resistors in parallel. Resistors are said to be in parallel when the terminals of resistors are connected to the same two nodes. Resistors in parallel share the same voltage at their terminals. Resistors in parallel formula is 1 divided by R total is equal to 1 by R1 plus 1 by R2 plus 1 by Rn total. Here is the conclusion. See, in any motherboard, if you see this black color component is nothing but a resistor. See, these are our resistors. Why these resistors are used in motherboard is to avoid the flow of current or some of the voltages. Okay, in series, if these resistors are connected in series, what it does, that addition, the total addition of the total number of the resistance is equal to R total is equal to R1 plus R2 plus R3. What are the resistors are in the series in the circuit? Okay, it means it adds the number of resistors. One thing you have to be noted down is current will be same in each resistor in series. Voltage will divide. Okay, in case if it is in parallel, the resistance value will reduce. It means 1 divided by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 like that. In this, current will be vary and voltage will be the same. Okay, that is the conclusion. There are many types. One is fixed and variable. So what are those? Step by step you can check. So what are the fixed? The value will be fixed only. In case of variable, the value of the resistance gradually it will vary, like potentiometer in receivers, in FM and all. And some of the resistance will vary as per the temperature. In that, Ohm's law we can't apply. It may be NTC or PTC, means positive temperature coefficient resistors and negative temperature coefficient resistors. Okay, that's the conclusion here. Welcome to Pavitra Laptop Care. See, the resistors in circuits, this is most important device, means most important component in any motherboard, because you must know what will be the voltage from source to destination in any resistors, any kind of resistors, depending on the circuits. It may be closed or it may be opened. Okay, in that condition, what the result we will get from the resistors, because if you miss any one resistor, the result may vary, much variation you will get in the motherboard. Okay, how you will get the variation, that we will check one by one. Okay, now in this video I will open a motherboard schematic and motherboard images. I will completely explain. Okay, using a motherboard schematic, so complete section today we will see. Now resistors in circuits. SMD resistors. SMD stands for surface mounted device. And SMD is any electronic component that is made for use with SMT. SMT means surface mount technology. Nowadays very thin resistors, thin components are available, okay, to reduce the space of the motherboard. Okay, SMT was developed to meet the ongoing desire for printed circuit board, PCB, which I told you, it's a motherboard. Those are PCB. Manufacturers to use smaller components and to be faster, more efficient and cheaper when assembling components to the PCB. See, the motherboard is nothing but a PCB, right? Printed circuit board. On that, very small components if you put, so the size of the laptop also will be very less. So that is the reason very small SMD components are used in PCB. SMD register size. See, this is the most important thing, how the size, how you will recognize the size. So there is a code actually. The shape and size of surface mount resistors are standardized with most manufacturers using the JEDEC standards. See, the main thing is this is a standard in maybe worldwide standard or Indian standard. Actually, it's a worldwide standard, JEDEC. Yeah, according to this standard only the SMD components will be manufactured. The size of SMD resistors is indicated by a numeric code such as 0603. Any SMD resistors in schematic they will be mentioned. It's a 0603 means that kind of gap will be there on the PCB and that resistor you have to put. Okay, this code contains the length and width. See, 06 is nothing but length and 03 is nothing but width of the package. So the imperial code 0603 indicates a length of 0.060. This is the length actually, inches, and a width of 0.030 inches. Okay, here is the length, width, height. These all are the codes. See, usually for CLR we are using 1206 size, 1210, 126, 0805. Usually what are the components we are using? 126, 0603, 0402, 0201, now 01 and below. Actually this is the very small one. So what are the wattage capacity, that also it indicates this table. The main thing is this all indicates the size of the component, resistor size. Next, resistors behavior in circuit. See, you have to give more concentration on this chapter, this topic, because using this only the active components will be working in the motherboard. Any kind of motherboard or any electronic circuits, depending on this characteristics only it will work. So now resistor behavior in circuit, single resistor in a circuit. See, there are two circuits, working circuits I'm talking about. One is closed circuit, other one is open circuit. Okay, closed circuit in the sense there will be a source, the positive and negative. Positive will go through a component and the destination part of this circuit will be connected to the negative. That's called complete circuit. Here, open circuit, the source will be connected to the electronic component, here is in series, and in one part, it's a destination part, or here or wherever it may be, the destination part won't be connected to the negative part. Then we call it as open circuit. It means the source till the destination part it will flow. Okay, but the same or little bit difference voltage we can get it, but it is not completed because it should be connected to the negative. When it's not connected to the negative, then here we will get the source voltages. But once it connected to the negative, here the source voltage will pass through the components and the destination part always will be 0 because it's a complete circuit. What are the voltage will be there? That will be the grounded one. So this is called source and this is called destination when switch is connected to the ground. See, here 19.5 volts. Any laptop will be using 19.5 volts, usually Windows laptops. Okay, one laptop it will be different voltage, but anyway we will consider it as a voltage, main source voltage. So that one will enter to the resistor. Here 10k resistor has used here. Here first pin number 1 and this one is pin number 2. Pin number 1 is called as a source and pin number 2 is called as a destination. Okay, in case the supply, once this supply goes here, till here it's open circuit, right? So here 19.5 volts you will get. After that, after crossing this resistor, it may be little bit reduced. Okay, here we will get 19.1. Still it is an open circuit only, because in case it is connected to next device, then we will calculate as a next device. So till here it's open circuit. In case this one is connected to the ground, then it's called closed circuit. here itself. So that time 19.1 volts won't be there, that will be 0 volts. Okay, now it's a continuation part. The destination part is continued to other component. Correct. Here is a load, bulb also a component. So now what will happen, the 19.1 volts will move to this load. So bulb will glow and finally here will be 0 because the switch will be on condition. Okay, the switch will be on condition, then this voltage directly connected to the ground, then only bulb will glow, otherwise it will be in off condition. Okay, so now you understood the source to the source of the resistor will be 19.5 volts, the destination will be 19.1. In case the destination is connected to the ground, then here it will be 0 volts, but destination is connected to the other component, so other component will glow because the destination is connected to the ground. Okay, so here complete path happened, so that's why here it's a 0 volts when the complete circuit will be there, when the switch is connected to ground. Now in case here is the open circuit, this is the source to source of the resistor will be 19.5 volts usually. The destination of this resistor will be 19.1 because it's already, what is that, one more component is connected in series, that's why. So in case this one is connected to the ground, then it will be complete circuit, but now we are talking about open circuit. The circuit is not connected any component, then here you will get 19.1 are related to this voltage. It's not exact one, it's depending on this value. Okay, so now one more component, here is the bulb will be in off condition because here also you will get 19 point something voltage because it is in series, so here it will pass and here also you will get, but I'm not talking about exactly bulb. In case if you are connecting any resistor, one more resistor, then the source will be 19.1, but it depends on the bulb characteristics, here voltage will be there or not. Okay, in case if it is open circuit, you won't get the voltage, any voltage here, but in case of the component one more resistor, then you will get 19.1 volts. Here the switch will be open because the negative path is not connected to the positive path. So here you come to know the resistor characteristics in closed circuit and open circuit with a single resistor. Now see, in case actually resistor is a passive component. In case before or after the source of the resistor, before the source of the resistor is connected to the IC, I mean active component, or the destination part is connected to the active component, what will be the voltage? That you must understand. Okay, the main supply is source, here is the positive and here is the negative. Now the source is connected to the IC, means it's active component. After this IC it will connect to the resistor, means here till the before the source of this active component the voltage will be 19.5 volts. Okay, before the source of this IC 19.5 volts. After this IC to the source of the resistor, the voltage may be vary 0 to 19.5 because the active component has capability to control the voltage and power. Okay, it may control the voltage and power, so that is the reason I'm telling it may be 0 or it may be 19.5 or lesser than that or more than that also. Okay, it depends on this IC. Here 19.5 I told, it may be 25 also. Okay, according to the characteristics of this particular IC. Okay, the source will get the voltage, then according to this it will pass very little less voltage you will get and other load as connected here. So the load is bulb, then it's a closed one, so that's why bulb will glow. In case here it's a less voltage, bulb won't glow, but here you will get always 0 volts. The complete circuit, the load of the destination is connected to the ground, then always you will get 0 volts, any kind of load component or any kind of component. If the component destination part is connected to the ground, then there will be 0 volts. The source of the particular component is connected to some active components. The voltage of the source of the component is depending on the IC active components. Okay, this is a closed circuit. Here is the open circuit. Now in open circuit, what will be the condition? See here, before the source of this IC will be 19.5 volts, or it's a battery voltage. Okay, what are the source we will giving that voltage till the source of this IC will get. After that, destination of this IC and source to the resistor, we will get the voltage according to this IC. Okay, here the destination of this, you will get the same voltage or little less compared to this source voltage. Here is the load will be off condition because it will be in open condition. This one is not connected to the ground. Okay, so now here is the voltage 0. So now it's not 0 because it's not closed circuit. That's the reason here we will get the voltage, same voltage here. Instead of bulb, if it is a resistor, the same or lesser than voltage we will get. Okay, just for example, I taken as a load. Load may be resistor also. Okay, now we have seen the voltage across the resistor, open and closed circuit, what it will be. Now we will move with the double resistor. Okay, in case it is two resistors are connected in series, what will be the result? What will be the voltage divider rule in that circuit in case of closed and in case of open circuit? Okay, now the voltage divider will happen only in the closed circuit in case two resistors are connected in series, and the middle of the two resistor we will take it as a voltage divider. Okay, always you remember voltage divider, the source of the first resistor should be connected to the source or supply. Destination of the second resistor or third resistor or so on, the last resistor's source should be connected to the negative part. Sorry, not it's a source, it's a destination part. Okay, the destination of the last resistor, it may be R2, R3, R3, Rn, whatever it may be, the last resistor destination, pin number 2, should be connected to the negative part of the source in closed circuit. Then only we will consider as a voltage divider. For example, R1 and R2 is there. In between, if you take the voltage, then it's considered as a voltage divider. Okay, in case R3 also is there, here you want, that also consider as a voltage divider. The voltage, what voltage you want, it's depending on that. Actually, in voltage divider will be complete circuit. Okay, it's not open circuit, it should be complete circuit. Please keep it in your mind, because in many circuits, many laptop motherboards, you will get these kind of voltages. Okay, especially in charging circuits. So now the source, 19.5 volt source supply is connected to the source of this R1. It means here one thing is understood, the source is connected to the supply. Here destination is connected to the one more resistor, that is R2. Okay, so that's called voltage divider part, but it's not yet completed, correct? The destination part, here is the switch is closed and it is connected to the negative part. It means it's a complete circuit. Then we will consider as a formula. See, V out means here is the voltage divider output. How we will calculate V? V means it's a total voltage 19.5 volts. See, 19.5 volts, and R2 this one 10K divided by R1 plus R2. We have to add these two and we have to divide by the R2. Then multiply by the source voltage, then we will get 19.75. okay, in case it may be 3.3 volts, exactly equal one, it's a, what is that, 3.3 means it's a 1.6 something you will get, correct? Okay, this is called voltage divider. Which one is not voltage divider? See here, the destination part of the last resistor is not connected to the ground, then we not consider it as a voltage divider. It may be switch, or it may be MOSFET, or it may be transistor, whatever it may be, that particular component, in case it is not connected to the ground, then we should not connect it as a, consider it as a voltage divider. Okay, in that case what will happen, the source supply will pass here, it will, the destination, the same voltage or lesser than that voltage will pass here, destination part. If we take it as a source, this voltage divider, here 19.2 volts you will get instead of 9.75, because here the destination should be connected to the negative, means ground. then only we can get it considered as a voltage divider. Otherwise, here there will be no voltage divider. What are the source? Same thing or lesser than that, you will get the voltage. Okay, you got it? See, these two are most important thing, because here in charging circuit there will be logic circuits. Multiple logic circuits has been used because to consider it as an open and closed circuit, because sometimes we need voltage divider, sometimes we have to control the voltage divider. Okay, through the control device we can divide it as a voltage or not voltage divider. Okay, this is most important thing. Now I have taken a motherboard, that is LA-F115P. In this motherboard, what will be the resistor values and what are the resistors work? So one by one we will check. See, this is very simple. Okay, the main thing is here is a resistor. The source directly connected from the source supply and destination is connected to the IC. The destination part of the voltage is depending on the IC and the source will be same. The source pin number 1 source, for example, it may be 3 volts. The destination also will be 3 volts in case there is no IC. Because the destination in case of open, then you will get the 3 volts. Otherwise, the 3 volts is depending on the IC, destination part what you connected. Okay, the same thing here. See, this is what it is. Here is the PCH. PCH is the active component. Right, see, here is a resistor that is connected to the active component and here is the source. It may be 3 volts, here is the 3 volts or 0 volts depending on the IC. Okay, in case intermediate is there, then you need to replace this resistor or this IC may be the faulty. There should not be intermediate. Intermediate means here is the 10K. For example, you have taken as a 10K, but here is the 3 volts and here you will get 2.8 volts or 2.9 volts or maybe 0. It should not be 1 or 1.5 because it depends on the IC. In case IC is giving, then it's okay. But IC is taken as the input, then the problem with this component. Okay, this active component. In that case, we will consider it as a active component faulty or maybe resistor faulty. In that case, you need to open this path and you have to check this destination part. You are getting the 3 volts or 2.8 volts. Otherwise, the component is faulty. Okay, now this is the schematic I will take for this particular motherboard and I will explain the voltage path of this particular resistor. See, multiple resistors. This is very important. What are the resistors as connected? Pin to pin I will explain. Here I have taken schematic. So total 65 pages are there. One by one we will check. This you leave it. We will take only resistor part. Okay, only resistor part. Here 3 volts. Here it is connected to the where? Here it has connected clock, right? So clock CPU DPI1 clock. Here is the active component. So here you may get 3 volts or maybe 0 volts. Okay, depending on the active components. See, all this same thing. Here also 3 volts always. Here 3 volts always. You will get it or not depending on the active component. See, here actually if the source is connected to a supply, then we will call it as a pull up. The destination path is connected to the active components, then we will call it as a pull up. In case the source is connected from the active components and destination is connected to the ground, then we call it as a pull down. Here is the pull down. Here always it will be 0 and here it will be the voltage depending on the active component. Next, here pull down. Okay, one by one I am not going to explain now. That is understood. This is the pull up and this one is the pull down. And here, thing else, here is the pull down. Here may be voltage or it may be 0. 100% it's a 0 because it's connected to the ground. Here it may be voltage. It depends on the active component. See, here is the pull up 3 volts Vs and here the destination pin number 2 may be 3 volts or it may be some other voltages. See, here the IC is giving 0.6 voltage. Using this pull up, here the source is 3 volts but destination part is 0.6 volts because this IC is giving the data. To carry the data using the clock, here is the pull up voltage. The support of 3 volts pull up resistor, this particular signal is going to this particular side, means it's a destination part. Okay, now you understood. Here this IC is connecting to the other IC through this pull up resistor. Here is the 3 volts, but here it should not be 3 volts because it's a complete circuit. This voltage, this path is connecting to the active component. It's depending on the active component's characteristics. Here we can judge the voltage. In case this path is open, then easily we will get 3 volts here also. Okay, now understood. So this is pull down, pull up. Here this 3 volts is going to this path, but no resistor. Here the network resistor, see network resistor, this we consider as a one resistor, but it has 4 leg. Source, destination, source, destination, source, destination. What capacity? 15 ohms. Here is the source, it's a bidirectional. Here is the source actually. Here the voltage will come and here destination path depending on this circuit, I mean this IC. Means here maybe 3 volts or it may be 3 volts or not depending on this active components. Here is the pull up. No, it's not pull up, it's a path actually. In series it has connected. In case here 3 volts is there, then here also you will get 3 volts or 0 volts depending on this path. If it is connecting to the active components, then behavior of that active components you will get 3 volts or 0 volts. Okay. Now here to here is the series connection. So here is the 3 volts or here also 3 volts or 0 volts. Now here is the pull up 3 volts Vs. Okay, I'll make it big. Pull up 3 volts Vs. Here is the 3 volts or 0 volts depending on this component, connected components. Here 3 volts always PCH. Here also you may get 3 volts always PCH depending on the destination path, or maybe 0 volts. And anything here, see here it is in series, so here to here you will get the same voltage or lesser than that, or maybe 0 in case it is connected to the active components. Here is the pull up. Okay, see here one thing I will tell you, this is 4.7, it's the capacity of this resistor, and 0402 the size. Already explained, you know, the size. Here is the size code. See, here is the code 0402. Now you understood 0402 the size length of this resistor. Now it's 150K, it's the value of this resistor and the size will be 0402. Okay, here is the pull down, but here it's connected to the capacitor. Here is the pull up. It's, see, ash has given. See, wherever you get the ash, there is a logic, maybe 0 or maybe this voltage or lesser than this voltage. Here is the 3 volts, here maybe 3 volts or may not be. Okay, in case of ash. Here 100% it's a 3 volts and here it's a ground, 100% is a ground. Here voltage divider, see why it's a voltage divider? Here 2 resistors are in series. See, it's a complete circuit. What we have seen here, that one we'll check. Voltage divider rule. See, here is the complete circuit. Here is the ground and here is the positive voltage. Where it is connected? See, here is the source. Here is the 3 volts. Here is the destination 0. In between it has taken. Means here 10K, here 150K. If we do this formula, see, if we do this formula, here is the R1 is 10K and R2 is 150K. See, if you put this formula, here is the 3 volts and here is the 10K and here is the 150K, then you will get the result here. Okay, this is called voltage divider. Here also voltage divider, 3 volts is coming here and here you will get 10 means exactly 50%. Means it's 3 volts, maybe 1.5 volts you will get. Here is the pull up and here is the voltage divider. Board ID always will be voltage divider. Okay, this is called signal. This signal has this voltage. Okay, here it's a pull up, the signal is carrying this voltage. Here it may be connecting to I2 component, then 0 or voltage. Actually it should be voltage, there should be voltage because there is no ash. If ash comes 100%, it will be logic, means 0 or particular voltage. Here is the voltage divider, here is the complete circuit. Here you are getting the voltage. Here ash is there, then it may be 0 or maybe this voltage divider voltage. Okay, now you got the point, right? So here is the series. Here is the pull up, actually this is a pull up, then this also pull up. Okay, now in this, here is the network resistor as used. See, here's the input 3.3 volts. Here ash is given, here it may be 3 volts or it may be 0 volts. Here is the pull up, ash is given 0 or 3. Here the same is connected in series. Here may be voltage or maybe not. Here this voltage is connected here. Okay, it's 0402 size. Here is the series one. So from here to here signal is passing. Maybe voltage. Here also maybe voltage depending on this. Okay. Now here in series, this RTC cell, the voltage is going through this resistor, 20k resistor. Some little bit voltage may be drop. Here maybe 3.3 and here you may get 2.8 or 2.9 or 3 volts. Okay. Next I'll reduce it. See, this voltage RTC cell, actually that is a voltage name, 3.3 volts. Here also you will get 3.3 volts or 0 volts because here ash has given. Wherever the ash has given, there may be a logic, 0 or high, low or high. Okay, maybe this one is complete circuit or maybe open circuit, right? In case of it is complete circuit, the ash, it may be complete circuit, then here 0 volts because the destination part of this single resistor. See what I told here, the destination path, in case if it is connected to the ground, then it's a 0 volts. Okay, here all resistor we can check. Here 0 ohms, maybe this same voltage will go here. And what is there here? Here is the pull down. See, this 3 volts you may get here, but here 100% 0 volts. Next here is the pull up, 1 volts you will get here, and here is the 1 volts or maybe 0 because of ash. The size is 0402. Okay, this is over. Here is the pull up. See, 1k resistor as used. Here 3 volts, here it may be 0 or maybe 3 volts. Actually usually 3 volts will come, it depending on this switch, because it is connected to the ground, it will be the complete circuit. And here in series, the voltage, same voltage will come to this, correct? See, here is the pull up, this voltage will come to this. Here ash is given 0 or 3 volts. Here ash is given 0 or 3 voltage will enter here. Here is the pull down. Pull down is very important when you are shutting down. So you do the shutdown option, right? In those conditions, this will be in off condition. Okay, this is very important. Pull down. Don't neglect this. Here is the voltage divider. Here is the complete circuit. Here it has taken TPM ID. The source is 3 volts. What is that voltage divider? Here is the voltage divider. The source here 3 volts instead of 19.5 volts. You have to use here 3 volts. And R1 is 10k and R2 also 10k. Okay, 10k. The voltage exact divided voltage will get here. TPM, FTM. Sometimes what will happen? No, here this component won't be there. Then only this resistor will be there. Then 3 volts is available here. Sometimes this resistor is not available. Then only this resistor will be there. Then here the source part will be voltage, but here no component. Here will be the resistor. Then TPM ID, in case voltage will be there here, and here it will be grounded, means 0 volts. Okay, like this component or with component, what will be the voltage? Here the pull up, right? See, what are the pull up here voltage? Same voltage will come here. It should be there because there is no ash. So here is the pull up. Here's the pull down size 0402, pull down, pull down, pull down, pull up, next. Here see the source, maybe one source is 1 volts, here also maybe 1 volts or maybe more than that. It depends on high voltage, where a source or destination, which one is the highest one, that one we will get to destination also. Pull up, these all are depends on this voltage, but this one is depending on active component. It's a 1 volts, here also 1 volts usually. Pull up will be 1 volts, here also 1 volts, but 0 it depending on active component. Here is a pull down. Okay, next. Here see, very important one, the resistor is used as pull up and pull down also. Here is the sense ground, sense positive one. Here is the 3 volts, I mean what are the VCC core voltage will be there, that's the 1 volts or 0.3 volts to 1.8 volts, it's depending on the core. That voltage we will get or depending on this path. Okay, sometimes signal will pass, you won't get the voltages. Here is the pull down, it should be 100% complete circuit. Okay, then what will be there? Here it's a signal carrying, it's a pull up, this voltage is carrying by this voltage. Here is the pull up, VDS VID S out bidirectionally carrying by this 1 volts pull up. Okay, don't forget it, it's a pull up. Next, here VCC sense VCC VSS is nothing but pull down, VCC is nothing but source voltage. Okay, this VCC GT. Here source and destination, or destination and source, or source and destination depending on 2 voltage. Now here is the pull down. Here a resistor, here is the resistor, it will connect VCC ST enabled to here, and here the voltage, same voltage is here. The size you can check it here, see 0603, little bit big one compared to other one, compared to 0402, see 0402, the size is 0603, this one is length and 3 is width. Here same. Next, here same voltage, source to destination will vary. See all these are the ground, there is a resistor here. See, these all are voltage divider or pull up or only the pull down depending on the condition. Okay, see 3 volts always you will get here in case the component is present. You won't get the voltage in case component is opposite. That's it. Here it's connected to ground, there will be no voltage here because this condition is, it may be resistor or it may be directly jumper. Here is the resistor in series, this voltage will cross from here to here and this voltage will go from here to some other places. Okay, in this the condition I told you, no, pull up and pull down. Here it is in series, the same voltage SPD1 TPM will go to this. Okay, or in case of incoming, this voltage will go to this. Here is the pull down. Pull down is very important. Here is a resistor. Okay, 1K0402. Next, here see some logic is there, 3 volts always is coming here and here also. In case, see, this is very important, how I will explain you. Here for example I am taking, here is the voltage 3 volts always. See here the voltage, plus voltage is 3.0 volts. Now this is we consider as a R1 and here is the R2. Okay, the voltage, the characteristics of this component, here is the MOSFET, N-channel MOSFET. In case this N-channel MOSFET gate will get the voltage, then it will connect 1 to 3. means here it will be series, and this voltage destination will connect to the ground. Then we consider this part as a voltage divider. Then the voltage divider part will go here. Correct. Here is the one. Here is the R2. Here is the source part is connected to source and destination part is connected to the ground. In case here there is no voltage, then it will be in open condition. Then we should not consider it as a voltage divider, because I already explained you the destination part should connect it to the ground. Then only we consider it as a voltage divider. In case if it is not connected to the ground, means this open, I already explained it's a depending on the component. Here is the component. If it connects to the ground, then only voltage divider voltage will go here, and this component will work or not depending on the condition. Okay, here it's clear, right? It may be or may not be depending on this. Here, see, this means there may be voltage or it's directly connected to this jumper. No, it's not jumper. It's this voltage will come to this. This voltage will come to this. Here is the jumper. Direct same voltage is connected here, but size is 0603. Here the resistors are there. Here input, this signal will go here, 10 ohms resistor, or output the here output not there, only input. Here is the output but no resistor. Here is the pull down which is connected to the ground, audio jack, and here the network resistor has given. See, these 3 volts will become this one. It's depending on the active component. Internally it is connected to the ground, then complete circuit will happen, then the same voltage is going to ground. In case it is an open condition, then same voltage will go here. Okay, here is a jumper, same thing. Okay, see, same voltage will go here, this particular signals. Here the 100K 0402 size, lid close hash. Hash means it may be 3 volts or it may be 0 volts depending on this active components which is connected to the here destination part. Here is the pull down series, it's jumper. Here series is the voltage divider depending on this. Here is the connected to ground, here is the source, maybe here is the voltage divider. Pull down series, see, here voltage here or here voltage here. Usually this voltage goes here, but size is, see, here is a 0 ohms resistor 0805. Let me check. 0805 size. Okay, this one is, sorry, this one is 0.125 watt. Okay, this is a bigger resistor. Here this is the voltage divider, it's depending on the source. See, this one is connected to the ground, then here a voltage divider will get. Otherwise here what voltage? 3 volts only will get. Ground, both side ground. Here is the pull down, the network resistor is going to pull down. What the size here won't mention here. This is the size actually. Network resistor 0804. Here directly series, pull up, series. Here is the ground, here is the voltage divider, right? Here is the source. See, here is the source, but voltage divider, see, this voltage here directly, it's a complete circuit. You have to explain anything, but depending on this component it has given. pull up, pull up, pull down. Here, shall we check it as a voltage divider? No, it's only pull up. This voltage will carry this signal. This voltage will carry this signal. Here one more important, I will tell you. In resistor part, I already explained some of the resistors are not constant one, fixed one. Here is the 3 volts always. Here 7.15, it's a fixed one, but this is variable resistor, 100k to 0k. Okay, it will vary depending on the temperature. This one will vary. In case NTC or PTC, whatever it may be, it will vary. When it will vary, the voltage divider, see this one destination is connected to the ground, right? Here is connected to the ground, and here is the source R1, R2. If we consider is the R1, R2 and R3, means it's a 0, means we can consider it's a R2. Then the voltage divider is depending on the temperature. Here it won't be constant. See, that's why in case of thermal related information, we are using this thermistor. Okay, we call it as thermistor. What it is RH1, I will show you in picture, in image. Okay, now we are checking only the schematic thing. So now it's a voltage divider is depending on this. Okay, that is the most important thing. It looks like a coil actually, but that is a resistor. Or here is the network resistor. Here is the series. After this diode, what are the voltage will be there? That will cross this 2.2 resistor, 0402 size. 04 is the length and 02 is the width. See here also resistors. Okay, like this, the same condition you will get the voltage divider or pull up or pull down. Just a minute. See, I will go a little bit fast. Here series. Here, no resistors. Series. See, in this condition, if it is a ground here, then voltage divider will happen here. But here voltage divider, it has taken. Here is the source, in case of it's a some voltage, and here is the destination part, the divided voltage will get here. Pull up. Here. See, here is the voltage divider again. Because here is the source. Source is this one. What is that? Here is the PSID voltage. In this path, depending on the voltage, depending on this component, you will get the voltage here. For example, it's 3 volts, and here it will be dividing 100k and 15k. Okay, here this part, what are the components are there, the base is depending on this voltage. Okay, here is the source, it's a pull up. Series, see the resistors are connected in 3 to 4 what is that conditions. One is pull up, other one is pull down, other one is series, only 3. And one more is voltage divider. Pull up and pull down both will be there, then we call it as voltage divider. Is to pull up. See the logic is very, very important. This one I'll explain you. Here how to read. Here there are 2 resistors. Here is the one resistor and other one is here. In case this component is on active, then it will connect 1 and 3. Okay, it will connect 1 and 3. Then this path is called as a ground. Correct. Here the resistor R2, if we consider it as a R2, here is the R1, then we can get it voltage divider. In case this component is in off condition, then the destination is not connected to the ground, then we won't consider it as a voltage divider. See, I already explained you what is that. Here it is. It is the open condition. Here is the open condition. then the same voltage will pass here. The same voltage will pass here because this is in open condition. There is no ground. If there is no ground, the same voltage will get it. Okay, it's very important. Depending on this component, the voltage divider will happen. Okay, that's it. The same thing is repeated here. See, voltage divider, you can consider it as a voltage divider because here is input, here is the divider part, and here is the destination part. Source, destination, between voltage divider. This component is depending on this voltage. In case if it is a voltage divider, it will depend on this. Okay, what is that component? Later we can check. Now we are talking about the resistor. See, one more, this is the final one. I'll explain you. Here the source, here the what are the voltage is coming here. At one will enter, we consider it as a R1, and here is the R2. The R2 destination should be connected to the ground. The ground is depending on this component. This component voltage will come, then drain to source it will connect. Then we consider it as a complete circuit. Here is the 19 volts, here is the voltage divider part. Clear? The same thing is keep on repeating all over the motherboard. All the motherboard, same logic. Pull up, pull down, voltage divider. Pull up, pull down, voltage divider. That is the resistor policy. In series also, on series. Pull up, pull down, series, voltage divider. These four things are connected. Okay, that's it. This motherboard, we can see the resistors are connected in pull up, or it may be in pull down, or it may be in series, or it may be voltage divider. Got my point? In any motherboard, these are the four conditions of the resistors. That's it, guys. In any motherboard you take, only the four conditions. Once again I am repeating: pull up, pull down, voltage divider, or series. And voltage divider, in case of thermistor, it depending on the temperature. That's it. Now any motherboard if you take, now you are able to do the troubleshooting. I hope so, because completely I explained all the things. What will be the series, what will be the pull up, and what will be the pull down, and what will be the voltage divider. That's it. Whatever it may be the network resistor or normal resistors, or it may be temperature resistors. If any doubts, please contact us. Thank you very much. Welcome to Pavitra Laptop Care. Today's topic is capacitor. Capacitor in circuit. Actually, in short, the capacitor stores the energy. In case of DC, it stores till the capacity, positive side and negative side. What it has, that much it stores the energy. After that, it will oppose the DC, and it will, in case of AC, it will allow the DC because of reverse direction. Okay, how it will work and what is the job of this in motherboard, those things we will check in this video in detail. Okay, now the capacitor in circuit. Capacitor is an electronic component that stores electrostatic energy in an electric field. It consists of two electrical conductors. See, it will separate actually two internally. It has two plates, okay, conductors that are separated by a distance. There will be a gap inside that. It consists of two electrical conductors that are separated by a distance. The space between the conductors may be filled by vacuum or with an insulating materials known as a dielectric. The gap, what we call it, is dielectric field. The ability of the capacitor is store charges is known as capacitance. What it stores? That name is capacitance. Capacitors store energy by holding apart pairs of opposite charges. What are those? One is positive and other one is negative. The simplest design for a capacitor is a parallel plate which consists of two metal plates with a gap between them. See, there are two plates, in between gap will be there, that's called dielectric. So it holds the charges positive and negative. It consists of two parallel plates separated by a dielectric. When we connect a DC voltage source across the capacitor. One plate is connected to the positive end and other one is negative end. When the potential difference of the battery is applied across the capacitor, in case, see, this is the potential difference battery. Okay, it's a battery. If the battery is applied to the capacitor, what will happen? The plate 1 becomes positive with respect to the negative. Okay, the plate 1 will be positive end and second one will be charged through the negative end. The current tries to flow through the capacitor at the steady state conditions from its positive plate to its negative plate. See here, positive, it will be charged positively, right? So till here it will charge completely. It will try to enter inside, but it won't enter because of this insulating part. It's negative, but it cannot flow due to the separation of the plates with an insulating materials. Okay, see how it will charge. Once you connect the supply, here it will start from the 0. Here is the voltage and here is the time. When you connect the supply, first positive will come here and negative will come here. So it's like a battery, here positive and here negative, right? So battery also, it's like a capacitor. So that here it's showing. Capacitor, it won't store any energy because any load if you connect, it will discharge completely. But battery will store. Okay, that is a major difference. Battery, even capacitor also like a battery, but it's a temporary and it's a permanent one, like that. So a battery is connected across a parallel plate capacitor. See, here is a positive plate and here is a negative plate in between dielectric. When it will be in 0 position, when you give the DC supply, it will charge up to a point. See, up to here it charged. After that it will be constant. Once it full charged, so what it will do, it will oppose the DC. Where it will oppose, see here it can't oppose because here also positive is there, here also positive is there. So once it fulled, so exactly it will oppose and it will be stored here only. The positive energy won't charge anything because it will be in constant mode up to one level. Next, what will happen? This also charged, this also charged. So it should be discharging material should be there, then only it will discharge, right? So both are load. Now what will happen? An electric field appears across the capacitor. The positive plate accumulates positive charges from the battery and the negative plates will accumulate the negative charges. The capacitor holds the maximum amount of charges as per the capacitance with respect to the voltage. This time span is called charging time of the capacitor. See, this is the charging time. It's a maximum, that's called charging time. When the battery is removed from the capacitor, the two plates hold a negative and positive charge for a certain time. See, here is the positive and negative will hold. In case if we remove the battery, it will hold the positive and negative charge. Two plates hold a negative and positive charges for the certain time. Thus, the capacitors acts as a source of electrical energy. Okay, as I told you, it's like a battery. Now, if these plates are connected to a load, for example, if we remove the battery source and if we connect the load, once it charged, what it will do, it acts as a discharge. See, there should be a path, right? The positive and negative should go in a load. It should be a path, actually through a path it has to go. The current, see, the positive to negative side. Here is the load, the resistor will pass through it, then it will go to negative. Once the combination of positive and negative is nothing but a circuit, right? This would be complete circuit. Then what will happen? See, here completely charged one. When a load has given, then it will discharge slowly. At the end, it will be 0. Current will pass from here to here. It means across the load. This is called discharging time of the capacitor. Working principle. See how it will work. We will check. Here is a switch. Here is a battery and here is a capacitor. Once this switch is connected to the battery, what will do? This capacitor will charge up to a level. Correct. Once the level is completed, then what will happen? See, here is charging now. When this one is disconnected to and connected to the load, then what are the positive charged one? It completely goes to this LED and it will glow. So once again, please check. See, now it's charging. And after that, when we remove this, when we disconnect this, it's discharging and this light is emitting. Okay, like this it will work because it stores the energy and it passes through a load. Okay, this is the function of capacitor. Capacitors in parallel. So what will happen in case if you connecting in the parallel? Already in resistors you have seen the parallel and series how it will work. But here the parallel is dead opposite to the resistor. What are there in series in resistors, that is equal to here parallel of capacitors. Okay, it's like parallel. When capacitors are placed in a parallel with one another, the total capacitance is simply the sum of the capacitance. This is analogous to the way resistors add when in series. I already told you, the resistors when it is in series, it will be added. Like that, capacitor will be added in this, in parallel case. Much like resistors are a pain to add in parallel, capacitors get funky when placed in series. The total capacitance of n capacitors in series is the inverse of the sum of all inverse. Means here actually the series will be reduced. In case of it is connected in series, the capacitance of the capacitor will be reduced. It's like a parallel in resistor. Okay, this is the formula. Now, standard units of capacitor. Actually, farad is the standard one. Farad is the heavy amount. So that's why microfarad. Microfarad means 1 microfarad 1 by 1 lakh. Okay, see how much zeros it will come. So 10 to the power of 6 farad. So that's why it's a microfarad 10 to the power of 6. Okay, nanofarad is very high. It's a 9 digits. It's a 10 to the power of 9. Pico is more than that. Say nano pico, 10 to the power of 12. The capacitor symbol will be like this. This is the non-polar capacitor and this is the polar. Polar means it's a positive negative. It will be mentioned. You have to connect positive to positive and negative to negative. Okay. So reverse you should not connect. Here in non-polar capacitors, reverse you can connect. That is a plus mark. Here is the variable capacitor. Here is the trimmer capacitor and here general polarized capacitor. This one is electrolyte capacitors symbol. What is the SMD capacitor? See, in motherboard and all we are using SMD capacitors. So what is that? See, SMD capacitors due to some features like leadless, small size and is simple to arrange on a printed circuit board. These are perfect in high volume manufacture. The performance of these capacitors is very good, particularly at RF. The two conductors of these capacitors can be separated with an insulator. This insulator plays an essential role while storing electric energy. The main function of any SMD capacitor is to charge as well as discharge electrical supply. See, this one we are using non-polar capacitor in motherboard SMD capacitor. Here inside what will be there? The connecting terminal. Here we do the soldering part. Here also we do the soldering part. Ceramic layers, dielectric. These are the layers actually. These are the ceramic layers. This is electrode in between. Okay. SMD capacitor types. What are those? It's a multi-layer, tantalum, electrolyte. These three. Majorly it's typed as 3. Multi-layer ceramic. Just I showed you multi-layer how it looks like. In this type of capacitors, ceramic is used as a dielectric material. Here ceramic it has used. In ceramic capacitors, different ceramic dioxides are used. Okay, these are the different ceramic oxides. Tantalum capacitor. Tantalum capacitors are used widely to give high level of capacitance compared with ceramic capacitors. Based on the results of the design and the requirements of these capacitors, there are some packages are used to design these capacitors. These capacitors have some values which can be identified by marking respective standards and coding materials. See, here some mark are there. See, A107. These are one standard will be there. According to the standard, the storage we can get. Tantalum. Electrolyte capacitor. This capacitor is used in SMD designs due to high level of capacitance and low cost. In case some applications, some circuits want more capacitance, in that condition these kind of capacitors are used. These capacitors are frequently marked with the voltage and its value. See, usually it will be polar capacitors. In case if you want more capacitance, then we can use it as a polar capacitor. I mean, we can use polar capacitors. There should be mark. As per the mark only we have to connect it. In this type, there are two kind of methods. The first method is to include microfarad values, whereas another method is to utilize code. In the first method, when the capacitor is marked as 33 and indicates with 6 volts, then the value of the capacitor is 33 microfarad and the voltage is 6 volts. See, sometimes here they will mention 33.0. Here 16 volts. Sometimes 33.6 will be mentioned, then 33 is the microfarad and 6 will be the voltage of that particular capacitor. Means that's the capacity of that maximum voltages. The codes of electrolyte capacitors with their voltages are listed below. See, E, G, A, what are the codes are there? These are the standard one. Here is the voltage capacity of this particular capacitors. SMD capacitor identification. SMD capacitor can be identified based on the color of ceramic body material. The capacitors like NPO and COG ceramics are generally available in white color. They have less capacitance that ranges from 1 picofarad to 10 picofarad. The capacitors like X70, X7R and X5R ceramics are generally available in light brown. The capacitance ranges of these capacitors are from nanofarad to microfarad. The capacitors like Y5V and Z5U ceramics are generally available in black or dark brown. The capacitance range of these capacitors is extreme. However, they are extremely non-linear and generate low capacitance at high voltage. The capacitance of the capacitor has to measure continuously at numerous voltage. See, these are the size. Okay, 0201. Here is the size minimum, size in inches. See, 0201, 0402, 0603. So, as per the size, the color also will vary. Applications. See, this is the most important thing where the capacitor has been used. Okay, here application examples: decoupling or bypass capacitors. It will bypass, that's it. A decoupling capacitor's job is to suppress high frequency noise in power supply signals. See, this is the power supply. Here, in case the supply has some high frequency noise, it will bypass it, because here we know that it oppose the DC and allows the AC. It directly, if any AC will be there, means noise will be there, that one passes through these capacitors, okay, and to ground. See, here is the connected part is ground. One part is connected to ground and other one is connected to the voltage. Here, what are the noise will come, it will pass here. In case of DC, noise in the sense AC. In case of pure DC will be there, up to a level it will charge and it will oppose. Okay, they take tiny voltage ripples which could otherwise be harmful to delicate ICs. It will be harmful in case noise will come. No, it will be very harmful. So that's the reason here capacitor has to be used. Out of the voltage supply, if the power supply very temporarily drops its voltage, a decoupling capacitor can briefly supply power at the correct voltage. See, sometimes what will happen, supply won't be constant. That time IC won't work properly. So here what it does, it stores the energy, right? When it's abnormally works, then it will discharge to the load. Load is nothing but IC here. So it gives the continuous power supply, constant power supply. This is why these capacitors are also called bypass caps. They can temporarily act as a power source, bypassing the power supply. Decoupling capacitors connects between the power source 5 volts, 3.3 volts, etc. and ground. It's not uncommon to use 2 or more difference valued, even different types of capacitors to bypass the power supply, because some capacitor values will be better than others at filtering out certain frequencies. See, the main use of these capacitors are to filter bypass the high frequencies. Okay, so in this schematic 3 decoupling capacitors are used. One is polar and 2 are non-polar. Help of reduce the noise in the accelerometers voltage supply. Here is the voltage supply, voltage supply. 2 ceramic 0.1 microfarad. Here 1 microfarad is 10 U. titanium electrolyte 10 microfarad split decoupling duties. Okay, so sub-separate part, it shows it's like a sub-separate part storage device. Next, the same thing what we saw no in what is that schematic, the same thing in PCB. While it seems like this might create a short from power to ground, only high frequency signals can run through the capacitor to ground. See, sometimes capacitor will get short. Why? The high frequency above this voltage capacity, some high capacity frequencies will come, then only it will failure to pass the pass the only AC. It will allow the DC also in that cases. Okay, through the capacitor, the ground, the DC signal will go to the IC just as desired. Another reason these are called bypass capacitors is because high frequencies bypass the IC, instead running through the capacitor to get to ground. When physically placing decoupling capacitors, they should always be located as close as possible to an IC. The further away they are, the less effective they will be. The main thing is where will be the VCC, the nearby that IC only more capacitors will be placed. See here. So nearby the IC. The following to follow good engineering practice, always add at least one decoupling capacitor to every IC. So if you are a good engineer, so please try to do the practice of add the capacitors. Usually 0.1 microfarad is a good choice, or even add some 1 microfarad to 10 microfarad caps. Here power supply filtering. See the advantages of this capacitors. One is like a bypass. Now it's a power supply filtering. How it will filter the power supply? See, we know that bridge capacitors, bridge diodes. Diode will pass only one direction, other direction it will block, right? So that's why this kind of sinusoidal waves you will get. But this is not pure DC. Again, to purify these signals, the capacitor has to be used in parallel. See, diode rectifiers can be used to turn the AC voltage coming out of your wall into the DC voltage required by most electronics. But diode alone can't turn on AC signal into a clear DC signal. They need the help of capacitors. By adding a parallel capacitors to a bridge rectifier, a rectified signal like this, see, this is the one, can be turned into a near level DC signal like this. The capacitors are stubborn component. They always try to resist sudden changes in voltage. Means it's very slowly it will act, it will charge and discharge. No, that's the reason. When it will charge, suddenly it can't discharge. That time one more signal will come. Again it will start to charge. It will be in constant mode only. In that case, see, we will get this kind of signal. Suddenly changes in voltage. The filter capacitor will charge up as the rectified voltage increases. Okay, the process which I told you, the same way it will it will rectify the signals. See, this is a bridge rectifies. The diode will give this kind of sinusoidal waves, and if you connect the capacitor here, polar capacitor, it will filter like this. Okay, so here is the voltage and time. Now energy storage and supply. See, two possibilities we saw, and this is the third storage. How it will store? See, battery capacity it has and energy density it has, but this one only charging and discharging will be there, the capacitors one, and lifespan will be more. So charging and discharging, how it will do that, already I showed you in GIF. Signal filtering. How this is a very important one when you are seeing the PWM section in the motherboard. Okay, signal filtering is very important. Once again I'm telling, just what we know, it will oppose the DC and it allows the AC. This concept you have to keep it in your mind, and you can check how it has been used here. See, capacitors have a unique response to signal of varying frequencies. They can block out low frequencies or DC signal components while allowing higher frequencies to pass right through. They are like a bouncer at a very exclusive club for high frequencies only. Filtering signals can be useful in all sorts of signal processing applications. radio receivers might use the capacitor among other components to tune out undesired frequencies. In FM and all we are tuning, right? So this is the useful signal tuning. So using this capacitor only we can tune it. Another example of capacitor signal filtering is passive crossover circuits. The crossover circuits are there. Actually in future you can come to know what are the crossover circuits. Here is the crossover circuits. See here, this end is connected to other coil and speaker negative. Inside speakers which separate a single audio signal into many. A series capacitor will block out low frequencies, so the remaining high frequencies part of the signal can go. See, it blocks the low frequencies and it allows only high frequencies speakers to tweeter. In the low frequencies passing subwoofer, see, in case of low frequencies are there, it will pass to subwoofer. So high frequencies it will pass to tweeter. So high frequencies can mostly be shunted to ground through the capacitor parallel. Okay, here is the connected to the ground. So this is the schematic for this signal filtering. See, signal filtering, this capacitor is connected to some other coil or resistor. It's not connected to the ground because here one signal, it's a sinusoidal signal or a square wave signal will come, it will pass here and it will add up. If any DC will be there, DC and AC both will add and it will rectify here through this inductor. Inductor, what it is? So next you can come to know. Now capacitors in AC circuits, what it will do? In DC circuits the capacitor charges slowly. The capacitor will charge up to a level and after that it will be constant. In AC circuit it is a dead opposite. The capacitors charges slowly until the charging voltage of the capacitor is equal to the supply voltage. See, up to a level I told charge point, it will charge, after that it will stop. Also in this condition the capacitor does not allow the current to pass through it after it gets fully charged. Once it fully charged, it won't allow the current. And when you connect a capacitor across an AC source, it charges and discharges continuously. See, we saw the DC supply, but if we connect the AC supply, once positive terms will come, it will charge, and again the negative term will come, and then it will discharge. Correct? It's a vice versa. Positive and negative both will be there in sinusoidal. When you connect a capacitor across an AC, it charges and discharges continuously. Due to continuous change in the voltage levels, capacitance in AC circuits, it depends upon the frequency of the supplied input voltages. The capacitor charge is depending on the supply how you given to the circuit. Also, if you see the phasor diagram as an ideal AC capacitor circuits, you can observe that current leads. See, this is the current is 0 and here what is that? Here is the voltage and here is the current. Current leads 90 degree. When it will be 0, voltage will be 0, the current will be 90 degree. Okay, see, 90 degree. Here it will be, voltage will be high. When voltage will be high, current will be low. When current will be high, voltage will be low. Okay, this is most important in AC circuits. Role of capacitors in DC circuits. Once again, actually it's a more information I am giving to you. Power conditioning, decoupling capacitors, coupling capacitors and coupling capacitors. These are the applications I already explained you. One more scene is there, you can read it out. See here, the two possibilities already explained. One is in case it is connected to the DC. What it will do, up to a level it will charge. See, this is the time. Time goes, it will be slowly charging and up to a level reaches, it will stop and it will be constant. When it will discharge the current, see, that time up to a level voltage reaches the maximum, that time current reaches the minimum. When current will be the maximum, that time voltage will be the minimum in DC. In case of AC, time C, it will continuously flowing here. Positive, negative, positive, negative. It will charge and discharge, charge and discharge. Now the time to check in schematic. Okay, in last time we have seen the resistor, the maximum number of resistor as used in the motherboard. Same like that, second most largest components in the motherboard. In any motherboard, the second most or first most largest component in the motherboard, that is capacitor. Okay, see, anywhere you go, here you can see this. The capacitor may be connected through parallel or in series. In parallel, it will be added In series it will be divided, it will be less, correct. Sometimes here positive and negative capacitor, polarized capacitor used for storage purpose. Okay, so here see multiple places, but near to the IC it has used here. See, in case main supply will come there, the big capacitor you can see here, the main supplies. Main supplies enters to the IC, there you can see these kind of capacitors, maximum numbers. In case of signal pass, so this kind of capacitors 1 or 2 you can see in the path of the particular IC. Here is the main, here is the main, because here input supply will be there, so to reduce the noise. Okay, see many places it has used. So in schematic how it will be used, so we will check. I open the schematic. Here is the schematic, total 65 pages, one by one we will check as resistor, what I checked in resistor. So like that in capacitor also we can check. See what are those connected. Here it start from here, there is no capacitors, only resistors. Here no, here a capacitor. See, one thing is I wanted to tell you, where supply starts or supply ends, there will be capacitor has used multiple times. Okay, see here it has given to ground. Ground means it's a bypass. What we saw in theory, it will be used by as a bypass capacitor and signal passing capacitor. Okay, signal filtering or amplifying capacitors. Here one purpose is bypass. Bypass means here the noise, if any noise will come, that will be in AC format, that one it will enter, right. See, it allows AC and blocks DC. Up to a level it will charge and it will be constant. After that the main supply, DC supply, will go to the IC. See, VCC point, a capacitor we have seen. Here output VCC point, here one more VCC we are giving, this is output signal. If there is any noise it will rectify. See, here is the bypass capacitor. Next, here bypass, here bypass, correct. Here is the voltage, it is the VCC path. See, almost all, where is the VCC path, there will be a capacitor or multiple capacitors. Usually in parallel capacitors, in multiple series we can check. See, here it's a bypass. Here no, here no. See, these are the signal. Okay, that's why capacitor not required. Here see, bypass, here is the voltage, actually some noise may produce, so that's why here is the bypass capacitors. Here also bypass capacitors. Here is the supply to the IC and gate, so that's why here it has used. Again came back. Here no, here no. Sorry. Here no. Here it's a bypass. See this IC, here is the supply, 3 volts always, that's why a capacitor. Here is the output capacitor. Here also same thing, supply has capacitor, output also has capacitor. This 5 leg has one capacitor. See, usually the main supplies, supply part. See, here also the output part and input part. Here is the supply path. supply path, this is over, nothing, here supply path, here also supply path, it's a decoupling. Here after this noise may reduce, increase, so that's why here decoupling. Here VCC path, a capacitor. Here this also VCC path, here is a capacitor, and here also a capacitor, decoupling capacitor. Here is the decoupling which is connected to the ground, those all are decoupling. Bypass, so here is a bypass, here is the bypass, because these are the strong voltages, that's the reason bypass capacitors will be more, which is connected in parallel. See, any IC, the supply has 1 or 2, it's depending on the schematic. See here, this is supply, VS, bypass. In signal it's very rare. Bypass, here signal is there, but here coil, after coil it may produce, the noise may be produced. So here clock data, here clock and data, nearby clock and data, okay, that point has to be noted. Here it's converting this to this, that case also it may be there. Here also same thing. This is audio jack. See here one more thing, here signal pass. Here it's a signal pass, it's a amplification purpose. Here if any AC will come, it will pass. Bypass. Almost all maximum bypass capacitors has been used here. See, bypass. Here is the signal path, it will allow this signal to here. Okay, this is AC signal. Bypass. Next, here is the signal, it will pass the signal, because pin number 2 is not connected to the ground. Here is the bypass. Here bypass. Here bypass. See, if signal strength, voltage strength will be more, in that case this capacitors has been used here. See, here signal pass, it's like a amplifier, it will pass the filter capacitors. Some signal will be in AC form, so that's why here it will be used. Here transaction and receive should be in AC form because of communication path. Supply, so where are the supply will be there will be bypass, and where will be the signal will be there will be signal boost capacitor, we can call it, amplifiers. Here bypass voltage, bypass. Here is the signal one. See, it's a signal amplifier. Next, here is the signal amplifier. See, signal, it will pass the signal, AC signal. Means here capacitor is there, it means this one should reach here, in between capacitor should be there, then it's a good signal you can get. Bypass, signal. See, always signal one end should not be connected to the ground, okay, both the end with the connector part, I mean signal path. Where are the TX and RX, there will be no ground, please keep it in your mind. Here is the bypass, bypass, signal. See, these are clock and data, here will be AC, bypass, bypass, signal, bypass, here is the voltage, here is the bypass, here also voltage, bypass, signal, RX and TX, voltage, there is no bypass here, bypass, 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 signal, RX and TX, signal here, see, here and here, type C, signal, signal, that RX and TX, here bypass, voltage, bypass, 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 99% it's a bypass only. Where are the signal there, it's a boost, you can call it as boost, bypass, 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 boost, boost, bypass, filter. Any low frequencies will come in this path, it will filter. Here also, see, core section, and also storage also required, for that also it has given here. Here bypass, memory, bypass, see, the main source will enter from this DC in, correct. Here before this coil, 3 capacitors connected in parallel, that is filtering capacitors, bypass capacitors. See, after generating this voltage also, bypass capacitors are used. Multiple places. Here also, where are the supply, there will be capacitors. Here also bypass. See, here is like, what is that, boost or protection, boost or protection, two kind of things. It will pass the signal or it will protect from here to here end. Bypass, the supply is given, so here is the bypass. Bypass, here sometimes it's storage, okay, this is for store. Here is the bypass. bypass, supply, bypass, IC. See here one more thing to be note down. This IC to this connection, this pin to this pin, there should be a decoupling capacitor. Okay, it may pass the AC signal. Here actually inside this IC some AC signal will be passing, so that's why this capacitor has been used here. So it will add up actually. Here AC signal will come to this point and some filtering process will happen. That later you come to know. Okay, here is the boost. We call it as boost. Means year to year it will separate it in case of DC and it will allow the AC. Bypass, boost. See where are the IC? Inside this it will call it as a boost and here is the bypass. Here is the boost. Same thing. Here is the ground. Ground bypass. Ground bypass. See the boost to this legs in between the resistor and a capacitor has given. Some signal will pass through this resistor and AC will pass through this capacitor. Here coil. After this coil it will be filter the AC one. Bypass, bypass. Here there is no ground, so here is the boost or protection. Bypass. See boost or protection. Bypass. Bypass, bypass. Here is the boost. Here to here it has connected or protection or filtering purpose. Here is the storage. We can call it as storage device. Here is the bypass. Here is the boost. Boost. Bypass. Bypass. Storage. Battery, like a battery. Because these all are some voltage required to the load. That's the reason here polar capacitor has been used. Okay. Where are the necessary, there only it has been used here. So here no polar capacitors. Here boost. See here little bit storage required, so that's why like a battery it has used here. These all are bypass. Bypass, here storage. Bypass. Bypass, and here is the filter, signal pass, boost, protection. Here the bypass. This one is signal pass, boost. Okay, bypass. That's it. Total 65 pages cut over. So maximum here it has used as a bypass capacitor, and second thing is filter, what is that, boost capacitor. Second highest one is boost capacitor or protection capacitor. Okay, and sometimes polar capacitor has been used here like a battery supply storage device. That's it. In any motherboard, this is the purpose of the capacitor. Okay, that's it. Thank you very much. Welcome to Pavitra Laptop Care. So today's topic is inductor. What is that inductor? Inductor is nothing but a coil, means a twisted conductor. So when current flows on it, so what will be the characteristics of this? Well, let us check one by one. This is inductor. So what is inductor? An inductor is defined as a passive component. Yes, it's a passive component that is used in most electrical circuits. In circuits you have seen multiple, okay, to store energy in the form of magnetic energy when electrical current flows through it. See, when current flows through a device, through a wire, twisted wire, so there what it will do, it will convert as a magnetic energy. It is also known as a coil, choke or reactors. Okay, it is a two-terminal electrical component that is characterized by its inductance. See, it has two terminal. Okay, inductance is defined as the ratio of the voltage to the ratio of the change of current. See, voltage and current will be differ here actually. Voltages, when voltage will be high, current will be low, and when current will be high, voltage will be low. The SI unit of inductance is Henry. Actually, the unit of inductance is H Henry, which is named after Joseph Henry. He is the American scientist. See, when the switch is off, there is no, here actually simple circuit we will take. So here actually it's an open circuit. When it will close, then what will happen? See, when the switch is off, there is no current flowing. When you flip the switch on, the battery will try to get current slowly. See, if it is connect without this twisted cable, immediately here is a LED, so it will glow. Correct. So, but it won't do like that. So, current flowing. It means there is a change in current which the inductor will resist. See, for example, here is a cable actually. Here is a normal cable, but without twist, if we connect here, it looks like this, right? Straight line. So when you connect this switch, then supply immediately it will glow. I mean, it goes to the LED and LED will glow. But here twisted cable, the same conductor, it is a twisted one. When twisted, the current will change. See, when we close it, the pin current flows on it, and it will take time, little time, and slowly it will charge and it will glow. LED will glow slowly. So that is the characteristics of the coil. So instead of the current going from 0 to maximum right away, it will gradually increase up to its maximum current. Okay, it will rotate, and slowly it will increase to the maximum current, and it stores the energy, and after that it will be constant, and remaining current will go through this. So here is a small, what is that, GIF file. You can check how it works. When it is closed, see, LED slowly it will glow. When it is open, no. When again it will close, what will happen? See, slowly the LED will glow. Okay. Next, this is the symbol. Air core inductor, air core won't be there. Iron core inductor, inside iron will be there. Ferrite core and variable core. Different types of inductors: iron core, air core, iron powder, ferrite, infrared, soft ferrite, and hard ferrite. Inductor in parallel. So what will happen? See, if two terminals of an inductor are connected to two terminals of other inductor, means two terminal here the same is connected to the other inductor terminal, same terminal, then the inductor are said to be parallel. See, this is called parallel. Positive, positive, negative, negative. We know that when resistors are connected in parallel, how it will connect in parallel? So that is, their effective resistance decreases. See, when we connected in the parallel, in resistors actually, the resistivity will decreases, correct? So similarly, when inductors are connected in parallel form, their effective inductance decreases. The main thing is when we connect in parallel, it's like a resistor, but characteristics are not like resistors. Here the parallel, it is similar to the resistor in parallel. Okay, so here also inductor value will decrease when it connected to the parallel. And what about current and voltage? We will check. Okay, here the current flowing through each inductor will be different. See, current will be different. This current depending upon the inductance value. It depends on inductance value. However, the voltage across each conductor will be the same. See, the voltage, here voltage is same, but current will be differ in parallel. By using Kirchhoff's current law, the total current is the sum of the current through each branch. That is, IT, total current, is equal to current 1, current 2, current 3. Inductors in series. See, in inductors in series, current will be the same, and inductance, the voltage will be changed. When inductors are connected chain together in a straight line, or when they are connected end to end, then the inductors are said to be series connection. We know that when resistors are in series, their effective resistance will increase. So like that, similarly, when the inductors are connected in series, their effective inductance increases. Here 3 inductors are connected in series. In this case, the current flow through each inductor is the same, while the voltage across each inductor are different. This voltage depends upon the inductance value. The Kirchhoff voltage law, the total voltage drop is the sum of the voltage drop across each inductor. See, here is the total voltage is equal to V1 plus V2 plus V3. Here inductors are connected in series, the total inductance of sum of all inductance. Okay. Impedance of an inductor. What is that impedance? AC resistance. Here see, the impedance we call when AC circuit is installed. When AC supply goes through it, then we call it as impedance. See, AC resistance mostly determines the opposition of current flowing through a coil. This AC resistance means resistor, we call it as a resistance, right? But here we can't call it as a resistance. Here we can consider it as a impedance. Okay. This AC resistance is most commonly known as impedance. In this section, see, in case of capacitor and inductor, both will allow the AC, and what it will do, it actually, in inductor I'm talking about, in inductor it reduces the AC and allows the DC. Okay, that is the concept. So in capacitor and inductor we call it as impedance, not resistance. That's why in any motherboard we will check impedance value. We call it as impedance value because PWM section has impedance. That is the reason in multimeter you are checking the impedance. First step of the troubleshooting is impedance checking. Okay, in this section, in case of impedance will be 0, then we consider the coil is short. Correct. So that is the reason here we are checking. In this section, since we are discussing the opposition given by the inductor, opposition means it's a resistance, right? That's called nothing but impedance. This can be called as inductive reactance. Inductive reactance, which is given the symbol XL, is the property in an AC circuit that opposes the change in the current. Current and voltage in an inductor. What will happen? How much induced voltage will be produced by the inductor depends upon the rate of current change. Lenz's law, one more law is there for inductor. Okay, states that the direction of an induced EMF is, means voltage, is such that it will always opposes the change that is caused it. See, the change of voltage that I will show you in the figure. In other words, an induced EMF will always oppose the motion or change we started with induced EMF in the first place. See, it's little bit tough to understand, right, you people? Don't worry, in future you can understand easily. So with a decreasing current, the voltage polarity will be acting as a source. See, with a decreasing current, the voltage polarity will be acting as a source, and with an increasing current, the voltage polarity will be acting as a load. So for the same rate of current change through the coil, either increasing or decreasing, the magnitude of the induced EMF will be the same. So what is that? See here, switch. When you close the switch, voltage till here it will be 0, and when it closed, so voltage will increase till here. When you open this, immediately voltage will become 0. That time inductor current, what it will do till this time, when voltage will be the maximum, current will be 0. When voltage will be in constant mode, slowly current will increase. When current will become maximum mode, then voltage automatically will decrease. Okay, here it will decrease. Here some cutoff, see here time delay will be there to increase the current. Okay, induced voltage, what will happen? See, when here till here the current will be 0. When it will start, then it will negatively it will start. Okay, that's here showed actually. VL is equal to minus L di divided by dt. Here actually this formula is not required for us. So mainly the thing is where we are using this inductor and what purpose we are using. AC through pure inductor. See, one thing you have to observe here, the current. When current will be 0, that time negative voltage will be there. Means it's a minus 90 degree. When the maximum current will be there, that time it's 90 degree, then voltage will become 0. Means it's leading, current is leading here, actually voltage is lagging, correct? So 90 degree. That you have to understand in AC circuits. In AC, inductor opposes the change in current by drawing or supplying the voltage, and hence the inductive circuit, in inductive circuits, when current is maximum, voltage is 0 or vice versa. When current is maximum, voltage will be 0. When current will be 0, then voltage will be maximum. In inductive circuits, current and voltage are out of phase by 90 degree. I already showed you, no? Here is a 90 degree phase will be there. So it will be lagging, voltage will be lagging. 90 degree current will be leading. Purely inductive circuits do not consume real power. See, actually power formula is entirely different, but you can't understand. Later I will explain all the things slowly, but it's not required. Okay, total power consumption in the inductor circuit is completely 0. Now in case of DC, if you're connecting the DC, what will happen? See, up to a level it reaches and current will be constant, but voltage will be 0. It reaches the maximum. It means it will boost the current. It stores the current here. Okay, when there will be no voltage, then slowly it gives the backup. That's it. See, these all are the inductors. This is small one is inductor, this one coil. Okay, in almost all motherboard we have seen these kind of things. Okay, that's it. In motherboard schematic, what will be the coil and where we are using those things, we will check one by one. Okay, now I have taken this motherboard image and schematic also. So slowly we will check where will be the coil in the motherboard. See, we already seen the capacitor and inductors, right? So capacitors and resistors. Now we will identify the coils, how and where it will be there. See, here is the coil. Coil usually mentioned as L. Okay, here is the LV and here PL. Okay, so here PLV, here actually it's a PLV, it's a big one. This one is the coil and here also coil. Okay, here is the coil, and next where here this one coil. Actually here it will it's called as inductor. Here is the coil, and where here is the coil, black color one. Here is the inductor PL is the coil. Here is the inductor. See, these are coil, inductor. Here also a inductor. Actually, what purpose we have used here? Here usually it opposes the AC, means it's not completely oppose, it will reject the AC and it will convert as a DC actually. So for that purpose, means here one side you will get AC signal and other side pure DC signal you will get. How you will get, later on videos you can come to know. Okay, now in this side, here is the coil, inductor over here. No, okay, next image we'll check. In this is the coil, here inductor, here there is no coil, and inductor here is not there. Okay, very less are there. What are the PWM section will be there? There the coil you can able to see. Okay, now we will check in the where schematic. See, here I have opened the schematic. So where will be the coil? One by one we will check. Total 64 pages are there. So one by one we will check. We will go very fast because here register already over. Right, where will be the coil? We are checking only coil. Here it's not connected. No. Usually where it will be connected, that we will check. See, no. See, practically I'm showing you actually where exactly it's available. You have to come to know. See here, no, 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 no. Anywhere here? No. Here, no. That symbol you know, right? Here also a kind of coil actually. Here one coil, okay? This is carrying signal strength. It will increase the signal strength, audio signal strength. See? Here is a signal. This is also a coil. These are coils. Here coil. Usually signal path, audio and LAN, some WAN, those kind of signal where will be the no plus and minus signals. There you will get this inductors. Here supply, no. Where exactly it will be used? One, we confirmed it will pass the signal, means it will boost the signal. Plus and minus, transmission and receiver. See here, coils. Here no coils. No coils. No coils. No coils. No coils. See here a coil. Here is the source. Correct. The main supply DC in and battery. The main DC in will come here 19 volts. Here is a coil, it will boost, it will convert as a electromagnetic energy. Once it completely charged, it will pass through here, boosted signal. So it will manage as a storage device here. Next. No. Here also a coil. See which section it has used. 19V in section will be, actually this is the CLR. Before that a coil is there. Okay, here CLR, a coil. It will boost, that's it. Here also a coil. See, actually here is a MOSFET and here is a MOSFET. Both are dual MOSFET, high-low MOSFET. Okay, total 4 MOSFETs are there. In between this coil has used. What are the purpose this coil will be used, that I will explain in future videos, because that's very lengthy. There's a PWM section we call. In that the coil will roll a major thing. Okay. Now here the coil has used for store the energy as a magnetic energy. That much only we come to know. Correct. Now here also coil. The output, what I told you, know here if any AC signal will generate, then we will get the pure DC here. One side AC signal spikes, other side pure DC signals we will get. So how we will get in PWM section, I will explain you. See all PWM sections, here is the input, just you check the input. Input also coil, that coil what is that inductor I showed you, know that one. Here is the boost one. Okay, here is the boost. It boosts, I mean it opposes the AC and it allows the DC. For that purpose coil has been used here. Otherwise sine wave only will get. Okay, keep it in your mind. Okay, here all PWM sections. Here's input. The PWM section here. Okay, here also coil is 19 volts input and output is 1 volts. See, PWM section coil has been used here. One is supply side, here the supply side, and other one is output side, PWM section output side, because input will have the AC spikes. Okay, output will have pure DC. Here multiple, this also coil, the strength will be more Henry here actually. Here see VCC core, VCC GT, the main voltages it has. Here PWM section, here also a coil, its voltage given. I'll tell you how you have to check this. Here also a coil is output. That's it. Okay, in schematic where the coil will be used, the coil will be used in PWM section and the main supply sections. Okay, in supply section it will boost and it will pass the pure DC, and in PWM section the AC, it will oppose the ACs and it gives the pure DC. That's why one side of the coil will be one side of the coil, pin number 1 will be AC spikes and pin number 2 will be pure DC. Okay, that's it. Thank you very much. Welcome to Pavitra Laptop Care. See, today's video is very important because just now we have seen what are the passive components. Correct. What are those? Resistor, capacitors and inductor. See, here is the inductor, here is the resistors, and these all are the capacitors. Now here these passive components, why they are used here? The maximum number of components are passive only. See, here one IC is there, but IC surrounding almost all resistor capacitors only available, and here big coils are there. Why? What it does? In case of AC, what it gives the output, and in case of DC, what it gives the output. In case of series, and in case of parallel, what the result we will get. Okay, let us check in this video. I have opened the circuit board. So here first what I will do is, first is earthing. One circuit has to be complete, right? So now I will take an example of first passive components, resistor 1K. Okay, 1K, here 1K. Now the source should be there, right? So what source we are giving? Usually 19.5 or 20 volts and 3.3 volts for pull up purpose. Correct. In the motherboard we already seen pull up it will take, say 10K I will take. Usually 10K we are using in pull up. Okay, now I will change the value to 10K. This is 10K. Now in DC how it will react, that also we'll check. See, now I will connect, this is the positive supply and this is the negative supply. Here positive to positive and negative to negative. Here is a circuit. Actually we will consider this resistor as a load. Okay, so here is the positive. Usually how much voltage we will take? We will give minimum 19.5. correct, in adapter, from adapter. So that much of voltage I will give, and what will be the result in resistor? The current will flow or not, in case of open or in case of close. See, now 19.5 volts I will give. So let us check the result. No, because earthing should be there. So here we are connecting the earth here to here and here to here. Okay, now we build a circuit. This is the earth and this one is supply and this one is load. Here is the positive supply and here is the negative supply. Let us check what will be the voltage and what will be the current in a circuit. This is very basic thing but very important thing. Please note down, it's very important point. Here in closed circuit, this is closed, right? See here it's closed, positive to negative through the load. A circuit is completed, then it's called it's a complete circuit. Okay. Now, yes, see, this is a complete circuit. What about the current? See, current is flowing now, because in case of open, current won't flow, only we can get the voltage. Correct. Now current flowing, 1.95 voltage, current we are getting here for 10K resistor. Okay, we will reduce the value of the resistor. So then what will be the current? We will check one by one. We will reduce to 5K. Okay, 5K I reduced. 3.9. See, more current is passing through this resistor. Okay, see, I used only one resistor. Here what happened, 19.5 volts is passing through this 5k resistor. Now we are getting 3.9 milliamps current. Here voltage 19.5, it should be constant. Here it should be 0. Okay, now I'll increase the value of what, this resistor. Now again I will decrease actually. Okay, 1k I will take. What the current value? Now it's a 10k, it's increasing. I'll reduce to 1k. 1k I reduced. What will be the current? See, 19.5 milliamps across a resistor. So this resistor won't bear, so it may get burned in case of more current. See, 19.5. What are the difference? See, if we are using 1k resistor, it's 19.5 milliamps. Now I will use 2k. What will be there? Now I am using 2k. The speed of this electrons, see, 9.75. Lot of difference we are getting. Okay, so this is the major difference. The resistor, if you use the resistor, the main effect for load or current. So now 3k I am using. Now 6.5. See, where is the 9.5 and now it's a 6.5. So once you increase the resistor value in a single resistor circuit, in case resistor value is increased, current value will be decreased, but the voltage will be constant. Okay, so now what I will do, I will make it as an open circuit. Then what will be the current and what will be the voltage? Now I will stop it. So now I will delete this. This is as to connect here. Now it's open circuit. Here we are not getting any connection to ground. Okay, if in case we are giving the ground connection, then only it will consider as a complete circuit. Now in open circuit, what we are getting? Now see, the current won't pass, the flow of electrons won't be there, but your source and destination voltage will be there. Okay, why open circuits are required? The end part will be there. No, that part we will consider as a voltage to some other circuits. So that is the reason here without current we are using the voltage. Okay, the same current if you give to some other circuit, their current will flow. Got it? Okay, now in case of closed circuit, in case of resistance value is increased, the current value will decrease. In case of resistor value is decreased, current value will increase. In case of open circuit, there will be no current. Okay, nothing will operate. Only we can get the voltage. Like adapter also we are getting open circuit only, right? So that positive minus positive and negative both will be there. If you check the multimeter, it's 19.5 you will get in open circuit. Now it's a single resistor. Now we will connect one more resistor, and what will be the result? Here actually 3k. Now I will make it as 1k. Okay, one more resistor I will take. One more resistor I took. What will be the result in open circuit? Current will pass or not? See, always in case of closed circuit, then only current will pass, otherwise it won't pass. Now again I will give the supply. See, here also 19.5, here also 19.5, here also 19.5. So here usually it will be 0. Now I will close this circuit. See, this is very important in laptop service, because in charging section the first MOSFET gate is applicable this concept only. In case of the voltage divider, second in case of P channel MOSFET they are used. In case of the gate voltage is connected to the voltage divider, then the destination part of the R2 resistor should be connected to the ground. But in between there will be a MOSFET that acts as a switch. Once in case that's in on condition, then it will connect to the ground. Okay, it will connect to the ground. So then it will consider as a complete circuit, then voltage divider you will get. See, now I closed the circuit. So here we will get the voltage divider. So what will be the voltage? Let us check. See, now current, here it's 9.75, here is 9.75 milliamps. here is the voltage. What voltage? 19.5 we got in single resistor. Output also we got, right? But now if we using two resistors, in case this one is closed, there you won't get 19.5. In case if it is open, then only you will get the 19.5 volts. Now current is flowing, means flow of electrons is occurred here in case of closed. So now here you are getting 9.75. If you multiply by 2, you will get 19.5. If you increase this resistor, see equal resistor I have taken, okay, equal resistor, here is the voltage divider. In case R1, this one is R1 and this one is R2. In case R1 will be more and R2 will be less, then what will be the voltage divider? That please check carefully. I am increasing to 2K, then what it will be there? See, I am increasing the resistor to 2K. So now what the voltage? 6.5. See, if case R1 is greater than R2, then voltage will be less. Okay, voltage will be less. Now what I will do here, I will make 1 kilo and I will increase the R2 value. Then what you will get? That we will check. I will decrease to 1 and R2 is there, no? R2 value I will increase. So now here is the R2 value is 2K. Now 13 volts. See, in case R1 is lesser than R2, then here the voltage will increase. In case R2 is lesser than R1, here is the voltage will decrease. Voltage will decrease. That is the concept here. Okay. So now you got it right. What is the voltage divider? See, for voltage divider, this is the source path. Source should be connected to the source and this destination should be connected to the R2 source and R2 destination should be connected to the negative path. Okay, maybe through MOSFET or whatever it may be, that should connect to the ground. Then only we will consider it as a voltage divider. Otherwise, we should not consider as voltage divider. Now, here is the 13 volts, right? Here is the resistance, and what we have to do here, the always R1 should be more than R2, then only lesser voltage we will get here. Usually what purpose we are using the voltage divider? In case of AC adapter, you connect the AC adapter, no, to detection part will be there in charging IC, there it will be very useful. Okay, and in charging IC, the MOSFET gate voltage, for there also in case of P channel MOSFET, their gate biasing purpose we are using the voltage divider. Okay, now what I will do, I will increase the value of R1. Always R1 should be greater than R2, then we will get lesser voltage. So now I will increase this to 10K, minimum 10K I will increase. So let us check what value we will get. We will get to 10K, see 19.10K I increased. So what? 3.25. okay, this is the maximum one here, 1:10 ratio. If you increase the resistance value of R1, then you will get approximate 3 volts. Okay, now again I will increase little bit. What will be the voltage? 2.6. okay, got it. So this is called voltage divider formula, I mean voltage divider rule. In case R1 is greater than R2, then lesser voltage we will get. In case R1 is lesser than R2, then greater voltage we will get. Okay, so now you come to know in closed path only the flow of electrons will occur, otherwise no. I will do one thing here, 2.67 we are getting, right? So now I will do it open circuit. Then what will happen? See, now I delete this. Then what the voltage? So here ground has to give. So now I will give the ground. Just a minute. See, I connected here ground. Now here is the open circuit. In each resistor, source and destination, you will get 19.5. okay, now here it's understood the circuit is not completed, then the voltage, same voltage, approximate same voltage you will get. In case circuit is completed, according to the resistor R1 and R2, it will be differ. Okay, got my point? So this is the major difference between closed circuit and closed circuit and open circuit in a in between two resistors. Okay, here usually we will get the voltage divider path. So now resistors over. So in schematic I will show you what purpose we are using here. I mean voltage divider, according to the voltage divider what voltage you will get in future I will tell you. Now this concept is must and should you need to understand. Okay, now we will take capacitor. I will delete this. Again 19.5. Okay, in case of AC, if we are using AC, then what will be the process in resistance circuit? See, AC I will take, for example, 1 kilohertz. See, 1 kilohertz means 1 cycle per second. 1 kilohertz means 1 kilo cycles will pass in 1 second. Okay, that it means. Now I am connecting this AC supply. I'll connect to this. Okay, what will be the result? See, it's a closed circuit. Off when it will be high, then it will pass here, and when it will be low, then it will come to negative path. Okay, now what I will do? Now I will increase the resistance value. Okay, graph I will show you. See, in the graph here it will show like this. Here the blue color one is there, no? Approximate, it will come like this. Okay, I'll reduce the value of the resistor, then what will happen? Let's check. See, almost AC will come in case value reduced, correct? So I will reduce to 0 ohms, then what will happen? Zero, 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 zero. This is approximate 0 volts. First 3, 2, 1, some micro test taken. See, approximate 1 milli ohms. Pure AC you will get. Understood? See, the AC almost all same sinusoidal as per the source. I'll increase the kilohertz here, amplitude. Okay, frequency I'll increase to 8 point something. This is the frequency. Okay, so I told you per second what will be the sine waves. That's called sine waves per seconds. Now it's 8.23 kilohertz is passing through this 1 milli ohms. Now I will increase the resistance value. So what will be the resistance value? I will increase to what? I will increase to 1k, 2 ohms. Okay, 5 ohms, 10 ohms, approximate 10 ohms or 10 point something. See, the current, the flow of, see, the AC is changed and it will be little bit less compared to previous one in only 10.9 ohm. Now I will increase it to 10k or 1k or 2k. Let me check what will be the minimum. So 10k best option. Okay, completely nil, almost all nil. Again it will increase. See the amplitude, the size is varying here actually. If frequency are more, then almost all same frequency you are getting here. Okay, anyway I will increase to 100 or 200 something. Immediately it will decrease and again it will increase. This is AC. Okay, there is no much result we are getting in AC circuits. Correct. See, now what I will do is AC won't work out in resistor. Okay, now I will pause it. I will make it as open circuit. Then what will be the result? So here I will connect this earthing. This is open now. So now what will be the result? See, AC will come to here only. It will be open circuit, but here instead of DC you will get the AC voltage, but current won't be there. Okay, clear? Now AC and DC in resistor over. Now we will check in capacitor. I will take capacitor now. So 1 microfarad capacitor. I'll connect to, first I'll connect to DC. Okay, DC. See, the waveform and this diagram is very important to understand the schematic. Okay, so please give some concentration. I am slowly explaining all the things. Here is the capacitor. Capacitor circuits. Okay, incomplete circuit in DC. I'll give what voltage? 19.5 volts DC. What will be the effect result? 19. 19.1, 2, 3, 4, 5. Okay, I have given here 19.5 volts DC. Then what will be the voltage? See, here it's not passing here. This is the most important thing. Please note down. Here it will charge, that's it. Positively it will charge. But here negative side always it will be ground. We are using coupling capacitors, right? So coupling capacitors, here it will charge as a positive and here negatively charged, but here it will be 0 and here the voltage won't pass through this capacitor. Okay, now we will connect, what is that? AC. Okay, first we will check in series capacitor, what will be the result. Now one capacitor we use, right? So one more we will take in series. How the DC will work? Here is the circuit. I have taken 1 microfarad, 2 capacitors. What will be the result? 19.5 volts. See, here you can get 19.5 volts and here some of the internal leakage or internal circuits you will get 9.75 volts. Not exact one, some voltage will be variation, will be there. In case 2 capacitor, if you are using in series, definitely you will get some voltage in between these capacitors. Okay, so now the capacitor, 2 capacitors if you are using, here is the main voltage, here some sub voltage and here is the complete 0 voltage. Now I will do one thing, one more capacitor if possible I will take. Yes, we can take it. It's a series. Okay, in series it will increase or decrease. I already explained multiple times. Now directly practically I am showing. See, now I will give the supply. Here. See, here little bit, here little bit. Now here it's a 13 volts and here is the 6.5 volts. If you are using only 2, here will be the 6 point something voltage and here now it's a 13 and something. So now you got it, right? So always positive, negative only we can get. But here negative positive will be there some internal voltage leaky or some charging due to the charging capacity, some voltage you will get it here. Okay, in case of parallel, in DC, in case of parallel, what we will get? So here, I'll delete this. Delete. Okay, parallelly I will connect this. I'll reduce here the size. Ground. Now I'll connect 1, 2, 3. Even resistor I didn't show you, but resistor also I will show you. Okay, now parallelly I have to connect. All source should be source connection. The destination should not be connected to the source. That's called parallel. See, now parallelly connecting. Okay, this is the circuit. 1, 2, 3, three capacitor. In case actually in all laptop motherboards we are connecting the capacitors in parallel, not in series, correct? Only the resistors we are connecting in series, almost all. So now I applied. What voltage you are getting? Here there is no current, but till year to year 19.5 volts only you will get. Here completely zero. See the filter capacitor, the bypass capacitor you are using now, one side should be 19.5, other side should be 0. There will be no voltage variation, no current at all. Okay. So it means it should be purely, in case AC, then only current should go to ground. But here AC not there, pure DC is there. In pure DC case, the capacitor will charge up to their level 1 microfarad, and then it will oppose the current. Okay. So now you got it right. So now AC I will put. Why the capacitor will be used? It is connected to the ground because in case any AC will come, that one it will absorb. And second thing, in boost capacitor, it will be connected to a resistor. It will boost from beginning to other end. That also I will show you. Now we'll change the supply path. Supply AC I will give. Now I will connect the AC supply, the ground, the positive. See now AC how it will react. See here I will show you this path waveform how it looks and this waveform how it looks. Two waveform I am showing you. See here is the 0 1, it's connected to the ground, and here is the AC one. Correct. What AC case, in case any distortion current will come through the circuit, that 19.5 DC we got, right? In case any AC will come, directly it goes to ground. Okay. Now the main purpose of the capacitor we are using is bypass. AC it will bypass to the ground. Okay. Now you understood, right? So now it's very important, this point. In case of AC it will oppose, in case of DC it will oppose, but in case of AC it allows to ground. Now what we will do, now we will disconnect this. We will connect a resistor. Now resistor I took. What will be the result? First we will check in DC, because 19.5 only we are getting, we are giving, right? So now I will give the supply 19.5. 19.5, here is the ground. Okay. So here positive and here negative, because capacitor is given to ground. Okay. Now this one is ground. In this circuit, here little bit charge will be there from negative, see, negative to positive. So now graphs we will check what it looks. Here green one is 19.5, here is the grounded one, so it won't show anything, because in this case, in case resistor and capacitors will be used in a circuit, it gets charge. Okay, it gets charge, see, it's charging, and once it completely charged, it will oppose. The electrons won't pass to this. It is the attraction of negative, and here is the positive attraction. Understood? See, the electrons will try to move here, but we can't. It can't. Okay, up to 1 microfarad it will charge. Once it charge, it will rotate here itself. Understood? Okay, I'll do one thing. One more thing is there, no? What is that? Coil. I will add a coil. So in DC circuit, what coil role? Individual also I will show you. Now RLC circuit. In this circuit, usually capacitor will come to the ground, and here coil resistor. In case of feedback, we are giving this kind of circuits, correct? So now here is the 19.5, here also 19.5, and here what will be the graph? Okay, that also, see, the graph, orange color graph is this one, and here the capacitor only, it's little bit blinking, but anyway charge and discharge will be there up to positive path. Okay, now for this I will give AC supply. Now what will happen? 1 kilohertz AC supply. Now I connected ground. Here is the positive side. See, now what will happen? In inductor the load here, blue color one, so 1 made. Here I'll show you. Here is the red one, so red one will come here. Okay, the same, almost same voltage will come to this part. Okay, and here because of 1 kilo ohms resistor, here amplitude got reduced, and again here the capacitor will charge little bit, but actually it's a 0 only. Okay, charge and discharge will happen here. So this path already showed here. It's a blue color one. Okay, here is the green color one, this one, and red color one here. Okay, that amplitude will change in RLC circuit. It means almost all filter. Correct. See, here it came here, and after this it got filtered here. Some high frequency or some low frequency it will get filtered. Now what I will do, I will remove the capacitor. So then what will be the result? I removed, I connected only resistor and inductor. I am giving the AC supply. So now blue color one, here is the negative, right, 0, and here this one I will this is already running, and here is the red color and this one is orange color. Okay, so same thing, nothing change. Now what I will do is I will disconnect the resistor. I will connect only the coil. Short, see, voltage source is short, so that's the reason the coil, the main coil won't connect to the ground directly. It acts as a direct conductor because it's a conducting part, right? See the twisted cable, so that directly it will connect to the ground, means directly whatever the source will come, directly it will get short. So now what I will do, I will connect only capacitor. Then now in capacitor, before and after this coil, what will be the result? Okay, see, here a capacitor I will use. I will connect to this, connect to this. I already connected resistor and inductor, nothing, no changes, right? So now here and here what changes will happen? Here is a 19 something, okay, 19 usually. Here also one more green color, both are same here. Here capacitor 1, negative 0. Okay, here is the green one, normal sinusoidal waves is appearing, and here orange color one directly 0, nothing is there. So now what I will do, after this capacitor I will put a resistor. What result we will get? So now resistor I will put. So please try to understand this. It will be little bit boring, but it's very, very important to understand the circuits. So now a resistor is connected. Then what will be the result here and here? See, the blue color one, now green color one, and now just point I am showing, right? So here capacitor 1, and here inductor. See, inductor, it's lagging 90 degree. Okay, see, here is the main source, the green color one made. Here inductor is orange color one. See, 90 degree it's lagging actually. After that capacitor, it's a green color one. Okay, orange, actually inside this orange and green both are equal, but here 90-degree phase shift will be there when you are using what is that, coil LCR circuit. Okay, it looks like this LCR circuit, 90-degree lagging. Okay, then see in one end it's connected here. Okay, now what I will do, now capacitor I will put before this coil. Okay, otherwise coil I will put after these two, then what will be the result? So now I will disconnect this, now this path also I will connect it here. This is the source and here and ground. Okay, now what will happen? First capacitor I connected. Here is the orange color one. Now it's a resistor. See, now before this capacitor will be there, no? Capacitor and inductor both will be, phase shift will be same. So these all are called reactance. That's a impedance, nothing but impedance. So in motherboard we are checking the impedance because it works in AC almost. Here is the resistor value. See the resistor value, 90-degree lag. Okay, so slowly it looks like this, and after that came straight. Okay, there will be a point, charging point, then it will act as a pure DC. Okay, now in open circuit, in case this one is open circuit, after this coil what voltage or what thing will get? Nothing. Okay, now directly DC I will connect, DC circuits. Here is the 1 volts, right? So I will make it as 19. 19.5. Okay, now let us check. All are same, but no current, because here last one you are connected to ground. That's the reason. Should be open. I will keep it as a open. Now in open, see some spike first came, after that completely zero, nothing. 19.5, 19.5 you will get. Here is the voltage, here also same, here also same thing you will get in all positions. Something happened here. Okay, so first capacitor should not be connected to the series. Now I will connect it to parallel. Then what will happen? See this one, I will rotate it. Okay, now it will goes to ground, and this one is continuation. Just a minute. This one ground, this one is ground. Here is the positive one side it has connected, negative one is ground. Now this coil, okay, let it be open circuit. Now let us check anything, any changes. Because of DC, so DC only will get till here 19 volts. See, after the coil and before this resistor, anywhere you go, so 19.5 something you are getting. One minute. Now I will connect AC supply. So what will be the result here? So here is the AC. Now I won't connect here, only positive side I will connect. This is negative side and this one is positive side. See something happening here. Capacitor will charge and discharge. This is the one capacitors one. Here directly DC 0 amps, nothing will be there here. After some times phase may change. Okay. Here this path I am showing here. This is capacitors one. Here it's coming, so here also it will come. But anyway, anywhere you go, here actually coil will have 90-degree phase shift in case of AC. Okay, that's it. So here is the graphical representation of RLC circuit in case of AC and in case of DC. Okay, now in laptop motherboard, how it will be connected. See, just one or two I will show you, then you come to know. Okay, here is the resistor. Here usually 3.3 volts will come, correct. So here 3.3 volts, it will pass here 1K, and here also you will get 3.3 volts. In case of this circuit is completed, then little bit less you will get. Okay, that much only. Here for protection, it's a high, any spikes will come, no, that time it will protect from those spikes, those high frequencies. Okay, AC or whatever it may be. So now here see where usually the resistors will be used as a pull up, right? Here 3 volts will come. In case this is open, here also you will get 3 volts. In case here you have some resistance value, 2.2 resistance value, in case of complete circuit, then little bit lesser current you will use. I mean you will get only voltage you will get in case if it is open. That's it. Okay, the concept is very clear. In case of capacitor where we used, in case of signal only the capacitor will be used full to boost the signal. I'll show you where exactly it will be used. Here is the bypass, always will be connected to the ground, and in case of signal bypass, already showed in what is that, capacitor chapter, right? So here is the something called its bypass, but boost in case of signal only you will get. Okay, using this schematic in future I will show you. Here not there, here also not there. Okay, anyway I will show you how it will pass the signal, how it works as a boost capacitor. That's it. So today little bit confusion, so no issues. So each and every circuit I will show you how it will work and what will be the result step by step. Okay, this is just introduction. Consider it as an introduction part. In future videos completely you come to know what reaction will be there in case of AC and DC in a circuit, in RLC circuit. Okay, in next we'll start active components one by one. Thank you very much. Welcome to Pavitra Laptop Care. See, today's topic is very important because it's active components, one of the major components in the laptop motherboards we have seen. Okay, so the main means it's very few only, but the work functionality of this particular ICs or particular component is very important. Okay, why we are using active components, let us discuss in this video. Okay, this is active components. What is that? Active components, in electronic components, active components are electronic devices that needs an external power sources to operate actively. Okay, it requires external power source to operate. They mainly manipulate, amplify, switch or control the flow of electron current or voltage in a circuit. See, the circuit, to build circuits, now onwards you need to give more concentration on circuits. See, using these ICs, using the active components, we can build a circuit. Okay, we can build circuits. See, this component receives external power supply, and what it will do, it will manipulate, amplify or switch or control the flow of electrons or flow of current or voltage in a circuit. Okay, in open circuit it will amplify the voltage, in closed circuit it supplies the current. Okay, active components like diode, transistor, integrated circuits, ICs and sensors require power to do their jobs. See, in any IC required external power supply. Okay, A circuit is an interconnection of components, means it contains multiple components inside it. Okay, these components are capable of performing active functions like amplification, rectification, and switching. The switching on and off. Rectification, it's AC to DC converter or something. Amplification, for example, 5 volts to 12 volts, 10 volts, 20 volts, like that. Switching, they are called active components. It means the component which controls or it amplifies the current, which has capability to increase or decrease or control the power. Those components called active components. But in passive components, these kind of activities, those things won't do, because it can reduce the voltage or current, but it won't increase the current, or it won't controls the power. That is the main difference between passive components and active components. What are those active components? Diodes, transistors, MOSFETs, and ICs. Okay, those are the main thing. Characteristics of components. See, active components requires an external power supply to operate. Active components produces energy in form of current or voltages. See, if it requires external power, and what it will do, it produces energy in form of current or voltage. Components can power gain in electric circuit. It may increase or decrease. It may increase the power in a circuit. Active components can control the flow of current. So, for example, current is 1 milliamps. For example, it reduces or it controls by 500 milliamps. Those kind of things. 0.500. Okay. See, active components receives energy in the form of thermal energy, chemical energy, hydraulic energy, and delivers in the circuit in the form of electrical energy. See, the circuit, it builds a circuit, it receives any kind of energy, and it supplies electrical energy. An active component works as an alternative current circuit in a device which works to increase the active power, voltage, or current. See, an active component works as an alternate current circuit in a device. It's an alternate current circuit in a device which works to increase the active power. Means, for example, 5 volts is the power. It may increase to 10 volts or some other volts or current. An active component is able to do this because it is powered by a source of electricity that is separate from the electrical signal. Okay, it receives the energy. Okay, that is separate from the electrical signal. Signal is entirely different thing, but it receives the energy. Therefore, active components provide electrical power or power amplification in an electric circuit. Some common examples of active components are diodes, transistors, integrated circuits, etc. See, the main part is you need to understand what is diode, what is transistors, and what is IC. Those subparts, because these are very important components in motherboard. Now, what are the active components? One is diode, transistor, MOSFET, integrated circuits. Diode, let us discuss about diode. What is that diode? See, diode is a unidirectional. Diode is one-way valve for electricity. The valve, you know, right? One-way valve. It allows one side to other side the electricity current. Okay, but it won't allow from opposite side. Diode allows the current to pass through one way if it is forward biased. The anode with the positive terminal and cathode with the negative terminal, and it prevents it from passing when it is reverse biased. See, this is the diode symbol, this is the positive side and this is the negative side. It allows the current from anode to cathode, positive to negative, but it won't allow negative to positive side. Diode consists of semiconductor materials, either silicon or germanium. How it made? It's a silicon part or it's a germanium part. It is a two-terminal semiconductor device, which two terminals are called anode and cathode. Okay, here is the anode and here is the cathode. It lets the electricity to flow only one direction. Okay, most diodes have pointed line on one end showing the direction of flow. See, here is a pointed line. So it will show the direction. The negative side is the normally white. See, this is the negative side. So normally white color. So current flow through diode only when positive voltage is applied to anode and negative voltage is connected to cathode. See, always when we connect the supply, positive supply is to the anode and cathode is a negative supply, then only current will flow. If these voltages are reversed, then the current will not flow. Okay. In case of reverse direction, here is a negative and here is a positive, then current won't flow because of opposite direction. Application. See, what are the solar panels they will use, voltage spikes they will use, the AC to DC converter, unidirectional flow of current. See, they are used to allow an unidirectional flow of current in the circuit. They differ by its power and how much current it can handle. See, depending on the power handling capacity, the partition of the diode we can use. Okay, they act as an electric check valve and convert alternative current into direct current. The AC to DC conversion, main part is AC to DC conversion. It will be very useful. Types of diode. Classification of diodes according to their application and characteristics. Different types of diodes are available in various applications. Diodes are broadly classified into two types. What are those? One is PN diode that are based on the PN junction. See, P-type and N-type semiconductors. These are common diodes, normal diodes. Second one is metal semiconductor diodes. Commonly, we call it as Schottky barrier diodes or SBDs for short form, that are formed by the junction of a metal with either an N-type or P-type semiconductor. Figure shows the classification of diode according to their application characteristics. See, this is the figure. So here is the PN junctions and here is the metal semiconductor diodes. What are those PN diodes? Rectifier diodes, switching diodes, general purpose diodes, super fast recovery diodes, high efficiency diodes, Zener diode, Zener diodes, so TVS diodes, it's a ESD we call. Okay, it's actually power production, it's a spike buster, we'll use it. Variable capacitance diode, RF switching diodes, these all comes under PN diodes. Metal semiconductor diodes, what are those? It's a Schottky barrier diodes, SBDs. Okay, RF Schottky barrier diodes. Now shows the classification of diode according to their internal connection. See, the diode, the symbol shows single or composite. In case of single, see, it looks like this. It's a anode and here is the cathode. In composite side, center tapped or common anode. See, here is the common anode in center tabs. One is the common anode. Here two anodes are common. Both cathodes are separate. And common cathode means here two diodes cathode are same and two anodes are separate. Series. See, here is the positive negative and here is the positive negative. It is in series condition. Independent diodes. See, both are is not connected, both are independent. Classification of diodes according to their internal connection. Now Schottky barrier diode. See, this figure shows in depth of Schottky barrier diodes. Schottky junction figures shows the structure of a Schottky barrier diode. A Schottky barrier diode is a type of diode formed by the metal to semiconductor junction that behaves as a rectifier. The Schottky barrier diode is named after Walter Hans Schottky. He is the scientist, actually. He is the main person. By his name only, this what is it? The phenomena, what the function of this as found by this person. So that's why it is named as Schottky. In SBD, Schottky barrier diode junction is formed by a deposited metal and an N-type semiconductor. In depth, we can teach in some other days, but generally you have to understand what is Schottky diode. These are the constructions. You need to go through of this. If you want depth, so you can see this page. This also, in case of forward bias, how it will act, and in case of reverse bias, how it will act. Zener diode. See, Zener diode differ from the typical rectifier and switching diodes in that they are used in the breakdown region in which the reverse characteristics of the PN junctions are stable. See, the Zener diode is very important diodes in case of reverse conditions. See, the majorly this diode used in reverse applications because it will control the current. See, the threshold voltage will be there. No, it reaches threshold a particular level, then the voltage will be constant. So that we will discuss later. Typical diodes cannot be used in the reverse breakdown region unless it is a specified noted that it is a permissible. The normal diodes we can use it as a reverse diode because it blocks the opposite direction current. But Zener will work with the reverse condition. Okay, reverse condition it will work. The breakdown phenomenon which might cause current concentration resulting in the destruction of the PN junction. In construct, Zener diodes are designed in such a manner that current does not concentrate locally at the PN junction. The breakdown characteristics of the Zener diodes are determined by the dopant profile in the vicinity of the PN junction as well as its shape and surface conditions. Therefore, Zener diodes with different breakdown voltages can be designed by changing these conditions. For example, see 3 volts Zener diode, 5 volts Zener diode, 10 volts Zener diode, depends on the voltages the Zener diodes are made. See, if we are using 3 volts in case of reverse condition, we are using reverse condition only, right? If more than 3 volts, what are the voltage will come? It will cut off. So it allows only 3 volts in reverse direction. This is the example I am giving. Okay. Zener breakdown and avalanche breakdown. See, in Zener diodes, there are two kind of breakdowns are there. The operation of the Zener diode can be explained by two phenomena. One is Zener and second one is avalanche. Zener breakdown and avalanche breakdown exhibit different temperature characteristics. See, the temperature characteristics, according to the temperature characteristics, the voltage will vary. How it will vary in Zener and avalanche? Let us discuss. The Zener breakdown voltage decreases as temperature increases, whereas avalanche breakdown voltage increases as temperature increases. See here, what will happen in Zener? In case temperature increases, voltage will decreases. Here, temperature increases, voltage also increases. This is called avalanche breakdown diodes. See, this is very, very important. According to the temperature, it will work. See, in case of temperature decreases, Zener voltage increases. Temperature increases, Zener voltage decreases. But avalanche breakdown, so temperature increases, voltage also increases, and temperature decreases, voltage also decreases. Zener breakdown. See, the explanation has given here. If you want to go through this, so you can read all the things. So here the avalanche breakdown. Zener diode for reverse voltage protection. See how it will protect the circuit. Zener diodes are suitable for protecting power supply lines, power supply control line, and can protect internal circuits and ICs from over voltage induced by hot plugs, etc. The spike buster. See what will happen. The power supply lines is susceptible to static electricity (ESD) as well as other over voltage pulses and must be protected. See, in any circuits, the electricity will cause over voltage or some pulse will generate all of a sudden, right? So it may not be clear why a circuit broke, but it is often the case that the cause was an over voltage such as switching off inductive loads. See, when you turn on the switch, that time the spike or over voltage will generate. Due to that, the circuit will get breaks. Zener diodes make it easier and safe to protect circuits and ICs. See, without Zener diode, here is the 15 volts, 2 amps supply is there. No, when switches connect, a spike will generate all of a sudden because of the wear and tear. All of a sudden, it will turn on. No, that time immediately spike will generate. That spike may damage this IC because the IC capacity will be 20 volts. If it comes more than 20 volts, means all of a sudden 29 volts will come, then IC will get burned because the cutoff voltage of this IC will be, capacity of the IC will be only 20 volts. See here, if Zener diode is used, then it will cut off all above 20 volts things. See here, all above 20 volts it cut off. So it gives maximum 20 volts only. So this is the major work function of this Zener diode. Transistor. Till now the diode part is over. Diode has, it may have 3 leg or 2 leg. Actually positive to negative only the current flow. In case of Zener diode, negative to positive it will flow. We can use it as a reverse direction. Now the second largest active components is called transistors. Okay, transistor is the most important invention of the last century. Its invention led to the advancement of electronics in a large and amazing way. Transistors amplify and switches electronic signals. The main thing is to pass the signal, or to amplify the voltage or signal. This transistor has to be used. Here what it will do, transistors amplify and switch electronic signals. The transistor amplifies, connects and disconnects electrical signals, acts as an electronic switch. It's called electronic switch because it will pass or disconnect the signal. Transistors are able to amplify the power of a signal. It has that much of capacity. It will amplify the main voltages. See, bipolar junction transistors, in which include NPN and PNP, are further classified based on their applications and characteristics. See, here actually two types. One is NPN transistor and other one is PNP transistor. See, NP and PN, these are called diode actually. One more, if we add, the doped level will be added, one more, then it called as a transistor. So total 3 terminals it has. So the two types of transistors are NPN and other one is PNP. The NPN transistors is commonly used for the amplification and switching in electronic circuit. It is named after the arrangement of its layers. N-type collector, it has 3 terminal. One is N-type collector, P-type base and N-type emitter. PNP transistor also used for the amplification and switching, but with the opposite current flow compared to NPN. See, here is a example of transistor. Okay, base, collector, emitter. Application of transistors, they are used for amplifiers, digital logic circuits, voltage regulators, logic circuits, temperature control systems, converters, automatic switches. See, E represents emitter, B represents base, C represents collector. See, emitter, base, collector. Difference between NPN and PNP transistor with interesting facts. Transistors are one of the most important electronic components used in the wide range of applications. NPN and PNP transistors are two common types of bipolar junction transistors used in electronic circuits. These transistors are used as switches and amplifiers, and understanding the difference between them is important for anyone interested in electronics. See, the NPN and PNP transistor, why it has used. So it's very important to note in a circuit. What is PNP? See, this is the PNP. I told you, no, it's a NP or PN are the just like a diode actually. These are diodes. Here what will happen, in between two N channel doping, in between only one P dop will be there. That is a base actually. N is the emitter and here N is the collector. In between base will be there, that is the holes. Here is the electrons and this one is the holes. How does it work? So here, based on the voltage applied to the base. See, if positive voltages applied to the base compared to emitter, compared to collector, it should be more than collector voltage. Means it's a positively supply applied to the base, then here it acts as a negative and all will be connected to each other and the current will flow in one direction, from where to where, collector to emitter. Okay, so now when a voltage is applied to the base emitter junction, it forward biased the junction allows a current to flow from the emitter to base. This current flows through the base and into the collector, where it is amplified and flows to the output circuits, which I told you, collector to emitter. It will flow when the voltage given to base, the positive voltage given to base. This is same ulta in PNP transistors. See how the NPN transistor will be applicable. See, this one is NPN transistors are commonly used in amplifying circuits, switching circuits, digital logic circuits, signal processings. Used in audio, amplifier, radio, receivers and digital circuits. Advantages of NPN transistors. The advantages of NPN transistors are shown below. High gain, high input impedance, low noise, fast switching speed, low cost, easy availability. Disadvantages. The disadvantages of NPN transistors are shown below. Poor performance in high temperature environment, low breakdown voltage, relatively low power handling capacity. See, it won't handle much voltages. See, what is PNP? That just opposite to this. See, the current will flow from emitter to collector when there is a negative voltages given to base. There should not be voltages in the base. About this NPN and PNP transistor in future classes I will explain you deeply. Okay, just general purpose here, base will be negative and base will be positive in NPN and base will be negative in PNP transistors. The application of PNP transistors used in amplifiers, switching circuits, digital logic circuits, power supplies, motor control circuits, and audio amplifiers. Advantage of PNP transistor. The advantage of PNP transistor as shown below: high gain, high input impedance, low noise, fast switching speed, low cost, easy availability. What are the disadvantages? Poor performance in high temperature environment, low breakdown voltage, and relatively low power handling capacity, both NPN and PNP transistors. Similarity, both transistors are BJT. Okay, both transistors are used as amplifiers, switches, and signal processors. That's it. So this is the major difference between these two. The P doped here, actually in NPN is a P doped sandwiched between two N doped materials. Here N doped materials is sandwiched between two P doped materials. Majority carriers are electrons in NPN, and here is the holes. The directions of current flow from collector to emitter in NPN and emitter to collector in PNP. So based on made up of thin layer of P-type semiconductor materials, base in made up of thin layer of N-type semiconductor material. Low power and high frequency applications. Here high power and low frequency applications it has been used. Here commonly used in amplifier, oscillators and switching circuits. Here power supplies, voltage regulators and audio amplifiers PNP has used. Higher electronic mobility than hole mobility. Higher hole mobility than electron mobility. Requires a positive voltage at the base relative to the emitter to operate. See, positive means what are the collector voltage is there, more than that collector voltage is as given to base part, then only it will work. Require a negative voltage at the base relative to the emitter to operate. See, the main thing is here emitter to collector the current will flow. What are the voltages are there in emitter? So negative voltage has to give here. Okay, one common used in digital circuits as a switch, commonly used linear circuits as an amplifier. Electrons flow from emitter to collector. Here holes flow from emitter to collector. Here is the electrons and here is the holes. So switching is done by applying a positive voltage to the base. Positive voltage, I told you, here is a negative voltage. Here circuits that required negative voltage and circuits that required positive voltages. Enhancement MOSFET working principles. This is also very, very important, because without these MOSFETs we can't do anything, because the PWM sections will use these kind of MOSFETs. Enhancement MOSFETs we are using. Enhancement MOSFET. A MOSFET, metal oxide semiconductor FET, this is also a kind of transistor, but it contains metal oxide semiconductor FET, is one kind of field effect transistor with an insulated gate that is mainly used for amplifying and switching signal. Now in analog and digital circuits, MOSFETs are used more frequently as compared to BJTs. So we are using most of the components as MOSFETs. MOSFETs are mainly used in amplifiers because of their infinite input impedance, so it allows the amplifier to capture nearly all the incoming signal. The main benefit of MOSFET as compared to BJTs is that is required nearly no input current from controlling the load current. MOSFETs are classified into two types. One is N-channel and here is enhancement MOSFET and depletion MOSFET. Actually, we will discuss more than this depletion. That enhancement MOSFET is very, very important, because in laptops we are using this enhancement MOSFETs. So what is enhancement type? The MOSFET which works in enhancement mode is known as E MOSFET or enhancement MOSFET. Enhancement mode means that whenever the voltage towards the gate terminal of this MOSFET increases, then the current flow will be increased more from drain to source until it reaches the highest level. This MOSFET is the 3-terminal voltages controlled devices where the terminals are source, gate and drain. The features of these MOSFETs are low power dissipation, simple manufacturing and small geometry. So these features will make them used within integrated circuits. There is no pathway in between the drain and source of these MOSFETs. When no voltage is applied in between the gate and source terminals, so applying a voltage at gate to source will enhance the channel, making it capable of conducting current. This property is the main reason to call this device an enhancement mode. See, when you are getting time, that time slowly you can read, then only you can understand those things. Just a simple introduction I am giving here. So in future classes you come to know what is the enhancement MOSFET and how it will work and what are the usage. Okay. Enhancement MOSFET. See, this is the enhancement MOSFET. It has two types. One is P channel and one is N channel. What are those? Here the gate. It has 3 terminals: drain, source and gate. The arrow mark inside, if it is the middle one arrow mark are inside, then it's called as N channel. In case of P channel, the arrow mark will be outside, it will be there. Okay. Drain to source will be forwarded, and here drain to source will be opposite direction. So that is the indication of N channel and P channel. We will discuss more about these things in future classes. See, these are the constructions, how it will work. For your knowledge purpose, I am giving these notes. You can slowly read it. So working also, aram you can read it, this page. Types of enhancement, already told, N channel and P channel. See, what are the major difference here? N channel MOSFET and P channel MOSFET. N channel MOSFET are used electrons and charge carry. See, in N nothing but electrons, right? Negative charged. So here is the negative, means it's the electrons. P channel means holes is the major carrier. So generally the N channel goes to the ground side of the load. In case if it is using as a switch, so usually N channel goes to the ground sides of the load. Generally P channel goes to the VCC. Here is the power side it will go, and here is the ground side it will go. This N channel MOSFET activates once you apply a positive voltage to the ground. See, positive voltage in the sense, so it will from drain to source it will pass, right? The voltage will pass or current will pass. So what are the voltages in collector, drain part? There actually, for example, you have only 10 volts. Then gate is required more than 10 volts, more than main source volts. Okay, that's called positive voltages. So the P channel MOSFET activate once you apply a negative voltage. Negative voltage in the sense, for example, in case of actually here source to drain is opposite side, right? So means drain to source it will be forward, and source to drain will be opposite side. The source, what are the voltages it has? So lesser than that voltage you have to give to gate. Then only it will act. In case of same voltage if we give, so it will be in off condition. This MOSFET is classified into two types: N channel and N channel in depletion and enhancement. Okay, here also P channel depletion and enhancement. There are two types, but we are discussing only the N channel enhancement MOSFETs. N channel circuits. A type of the MOSFET includes see the 3 terminals what I explained already. So it is there here. So when it will be on in N channel, so you have to give more voltage than the drain in N channel. Okay. In case of P channel, we have to give lesser negative voltage compared to the source. Working, here is the N channel symbol. See, this is very, very important. Here is the gate and here is the drain to source opposite direction. N channel, this is the identification. Please note down. Here arrow mark goes inside to the gate and one more arrow mark goes to the drain, source to drain. This is the major indication. Drain to source, it will be opposite in N channel. See, these are the working principles, how it will generate, how we can test that also it has given. I will show practically once we do the practical things. So this are application. The application of the channel N-channel MOSFETs includes the following. These MOSFETs are frequently used in low voltage devices applications like a full bridge and B6 bridge arrangement using the motor and DC source. These MOSFETs are helpful in switching the negative supply for the motor in the reverse direction. An N-channel MOSFET operates in saturation and cutoff region. Then it acts like a switching circuit. These MOSFETs are used to switch lamp or LED on and off. Okay, these are preferred in high current applications. See, this is the P channel MOSFET just opposite to the N channel, means the arrow mark going towards the drain. Towards the source, sorry. See, opposite side of the N channel. Here, get to source, it's moving, and here, source to drain is the opposite direction, and drain to source is the forward direction. That's the P channel MOSFETs. We'll discuss more. This is working the types of P channel MOSFETs. Okay. This is testing method. Now, the main part is IC. IC in the sense integrated circuits, types, functions and uses in electronics. An integrated circuit is a semiconductor device that contains multiple electronic components such as transistors, resistors and capacitors, all integrated onto a single chip. See, this is very important thing. In one chip, it contains multiple semiconductor devices such as resistors, capacitors, are transistors. Here active components and here positive components, both it included in a chip, single chip. These components work together to perform various functions such as amplification, signal processing and data storage. See, to store a data, see if I tell zeros and ones, so those things it has to be stored. So those things stored by an IC, a chip, single chip. Single chip, what it contains? It contains multiple active and passive components. The circuits, it contains circuits, okay, internal circuits. ICs are fundamental to modern electronics, powering everything from smartphones to automatic to industrial and medical machinery. An integrated circuit is a miniature electronic device made up of various electronic components such as transistors, resistors, capacitors and diodes, all fabricated onto a small semiconductor metal, typically silicon. These components work together to perform specific functions like amplification, signal processing and logic operations. See, logic zeros and ones means on and off logic. Amplification means signal improvement developments, and what is that? Amplification, signal processing. The signal it will process. Okay. So constructions of an IC, how the IC will be manufactured. See, here internal structure of an IC. Here the silicon chip. Okay, the chip contains multiple circuits, means multiple components, active and passive components. Here is the plastic case and here are the pins. Okay, the components used in the construction of an IC are not visible from the outside. Okay, they are built into a semiconductor chip and cannot be removed. Capacitors with values greater than 30 picofarad are typically not used in ICs, and inductors and transformers are generally not mounted inside the chip of the IC. See, inductors and transformers are generally not mounted inside the chip of an IC. Thousands or even millions of bipolar transistors. See, the main concentration, what is that? Transistors and complementary metal oxide semiconductors, MOSFETs, are used in the fabrication of an IC. Okay, you got it right. So inductors and transformers are not used in the IC. Thousands, millions or billions of transistors or MOSFET are used in the IC. How it will manufacture? Sand, silicon, wafer and chip. See, wafer fabrication, how it will manufacture, that an introduction it has given here. Here, see how it will manufacture. It will start from here and it ends like packaging. What are the packaging? In depth we'll see. So now, types of integrated circuits, their functions and common uses in electronics. See, the types. What are the types? One is analog ICs. It's a process continuous signals, audio and video equipments, sensors and power management, we can use it. These are the function and these are the common uses. These are the types. Second one is digital IC. So in digital IC, what it will do? Process binary data. So zeros and ones it will process. Where we can use? You can use it in computers, smart phones and calculators. Mixed signals. Mixed means analog and digital. Combine analog and digital functions. Data converters, RF signal processing, communications. Power management IC. Power management IC requires by converting and regulating the voltages. Manage power requirements. Battery operated devices, smartphones, laptops and automatic electronics. RF IC. Process high frequency signals for wireless communication. Smartphone, Wi-Fi, routers, GPS systems. Systems on chip. See, this is very important. System on chip. Integrate all components of an electronic system onto single chip. Smartphone, tablet, embedded systems we can use. Applications specific ICs. See, you need some specific ICs, then it's a custom IC, custom designed for specific applications. Cryptocurrency mining, automotive controls, medical devices. Okay, it's a custom one. How you want, how to design this, depending on that they will design and they will give different types. This is analog function analog ICs. See, it looks like this. Usually it will be used in audio and video equipments, sensors and power management. Digital, zeros and ones. Okay, smart chip calculator. Just now we discussed. See, it looks like this. Both it mixed like this. Okay. Here power management IC, you have seen our charging IC, looks like this only. It's IO also, it's a power management IC, PM IC we call. Okay, power management IC, power requirement of electronic systems by converting and regulating the voltages. Usually battery operated devices, smartphones, laptop and automotive electronics. RF signals, see the wireless communication like a smartphone, Wi-Fi routers and GPS systems. Here system on chip, see it looks like this. It won't has external legs, internal legs only. It contains SOC. SOC we call. SOC means system on chip. System on chip SOC. Nowadays processor also SOC. It includes PCH also. SOC, SMT components, electronic systems on a single chip. Commonly used in a smartphones, tablets and embedded systems. This one specific integrated ICs, just I told as per your requirement they will manufacture. See the types of ICs, the single inline SIP we call a single row of pin extending from one side. DIP, dual inline package, two parallel rows of pins will be there. Surface mount devices, SMD mounted directly onto the surface of the printed circuit boards. Directly PCB will be there. On that PCB I can mount. SOP, small outline package, string small outline package, quad flat package, etc. Quad flat package, flat rectangular package with pins. These are IC how they will manufacture. And BGA, nowadays the processor, everything, even IO also BGA level IC. Chip on board, bare silicon die attached directly to the PCB and covered with a protective epoxy. Pin grid array, PGA, BGA, COB, QFN, PGA. What is that? Those things what we are using, all the things we will discuss in future classes. Ceramic package, leadless chip carrier, LCC, square or rectangular package with no protruding leads. Okay, so these are the types of ICs, basic external structures. Here is the end of I2 components. But in laptop motherboard, what are those I2 components? We have to segregate. Okay. Here I have taken a motherboard. In this, how we can identify the I2 components, that we will discuss. See, here is a motherboard. Part number is LAF115P. Actually, what we are looking what are the ICs and what shape it is and what are the diode. First we discussed the diodes, right? See, what are the diodes? D. See, in D symbols all are diode only. See, D, I1. So in what is that, in board view, the D part, what are the D, those things we can easily identify. See, the D is here on the IO below. In the motherboard, this is the IO below D1. Okay, all D what we are seeing, those all are diodes. See, from beginning we will check what are the D or PD. D or PD are diodes. One by one we will check. In this side, this side, this side, here is the D3, this is the diode. Okay, WWI is given, and here is the, what are those? Here PDB, this also diode. PQ is there, PDD. Here also a diode. See, this one is DZ. D, it has indicates as D. Here is a D4, this is a diode. PD4, PD5, these two are diode, this also diode. PD6, okay. Here PD5, this also diode. See, in this how many diodes it has used here. Like that, here, no D, PD or D, we have to check. In this, DA is a diode, Q is not diode. Here DA, this also diode. Here, what is that? ED, this also diode, D has mentioned. And next, nearby this diode, this is not diode, this is a diode, D1. And here it is. Here is a diode, DI. See, here also 3 legs, and here also 3 legs, but this is diode. And Q, actually multiple active components, means multiple structure will be there. Here is the, where the diode, here PD, see this one, right, PD, these two are diodes. And what are the PD has mentioned, those are diode. Here it's a empty, here maybe this is the one, PD. Next, PQ, not diodes. PD11 is empty. PD, here is the PD1. Okay, any other? This side over, like that we have to check. That side from beginning will come. Okay, here where it is, no, PD, here is the PD, here is the PD. See, these two are PD. This is very important thing. And the line, white color line will be there, no, that is -1. Here is the anode and here is the cathode. Okay, the line mark is cathode because it's a anode to cathode, single direction it will pass, that's why. Okay, here 1, 2, 3 diodes are there. And here diodes, here this side, here no, this side, DT maybe here is a empty, DT, here no. Okay, you know how to find out the diodes. That may be 2 legs or maybe 3 legs. Those are diodes. So now what we find out, MOSFETs usually it will be PQ. See, what are the PQ? PQ, for example, here it's a PQ, or PQ, almost all PQ only. See, almost all PQ. That may be 3 legs or that may be 8 legs. Okay, now we will find out in the motherboard. From the beginning we will call, we can come. See, beginning side, beginning U actually is the IC. Now we are finding Q. The U PQB. See, Q is the MOSFET. Okay, Q is the MOSFET. MOSFET we are finding out. PCB, PDB, PQB1 and PQB2. These two are MOSFETs. Okay, and what are the Q? This is IC, but we are finding Q1, right? Q. Here PQA. This one also MOSFET. MOSFETs or transistor. That I will tell you. In this, transistors are not there. Only MOSFETs are there. It's a 8 leg. And here U. It's actually Q. We are searching. Any Q related? 3 leg. Q. This is the MOSFET. 3 leg MOSFET. PQ. See, these two are PQV, PQ8. This is the 8 leg MOSFETs. See, this is the 8 leg MOSFET. Here PQ, PQ. See, PQ. These all are MOSFETs. All MOSFETs and transistor. Maybe that we need to check. So this side. This side not there. U is there. PQM. See, that is section is a different one, but Q it mentioned it's a MOSFET. So here that's it. Here also on Q is the MOSFET, 6 leg MOSFET, and now other side we'll check. In this side from beginning we'll go. Q, D is the diode and Q is the MOSFETs. Q, 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 Q. See, these are the 3 legs MOSFETs. The diode, ED. Q, Q, Q. These are the MOSFETs. Q. Why MOSFETs has given here? It may act as switch. So almost all 3 legs MOSFETs are given as a switch. It will connect to the ground. Emitter is connected to the ground. See, it acts as a logic circuits. Q. See, Q MOSFETs. Okay, like this we need to identify the Q. See, MOSFETs. Now U in the sense it's a IC. U is the IC. It contains million billion transistors and capacitors, but it won't contain inductor and transformers. Okay, now U. See, here is the IC. Correct. That shapes we have seen, no, QFN, so many things that we'll learn in future. U. Here it's an application, it's a custom one. See, U. Here it's not there, but it's IC. UZ, IC. UL, it's IC. I think here U IC is not there here, but it's IC. UZ. See, these are the IC, not MOSFET. Here's the diode, IC. PU, here also IC. Next, here an IC not there. IC. This is transistor or MOSFETs. UC, see, IC. UC, IC. UC, IC. QV, actually this QV, this also it's actually Q has given, it's a MOSFET. U, IC. UV, see, these are IC. IC, UC, see, UV, this is IC. PU, see, it looks like a what's that, MOSFETs. Then also it's IC. So these are just introduction part. That's it. In that side, how it looks. See, this is IC, PUB, IC, PUZ, IC, U2, IC, U, this is IC, this is IC, IC, U, UV, IC. See, almost all U, all are ICs only. That may be processor or graphic chip or IO, whatever it may be, U as indication. Okay, those all are ICC, UT, IC, UT, PU, IC, PU, UT, U, start from U or in middle or end of the section, U, those all are ICs. See, PUS, it's a middle one. UU, it's IC, PU, it's IC. Okay, lot of ICs we found. Correct. One is diodes we found, transistors or MOSFETs we found, and finally we found IC. See, the processor UC1 is a IC. And what about bias chip? That also we can check. See, this is a bias chip, that also mentioned as UC. UC is one category, UC3, UC1, and here it's a UV has given. And what about UC2, this side, here UE, that's it. Okay, now you come to know what are the diodes, what are the transistors, what are the MOSFETs, and what are the ICs. So in the motherboard, what it contains, motherboard is a combination of, it's a mother, what we called, it's a mother because it contains all active and positive components. So what are those in active components? ICs, diodes, transistors or MOSFETs. In positive components, what is that? Capacitors, resistors, inductors, coils will be there, no? Those things. Okay, that's why it's called motherboard. It contains connectors, inductors, I mean active components and positive components, all the things. So that's it. This is how we can identify the components, active and positive components. So in next chapters is very important, because using these active and positive components, what are the circuits it will generate? Those things we will discuss in next class. Okay, thank you very much. Welcome to Pavitra Laptop Care. Schematic is graphical or symbolic representation of electronic component circuits. How to read schematics? To read, please follow the procedures. Number 1. Voltage name from each component, source to destination. Source supplied to the motherboard. Voltage path from source to destination. Pull-up voltages. PWM sections. Power states. Smart chips and their signals. Logic circuits. Functions of each electronic components, and so on. Let us begin. We will check one by one. Here we have taken a schematic. Just introduction I will give using this schematic. It contains KBL-U plus MAC 1416 motherboard. It started in 2017. So what are the main key points we have to check in this schematic is, first is model number LA-F115P. See, in any schematic, first you need to check the power plane and power state. See, here is the power plane and this one is the power state, S5 to S0. See, in S5 state, what are the voltage will come? You need to segregate it. First step is S5 state, second S3, and third one is S0. See, now what are the S5 state PWM or main voltages? See, here is the S5 on 1 volts prime, next here on and off, 1 volts MPHY PLL, Next one is 1.8 volts prime. Next is 3 volts always. Next is 3.3 volts always DSW. Next 3 volts always PCH. Next 5 volts always, and next is the RTC cell. These all are what are the on as given. These all are S5 state, and star as given. Star in the sense here on means that this power plane is on only with AC power available, otherwise it will be off condition. See, in any schematic this is the common S5 stage, S3 stage and S0 stage you have to segregate. Now the main source to the motherboard. Here are the main power supply, main source. See, one is DC jack. See here, it's a DC jack. PJPDC1. Here from the adapter the voltage will enter as a DC in. Actually it's 19 volts adapter in. After this coil it will change as plus DC in. This is the first voltage, and as well as the ID, PS ID also will enter, and where it will go, that source to destination, which I told in general I am telling this one goes to 25 page number. So which component it is there, later we will check. Generally we will check identify the source. This is the first source. Second one is the same source will become SDC in through this first and second MOSFET. How it will become, later we will check one by one. And this is source over first source. Second one is the battery source. See, once you connect the battery, here is the battery connection. So once you connect the battery, that will become plus 17.4 V bat plus. Okay, next source, third source is type C PD source. That also similarly it will become as SDC in through this first and second MOSFET. This entire functions we will check it later. This is the source. What are the source? Plus SDC in. Second one is battery source. Battery source, it's a 17.4 V underscore bat plus here. And third one is this adapter voltage. The same thing is SDC in. These three main supply will enter to the motherboard. Now what are the PWM ICs and PWM sections? Here is a IC, it's a first PWM section, it's a PUB01. You know why it's a PWM section? It has high-low MOSFETs, and here is the gate. So here is the coil. Where are the coil will be there, the main coil, so there will be a PWM section we call, because the gate voltage of this particular MOSFETs, this is actually dual MOSFET, so it will control by this IC. This is PWM IC. So once the major what are the main inputs are required inputs are fulfilled, then here you will get the voltage of PWM section. This is the PWM section, but here we are getting 19 volts VB is the output from this particular PWM section. As well as actually this one is not only adapter voltage as well as battery voltage too, because it will enter from here to here, and this CLR will become 19 VB. This voltage will enter to all over the motherboard and main ICs. See here that 19 VB entering here, which IC it is? Here it's a 3 volts IC PU301, and final output through this PWM section PL301 is the coil. Through this coil we are getting plus 3 volts always, as well as this PWM section output gives 5 volts always. Like that, this also on PWM section 19 enters here, and the output through this PLM01 we are getting 1.2 volts. Like that, one more PWM section here PLH01 we are getting 1 volts always P. Next we are getting through this PL1801 1.8 volts always. These are PWM sections. Here also one actually this is not PWM section, it's a 2.5 volts, and here also it's a major PWM section. What it will convert? It will give VCC core, VCC GT. Okay, this also here PWM section, it's a VGA core, it's a graphics. voltage. This one also PWM core, it's 1.35 VGPUP. Okay, these are PWM sections. Here this one is the SKL, it's a SOC signals. These are the voltages, pull up voltages, SOC signals. So what are the pages it contains? Up to here. See, these are SOC related. This one SOC. See, SOC, and these are the signals of this particular SOC. We will call it as master chip. Here this is the RAM section, RAM slot, DIMM DDR4, DIMM A RVS. This one is DIMM B. Here is the one more smart chip, it's a MEC 1416. These all are the signals, these are the inputs. See, it's a pull up. These are the pull up voltages. So this one was the introduction of this PWM section and smart chips. See, here is the signals. Some of them are output, some of them are bidirectional, and some of them are inputs. So here is the conclusion of general instructions. In next videos we will check one by one thoroughly. Thank you very much. Welcome to Pavitra Laptop Care. Today's class is very important for beginners. You know why? So I will tell you. Because this is very simple manner you can learn whole schematic. You know how? See, the thing is, this is the first page. The processor is KBL-U plus MEC. It's actually IO board. The year is 2017 and version is 1. Okay. Here this model is Compal has made this one. Okay. Compal confidential. The PCB designed by Compal. The model number two are there. One is Loki 15 and Loki 17. Okay. So this is very simple. You need not to scratch your head. The only thing is model number you have to note down. And here it has given unpop component. See, unpop component means at present if it is given as at, the component not available. In case UMA at has given, the UMA component will be there. This at will be there, means this component will be there, like this. See, these are EC at means EC component, JP at means jumper. These are present one. Which one is absent? Only at has given, then only it will be the absent one. Okay, here is clear. So these are the meaning one by one. And now this is the block diagram. What motherboard contains, what CPU and what PCH. See here, the CPU, Intel CPU, KB Lake U. This is actually two models are there, right? KB Lake U and KB Lake R, 15 watt. What it contains? See, the thing is, it will communicate with the RAM. GPU is connected with the CPU, and EDP is the output, bidirectional output, EDP connector and HDMI connector. From here you will get the output. And here USB ports, as usual, you know that USB type USB 2 and USB 3 is the latest one. Type A, type B, type C, all are USB only. See, these all are type 2, USB 2, and here USB 3, this port. Okay, that yellow color port. And now here it's a WLAN and SD card slot, and here is the card reader. Okay, here VGA connector, here type C, RJ45 LAN connector, M.2, NVMe also it will support. Some motherboard won't support NVMe. Here it's clearly mentioned it's NVMe. Okay, ODD, it's DVD writer, HDD SSD connector, FFS, I don't know really. eMMC card will come, it's like a memory card. Okay, SDA means it's a audio jack for speaker. Here is the RTC cell, externally it will be connected. Why these all are marked as yellow? See here it has given Loki L only, means that Loki L model only it has given RTC and data board. Okay, it's very simple, right? In this, one more thing you have to observe is the page number. If you want DDR4 related information, you have to go to page number 20. Or If you want CPU related information, you have to go to 6 to 19. Here is the 25 for MEC KBC, means it's IO, and so on. Okay, these are the page number. Now where you have to see here, if you come down, this motherboard will work with the power plane voltage rail. What are those? See here, S5 to S0 state. First you need to concentrate on S5 state. See here, which one is the on? For those, what are the voltages it will create and what are the signals it will carry? Those things you need to identify. See, these are the S5 state. It will be on. Here this one will be on, 1.8 will be on, and here 3 volts always on, like that. These are what are the on is there, that is S5 state voltages. Second one is S3 state voltages, usually RAM voltages. Okay, S0 state, S0 means it should be on, all will be on. Only the option is this one. Okay, clear? This is a voltage rail. According to the voltage rail, this particular schematic has made, means the circuits will generate these kind of voltages depending on the status. Which one will consider the state? You know, the smart chips. Those are processor, PCH and IO. These are the smart chips will decide the status. Once enable comes, then only it will decide next state as to proceed or not. Okay, so that later on you can come to know. Before that, what are the status, state voltages, how it will create? By seeing only one page you can come to know complete motherboard voltages. You know how? See, if you come little down, you may able to see the block diagram. Using this block diagram only, means it's a power rail only, you come to know what are the voltage required to generate from what. See, this is very simple. I'll explain only on this page, then you come to know. See, here is the adapter. Right, adapter is the first. Once you connect the adapter, it goes to charging IC. Correct. Okay, you leave it adapter. Then you will connect the battery also. Correct. That also will go to charging IC. This is actually POB01 is the charging IC. In simple manner, it will collect the information from the adapter as well as battery. The main source to the motherboard will entry through the charging IC. That may be actually here in this IC 13.5 volts you will get in 19 VB. It depends on motherboard condition. Okay, some motherboard has 13.5 volts and some motherboard has 19 volts as the adapter voltage. In case if you are connecting the battery, it may be 14.5 or 17 something will come. Actually here is the sys output will be there. Through that output you will get the power source. Okay, that is a plus 19 VB. You know what is that power source? Power source is the main voltage from the battery as well as adapter. Both together will combine in this section. See, complete section it will combine. Now this particular section will move to other sections. What are those? See, the 19 will enter to the RAM section. These two are RAM sections. See, what is that? 1.2 volts DDR. Shall we check in the power plane? See, here is the power plane 1.2 DDR. When it will be on? Here, S3 state. Okay, DS3, S3. Correct. Like that, you have to see this black diagram. See, power rail diagram. It will be easily you can understand. See, this one will enter here. Immediately 3 VLP will generate. Correct, here, and one more cell voltages will enter here. Then it will become RTC cell. Okay, that one also over. Now it's a term to this one. See, this 1.2 here 1.0 prime voltage will enter to this part 1, 2, 3, 4. Then what it will generate? Finally, it will generate 1.0 VS VCC IO. And here same 19 volts will enter to this part, 5 volts always. Correct. So 5 volts always will enter to these 4 part and it will create this kind of circuits voltages. 5Vs, everything it will generate, and again this voltage will enter to this part, and again it will generate these voltages. Okay, like that these voltages, I mean this circuit will generate this one CCG bus, and where it will go? It will go to the V bus, means charging IC. Okay, it's a type C voltage, it's a PD, what we call that, that voltage it is. And again the same position PU301 will enter here, I mean it will create 3 volts always through the PWM section, and again what are the section it will enter? 1, 2, 3, 4, 5 section it will enter. See, these are the voltage it will produce. This particular voltage will produce, it will enter 3 stages, and the circuit will generate these are the voltages. Okay, so here same 3 volts always will enter here, and it will produce these voltages. This one will enter, and here it will produce 2.5 volts. The same way again down here 19 will enter here, and it will produce VCC core, VCC GT, VCC SA, VGA core. Okay, like this the main voltages will generate to carry the signals. Which signals? To operate the smart chips. What are those? CPU, PCH and IO. Okay, now you understood? That's very simple. In next chapter we will check what are the individual sections. Okay, now 3 volt section where it will go, 5 volt section where it will go, and adapter voltage where it will go, everything part by part we will check. Okay, that's it. We'll come back again. Welcome to Pavitra Laptop Care. Till now we have seen the basic concept of the schematics, right? So today we will cover maximum in the sense in advanced level we will move forward. Okay, here is the KBLU is the processor, MEC is the IO. Okay, 2017 model, revision 1. Compile confidential. Compile is the manufacturer of this design. Okay, I mean PCB. So now this color is a present, this one present. In case this one has given, in case graphics is there in the motherboard, then this at will be there, otherwise UMAT will be there. Okay, this already explained. So now in simple manner, this is the SOC. It contains GPU, here memory, like that USB 3, here WLAN, SD card, okay, WLAN camera, and so on. It has 2 models. One is Loki 15 and Loki 17. Okay, now what we have to do? We have to check all the supply to the particular, what is that? Particular connectors. So here supply has to be go. Then only it will communicate with this SOC. How it will communicate? Through the communication signal. See, this is the communication signal. How it will communicate? This is IO and this one is SOC. SOC will communicate to this RAM section. Okay, here is the RAM section and VGA section. Through what? See here, this is the communication path. SDA, SL path, clock and data path. Through this clock and data R7 and R8, this is the RAM section will work and VGA section will work. So like that, the same DGPU will work through this clock and data. Okay, this one is 2, including these 2, the max, what is that? SM bus address MCP23008T will work. What it is? So we will check later. So now through this SM bus, thermal section will work. So this is the communication path. See, this path, if not there, clock and data won't be there, then your laptop considered as a dead, because without communication it won't connect to the devices, right? These are the devices. Okay, so now it's a type C also, connectivity, charger, battery. So to charge the battery, it has to be torque, right? The in between the what is that IO and this particular charger or battery. So there must be a torque. Then only it will communicate to each other, and then it will, in case of battery will charge, and in case of charger, the charger light will glow. Okay, so now you got the point, right? So through the communication path, it will communicate to each other and it will work as per the requirement. Here is the block diagram. Okay, as per this block diagram only this particular motherboard will work. So how? See, here is the adapter, charger and battery. charging IC and battery. Once both are combined, then 19 VB will produce. I already explained. Once again in general I will explain, and one by one section. What are the circuits here? What are the blocks are there? All are each circuits. We will get the output from here. Okay. So how we will get the output, that I will explain in today's class. Now the source point. What is that? Adapter, battery. These two we will check. Here is the first source, that adapter. I already explained, but one more time I am going to explain. See the coil characteristics. This component will oppose AC and allows DC. We required pure DC in, so that to avoid the AC signals, these capacitors are used. Even though in case of AC is there, then it will allow through the coil and it won't allow the AC signal, and it allows only the DC signal. Again, if any malfunctioning signals will generate, noise will generate, then this capacitor will filter it. What the capacitor will do? It allows the AC. In case of AC is there in this path, it will filter to this ground. Okay, just it will bypass. That's it. Okay, now we got DC in. How? Once you connect the DC jack, here is the 5 and 6 is the positive, and 1 and 2 is the negative. 3 is the PSID. Through this coil it will go. So what it does, actually coil is for boost the signal, DC signal. So now here it came, and here is the protection diode is there, 3-leg protection diode. So here is the what is that, voltage divider path is there. See, actually for this path one MOSFET is there. This one is N channel MOSFET. Okay, here is the what is that, drain, and here is the source, and here is the gate. Okay, so now here there will be no voltage, correct, but here some voltage has given 3 volts voltage. This 3 volt voltage through this 2.2k resistor it will enter, almost 3 voltage it will enter to this path. This is one communication signal. See, this PSID is very very important. 25 in the sense it's the page number 25 contains IO. This particular signal goes to IO. So here in this path, in this path 3 volts may be there or may not be there. Okay, it depends on IO. This is the PSID. The first signal will enter to the where IO. Okay, see here 3 volts always will enter here, and actually till now we didn't get the 3 volts always because only positive only we got. So later we will check at the time 2 or 3 PWM sections will work. So now here is the forward bias. This voltage will go to this particular section. See, here is the forward bias, so here it will go, and here voltage divider will happen, and some of the voltage will go here, and here it will, what is that, in case its required voltage is more, I mean it required voltage is obtained, then here what are the voltage will come, it will go to ground. It means it will be in off condition. Here the what are the voltage will come again, so it won't come this path. Okay, so sometimes here the path will be 0 volts. It depends on the circuit. Okay, now here is the 5 volts always has given to this MOSFET, because the source voltage will be lesser than the gate voltage always. So that is the reason here, see 5 volts, and here is the 3 volts. Okay, so now we got PSID and DC in, and one more point is DC in will enter here. MOSFET, what are the MOSFETs are there? One is P MOSFET and N channel MOSFET. The P channel gate should be very less compared to source. It means in case 19 volts is here in the source, and the gate should be 17 is the maximum, 0 to 17, then only the complete voltage from source to drain it will pass, otherwise it will block. See, the diode is in opposite direction. In case we need to break this diode, here gate voltage is machine should. Here is the P channel. You know the P channel, the diode direction will be opposite from source to destination. So that's called it's a P channel. Now DC in will come here, and here is the voltage divider will happen. So how it will happen? See here multiple MOSFETs are there. So first we need to understand the logic. So then we can easily understand how the voltage will enter to this side. See here, this is the MOSFET. Where it has connected? It has connected to 1, 2, 3 source. Right. Here it has come, and this path also it will go. Here what will happen? Here is the 2 resistor. In case of first resistor is a source, and the second resistor destination is connected to the ground, then it will become as a voltage divider. Okay, see here is the 19.5 volts will enter here, and here voltage divider become, that is AC. Okay, that one is going to this diode PD10, then it will forward bias, so it will come here, and again the same voltage, maybe 3 volts or 2.6 volts, whatever it may be. So that one will come here and here. See, it will pass through this 0 resistance, and here it will come. In case this voltage is enabled, then what will happen? See, we got the voltage, right? 3.3 adapter in, and here also one voltage we got. So then this MOSFET will be on condition. It's a N channel MOSFET. See, in case of gate has some voltage, then this what is that? N channel MOSFET will be on condition. Then drain to source current will pass. See here, one more thing we have to observe. This DC will come to this part also. This is the capacitor. Capacitor oppose the DC. What are the charging point is there? Till that time its positive charge will charge, and it will oppose this, and the same voltage will come to this resistor. Here is the source, and here is the destination. Destination now, here what are the voltage will be there? Then it has gone to ground. Then it means here is the ground. It means here also one voltage divider happened. So through that voltage divider, the voltage will pass to gate. Then the pass here may be very less voltages, right? Maybe 3 to 7 or 8 or 9, whatever it may be. So here we got the voltage. Then here gate is active, then complete voltage from source to drain will pass. Okay, now DC in SS we got. So this voltage, what is that? It's a 19.5 voltage. Through this protection diode, protection MOSFET, it will come. So this one, where it will go, that we will check later. So here this voltage will come here, and here also it's a PQ4, also P channel MOSFET. P channel MOSFET easily it will enter to here, right? So drain to source it entered. So then what will happen? This voltage will come to this. But here it depends, the voltage divider is depending on this MOSFET. This MOSFET is on or not, that we will check. See, here is the DC in SS will come. Through this resistor it will come here, and one more resistor is there. Then see, the second resistor destination is the ground. First resistor source is the main source, it is connected to the source. So that's why here is the voltage divider happened. So using this voltage divider, this MOSFET will be on condition. So then what will happen? Here the voltage, here the voltage, here is the second resistor, and here is the first resistor. Second resistor destination is connected to the ground. First resistor is connected to the source. Then here is the voltage divider happened. Then this MOSFET also will be active. Then complete voltage. See, in case of this is not active, some portion of the voltage will pass here. In case of 19.5, here it may be 18.9 something. But here gate voltage also has come, right? Gate voltage, what it will do? It will connect this part to this path to this path. Then complete voltage will pass from here to here. Then now we got the DC in SS also here. What the name? The name is SDC in. It became SDC in. Okay. This is how SDC in will generate. So now so many logics are there. These are logic circuits we call. Okay, how it will work, that we will check. This one we saw, this one also we saw. So now we will check from the beginning here. What is that? This page contains multiple logic circuits. So here DC in also came here, and here is the IC. What I see? It's a 5-leg IC. Here is the VCC, and ground should be there. Here is not connected. Same output will come. Actually, here is the DC in it has given. It means it's a 19.5 volts, but it will convert as a 3.3 voltage here. See, this IC will receive 19 volts, but output will be 3.3 volts adapter DC in. But here we need to check. It may be 19.5 volts, 5 volts also, or 3.3 volts also. It depends on this particular IC. So now we'll consider is a 3.3 volts adapter DC in. Okay, here this voltage is generated, and now here 3.3 volts adapter in will enter here. V bus in also will enter here. This one from where it has come, that we will check later. So again here this is the 19 volts. Here is the voltage divider, and here this enable. This enable means it's a voltage divider amount. What is the amount voltage will be there? That voltage will enter here. Then we will get the output. Okay, so the same voltage will come here, and this one has to be ground or not, that depends on this one. See here 3.3 voltage, this one, or VB bus. One more supply is connected to this diode, and it will come the output. See, output through this resistor will come here, power selection 2. Okay, in case it has some 3.3 voltage, then this one will be active, then whatever the voltage will be there, that entire thing will go to ground. And in once it ground has enabled, here enable won't be there. In that case, this output we won't get. Okay, so now we will get or not. See, we won't get here this output, because here is the one more V bus will enter here through this what is that 100K. It's actually power selection path. What it is, we will check later one by one. So now in case voltage has come here and it will be ground or not, that we need to check, right? See, here one more logic has given for this voltage. See, here till here voltage came and this one enable won't be there, right? So for this also one more MOSFET they have given using the logic circuits. See how it will work. In case gate voltage will come, then this voltage will go to ground, then here there will be no voltage, and then this one will be off condition and this one enable will be there. So here voltage will be there or not, that we will check. See here the power selection. See here 3 volts always is there. 3 volts, what it will do? It will do that 3 volts will pass here through this, and here also voltage we got. So then what will happen? What are the voltage will be here? That goes to ground, and here there will be no voltage, then it will be in off condition. Then what are the voltage will be here? That enable signal goes to this IC and we will get the output. Okay, so now 3.3 volts adapter DC in is available because of this. In case this one is not available, then this will be in on condition, then enable won't be there, you won't get this voltage. This is the logic. Okay, how to identify this logic? This is the one. This is the AND gate. Okay, LM393_P is the AND gate. Here power selection, the IO will release this signal. In case voltage will be there, I mean signal is there, then here is the pull-up voltage. Same voltage will enter to this pin number 1 and pin number 2, this one. In case this one has 3.3 voltage, then both will be in on condition, then the output also will be available. Output is this one. See, here is the what is that the source has given, but we don't know exactly what is source. Actually usually 3.3 voltage will come here. Okay, so that voltage will enter here, this MOSFET will be on condition, then what are the voltage will be there? Enter voltage will be go to ground, then here there will be no voltage, then here it will be in off condition, and here what are the voltage will be there? Then it will be present only. So what voltage will be here? See here the adapter pin voltage, and here the DC in voltage, it will enter here, and here it will be in off condition, right? So same voltage will enter here, and this one will be in on condition. Then what are the voltage will be there? Here one in drain, it goes to ground, and here it will be voltage divider. So the voltage will pass from here to here. See, this is the logic circuit. Is very important. Like this you need to understand. Okay, if you not understood, please check this video once again how these logic circuits will work. Okay, now here this also over, 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 everything over this side. See, here we'll go forward. So here one more circuit is there. Here also it's a P channel MOSFET. Here it will come and it will stay here. It's a 19.5 volts, and here this downside it's a gate voltage. Gate voltage we already obtained, right? So that gate voltage will go to here. So here is the protection circuit or what, that we will check. Here one more voltage will go here. Here is the voltage divider. So some of the voltage will go to here, and it will be off condition, because whenever the voltage will be there in gate, that till the time the P channel MOSFET will be in off condition. So that's why this one and this one won't connect. It means the voltage divider, here voltage divider voltage will be there approximate 3 volts or 5 volts or 10 volts, whatever it may be. In case this will be in on condition, then 19 volts will pass to gate voltage, then there will be no use. Okay, so then it will be in off condition. So that's the reason here the voltage will be should be there, and it should be in off condition. Okay, so now this one also it's a protection circuit, and the same voltage will pass here. The voltage here pass here. Is the voltage divider or not, that we need to check. See, here one more MOSFET is there, here one more MOSFET is there. Here power select 2 voltage will come, AC B2B voltage will come, and AC okay. Any one voltage will come here, and this one will be on condition. Then what are the voltage will be here? Then it goes to ground. Then it will be in off condition. In case if it is in off condition, there will be what is that? There will be full voltage. It means it's a 19 volts something will be there here. So that one will be come here, and it will be in off condition. Okay, so like this the logic will work. So all MOSFET, how the logic will work, that I told you. This one need not to check these sections. Okay, these are some standards, ERP logic standards it has given, so need not to check. So now we got the SDC in, DC in SS, and DC in adapter. Using the adapter, how it generated I already explained. Now one more source. What source? Here is the battery section. See, beginning, once you connect the adapter, what signal we got? PSID signal we got, that gone to IO. So now the battery section. Battery section, once the positive will connected here, it's a pin number 8, 9, 10, 11. Okay, sorry, 11 and 12 are the ground, and 10, 9, 8 are the positive one. See, here is a 17.4, and using this coil, the name become 17.4V underscore bat. So this is the battery voltage through this coil. Now this one is ground, and here two are there, see, clock and data. This is most important section. This is the communication path. Okay, where it will go? Here 25 and 55. 25 and 55. 25th page contains IO, and 55th page contains the charging IC. So it will communicate, the battery will communicate with the IO and what is the charging IC. Both will communicate. Total 3 will communicate. One is battery section, IO and charging IC. These 3 will communicate to each other, and what are the battery requirement. Battery is good or not. Battery, what the capacity, it is already charged or not, we need to charge it or not, it's fully charged or not. All information will goes to IO, and battery is connected or not, that information also will go to IO. Then only once the information, input information is pakka, then communication path will enable through this data and clock. Okay, this data and clock communication path will start. Once this path will start, here is the system present. So one more voltage it will come. System present. 1, 2, 3 are the ground. So need not to worry about this. Here is the battery present. 3 volts is the pull up. Pull up means the signal. To carry this signal, one voltage is required. That is pull up voltage. Here is the pull up voltage comes from 3 volts always. But till now we didn't check the 3 volts always, because now still we are in the source. So at a time, a source, charging IC and step down IC, all 3 together will work. So that's why here it has given 3 volts always. Okay, so later we will check how it will generate. Now P bat press, here is the 25th point, 25th means it's a IO, and it's a 55 in the sense it's a charging IC. So it will communicate. What are the signal now we got? We got P bat press, date underscore SMB, clock underscore SMB. This is the communication path. Okay, now got it. Using the adapter ID, this what is the PSID we got? Here we got battery present, ash, data and clock. Okay, one more type C connector. Actually later I will explain you what are the type C requirements. Okay, here is the DC in we got already. So this is called comparator. It will compare two voltages. Pin number 3 and pin number 2 is there. No, two inputs it will compare. Which one is the high? It will make it as a high. Output will be high. Which one is low? In case negative is the high, then negative path will be high. Means it will be low. Okay. So it will compare two. What are those? One is DC in. Is the 19 volts. And here is the negative one is, what is that? 3.3 adapter DC in. Okay, 3 volts. Those are, here is the voltage divider. See, here is the voltage divider will happen. Here it has given 17.6 volts. Here maybe 3 point, here it's a 1 point something will be there. You have to check what is the voltage divider amount. In case pin number 3 is high, means greater than 2, then here the output, pin number 1 output you will get. Okay, for this comparator supply should be there. So that is the supply path here. See, supply from where it will come? One is adapter DC in and V bus in. Okay, these two are the supply path. This any one will go to here output, or both will enter here, but only one output it will come. So this one is the supply path, positive and negative. When in case pin number 3 is a greater, number 1 will be high. Okay, high in the sense here you will get, this one will be high, means voltage you will get. That one goes to this 25, 20, 53, 54, 55 pages. 55 it has what is that? IO. It means it's like AC win. It's actually one kind of thermal information. Okay, AC, okay, like that. So that information goes. Now what are the information we got? PSID, clock, data, SMB, and battery present, and this one also. This all will go to where? IO. Now IO getting all these things. So now here CCG bus. Okay, we will get the output from type C. CCG bus will get. So that one, from where it will come later we will check. So here it will come through this coil, and it will become like this one, this name, and it will enter the PQS01. See, same thing, same repeated process. So here is the P channel. The gate voltage should be lesser than the source voltage. So that's why voltage divider is very, very important. Here is one resistor is there, and one more resistor should be there, right? So from where we will get? Here one more resistor we got. So here the second resistor should be destination part, right? But here till now here there will be no destination, is the ground, because here is a MOSFET. This MOSFET, until unless it will be on, till the time it will be, there will be full voltage here. What voltage here is the 19 volts. 19 volts come through this resistor and through this resistor, and it will be stay here. But here the logic circuit is there. How it will become as a on? So that we will check from this. Okay, from beginning we will come. This CC bus will see, this is the VCC and ground. This particular IC will become as a 3.3 volts V bus underscore in. Okay, now adapter in we already got in that particular previous IC. Then this is the voltage will go through this Schottky diode, and here one more AC OK will goes to this Schottky diode, and one more hardware that AC in also will go to this Schottky diode. It means any one input will go to this part, then this particular MOSFET will be active. Now it's active only because these all are the voltages has gone here. So now if it is active, then what are the drain voltage will goes to ground. What is the drain voltage? Here is the 3.3 volts. Here is the voltage divider is there. Correct. That voltage divider will come to here, and here. Here what will happen? What are the voltage has gone here? It will be grounded. But here it should be in on position. But here if there is no voltage, then it will be problem, right? So that's the reason. So one more logic has to be happen. So that is the here. See, over trip protection. In case this will be on, then this MOSFET, this will be high, then this MOSFET will be on, and what are the voltage will come here, that one goes to ground. Then this MOSFET will be off condition. Okay, and here also it should be in off condition. In case these three voltages are not available, then this one will be in off condition. Okay, in case anyone is on condition, the voltage will come here. In case, see here, in case this one is on, means here it's 0. In case this one over trip has not come, then it will be in off condition, and what are the 3.3 volts is there, it will enter this MOSFET, and this one will be on condition, and what are the voltage will come here, that one goes to ground. Okay, so but one more thing we need to understand here. So here it's already grounded, because here over trip voltage should be present, because once it present here there will be no voltage and it will be in off condition. One minute. See, if you think in generally, so here it should be on condition, means here there should be voltage. Okay, and here there should be voltage till here and here, but these two should be in off condition. It means here there will be no voltage, and here also there will be no voltage. Means what are the voltage will come, it will go to ground. Means here voltage should come, and here it will be no voltage. In that condition only here we will get the voltage divider. Okay, so now the 19 point something voltage will come here, and it will enter here. Okay, here is the voltage divider kind of thing. But once V bus P control will come, this will be on, and this one goes to ground, and here voltage divider will happen. Here it will be on, and what are the voltage will be there, that one will enter here. Okay, so what amount it will enter, that we need to check. Actually, once it enters 19 volts or some other volts, so it will be in off condition. In case 19 volts will come, it will be in off condition. But here, in case of N channel, now it's a P channel. See, now P channel means here is the voltage has come here, and here is the voltage, and it will be in off condition. Means source to drain, the voltage won't pass because it's a P channel. See, generally what will do, the technician will get confused with the N channel and P channel. Here we need to check the diode conditions. So here is the P channel. See, Guys, it's a very important to understand the logics, otherwise it will be very difficult to get the circuit confirmation. In case of troubleshooting, it will be very difficult to understand this kind of logic. Okay, main logic is here should be voltage divider and this one will be on. If it is on, here should be voltage, so that voltage will come from this one and it will go here and it should stay here and it should be in off condition, and here also it should be in off condition. For that it should be in on condition because voltage will go here. So here it should be in off condition. Okay, if voltage comes, then it will be on, then it will be the whole voltage will pass to here. So that's why. Okay, so it depends on logic. What are the voltage has to come here, then only it will come here. Actually we are checking the type C, that's why it will be in off condition. Okay, so now the type C voltage will come here, it will become V bus DC underscore SS, and next it will pass easily. This is also P channel MOSFET. This one is easily it will pass, but some of the amount will be deduct, right? So because gate 100% it has to be in turn on, then only 100% voltage from 5 to 1 to 3 it will pass. So now here the voltage will pass and immediately these two resistor will become voltage divider. How? When it will be in on position. In case of if it is on, then here voltage should be there. The voltage from where it will come? See here, these are the input path, so it will enter to here OR gate. See, OR gate means either this one or this one, any one voltage will be high, then output will be high, then it will be on position, and whatever the voltage will be there here, that one goes to ground. Okay, so this is the logic here. Once it goes to ground, then whatever the voltage will be there here, it will be go to ground, and here it will be in off condition. So it should not happen, right? So that's the reason here there should be no voltage, it should be in off condition. Okay, so now from here we'll check these two voltages. Here is any one voltage will come, then it will be off condition. If both will come, then it will be on condition. Then if it is on, here it will be on, but here it should be in off condition. Okay, if this one will be on condition, then what are the 3 volts will be there, what are the voltage will be at 3, it goes to 4 and it will become 0 voltage here. What are the voltage will come here, that one goes to 0. Then this one will be off, then your voltage divider won't happen. We required voltage divider because of P channel MOSFET. Okay, so here this MOSFET should be in on position, because of that it should be off, means here there should be no voltage. Okay, those things, those logic we need to understand. Okay, here if it is a voltage, definitely here it will be in off condition, means type C won't connect here. The SDC in, the same one from the DC jack also we got, here also from type C also we will get this one. At a time you connect both, any one will work. Okay, so that's why these kind of logics are there. It's very difficult to understand, please give some concentration on it. Okay, here what is that, some voltage divider path has given to this one is P channel. See here it's a voltage divider. In case of voltage divider, this should be in on condition. How it will be on? Here 3.3 voltage will come here, and here one more also is there. Here if it is on, then the voltage will goes to here, and here it will be in off condition. In case of off condition, what will happen? Voltage will be available here, then this one won't on, it will be off condition. In case if it is a on condition, then 19 volts goes to gate, then it will be in off condition again. So then what are the voltage are there in 5, it won't pass to 1 to 3 because the same voltage is available in gate. Okay, this is the logic of first and second MOSFET from here, from DC jack and type C. And battery also we got. Now we got SDC in from type C, and what is that, in adapter. Even V bus underscore DC underscore SS also we got, and DCNN underscore SS also we got. Now where it will enter? This is charging section. See, here is the charging section, here is the input 19 VB. 19 VB what it is, that I will tell you. Now V bus from the type C, and this one is the normal adapter. So these are the voltage we got, that one enter to this particular charging IC. Once this input will enter here, then what are the common things? See, DC in SDC we already got, right? That one also will enter here, ADP. So here is the voltage divider. Through this voltage divider, AC in charge voltage will enter pin number 19. Okay, DC in one first, this is the first voltage. Second one is SDC in is the input for this AC in charge. is the second one, AC in charge is the second one. Here one more VDD has given here, see, AC in. So VDD also very important. So here it will come, here one resistor, here one resistor. So it may be become as a voltage divider. Then that voltage divider, what is that path is AC AV in. Okay, so many things are there. In depth will tell you one by one. Okay, for at present you have to consider it's an input. Okay, here is the adapter input and here is the AC in, and SDA SCL should contain 3.3 volts. See, it will communicate with the pin number 53 and 25. Okay, that what is that 53 means, I already told it's a battery section and as well as this section, charging section, I mean adapter section. So here is the actually battery section, it's a 25 IO section. Both will communicate to each other with the bidirectional. So pro chart okay, AC okay, AC okay, how it will generate, see, this is the AC okay. This path completely I will tell you. Here is the battery present. I already told you from the battery side it will communicate with the charging IC also. See, 25 and 53 means charging IC and IO, both it will communicate. Now the complete working function some other day I will explain you how it will work. Okay, now the input and what are the required conditions will be okay. Then here is the 19 volts VB. This is V6. V6 is the output of the IC. Okay, V6 is the output of the IC. So what is that output? Here is the output V6. The same output will be present here also. Okay, see, in all motherboard, I mean all section of the motherboard, this plus 19 VB will enter. It may be 13.5 volts or battery's voltage. See how is the battery voltage? Here battery side, this is the first MOSFET. Here it has shown as 17.4 volts bat. Once battery you connect here is the P channel MOSFET, right? It will enter from here to here. So here the gate voltage is depending on the charging IC. The charging IC will control this one. So how it will control in next videos I will tell you. So here battery voltage will enter, that will become as V charge in. Okay, that is that will be available in this PRB 12. Here is the CLR voltage. This CLR voltage is nothing but 19 VB. Okay, now you got right 19 VB. How it will come? It's 13.5 volts or battery voltage. So now we got 19 VB in charging IC. Okay, so one by one later I'll explain. Next, this 19 VB will enter through this jumper to this particular IC. What it IC? What this IC? This one is 3.3 volts LDO, I mean 3.3 volts IC. Okay, step down IC. Here is a single IC. These are the input. What input? 19 volts. See, I already told if any noise will come, this capacitor will be reason to filter those things. Okay, once pure DC will come to this IC, then what it will do? By the help of enable 1 and enable 2. See, now the enable 1 from where it will come and this one where it will come, that we need to check one by one. See, here always on will come. Okay, this always on, once it comes, this is the path. Here it will enter and again it will go to two directional, enable 5 volts and enable 3 volts. Once this always, from where it will come, this is the IO path. See, IO output always will get, then the always on will generate as a enable 5 and enable 3. Here what is that? Enable 3 volts is the enable 1, and here in LDO one more also enable is there. Okay, that one also we'll check from where we got it. So now the main thing is, 1 minute, that one I'm checking here. See, 19 volts is entered here and same 19 volts will become as a enable 2. Okay, leave it, that one we don't want at present. Once this voltage enters, this 3 volts LDO will produce by this particular IC. This is called LDO voltage. Okay, now after this enable 1 and enable 2, this one will produce what? 3 volts always. Here is the jumper, this 3 volts always will become as a 3 volts. That's it, volts always, not P. And here 5 volts. 5 volts IC also same concept. 19 volts will enter to this and here immediately VL in the VL is nothing but 5 volts. 5 volts will generate. So here is the enable 1 and enable 2. Enable 1 I already told you how it got here from always on from the IO. So finally once 3 volts always and 5 volts always will get, the output of this is a power good. Power good is the power good is nothing but the complete working section is good, then only this voltage will generate through this pull up. Okay, now this volt already is generated and that is the pull up voltage and that is the POK signal. See here all pages it will go. This is the POK. Here also POK. So 3 volts IC and 5 volts IC will give the POK power good. Okay, now what we got? 3 volts LDO VLP we got, 5 volts VL we got, 5 volts always we got, and 3 volts always we got. See, through this jumper 5 volts always we got. Okay, now this 3 volts always, 5 volts always, charging IC from charging IC 90 volts VB. Okay, and SM bus, SM data, through that battery started charging. Now 3 volts always we got. So where it will go and what are the sections it will enter. So next it will be entering here. See, this is the RAM section. RAM is nothing but S3 state. Okay, S3 state. This one later will start. Before that, one more voltage will generate. See here, 19 VB. It will enter here. So this particular IC, what it received 19 VB. Enable from where it will come, this SIO SLP SAS. See, the POK already we got. This SIO SLP SAS is from the PCH. PCH signal will release this signal. Any one signal will come here. See, PCH prime enable also will come. So those things once it entered here, so 1 volts always enable will be there, will be present. So here is the PG ground, AG ground, and here is the bypass and boot, and LX is the output. What output we got? Here 1 volts always we got. And what are the P good? P good is 3 volts always. Okay, so there is no name here at present. So now here 1 volts always P is become as 1 volts prime. Okay, so these are the S5 state. First we need to check this voltage. See, one more voltage is there. We got already 3.3 voltage, right? So that input goes to this PU1801. So then what are the enable? Here is there enable? See, enable is this one. So from where it will come? Same SAS POK and prime also. So once enable comes here, then this IC will generate this one. What is that? 1.8 volts always. So through this jumper 1.8 volts prime will be available. And at a time is the power good. See the power good? What is that? Here is the prime power good. Where it will go? It goes to 25. 25 what it contains? IO will contain. See here, these are the important point has to be noted. SAS, ASH, POK and prime enable. We already got the POK from 3 volts and 5 volts power good. Right. Here one more prime power good we got and it has gone to IO. So these are the important points in S5 state. Okay. Now these are the PWM section generated. Now next, see if you come down, so here is the 2.5 section. It's not yet started because here is the, what is that? SIO SLP. Here is not yet generated. From where it will generate and its power button is on or not, that also we don't know now, right? Now till now the S5 state, what we got, once again the summary, we got prime power good that gone to IO. Okay, and the second thing is 1.8 volts prime. Next we got 1.0 volts prime, and is there any power good for this? Power good? No, it was always only. So next what we got here actually POK SAS SLP underscore SAS PCH prime enable, and what we got, we didn't check this one because it's a RAM requirement. Because see why we didn't check, the enable is SIO SLP S4. It's still now it's not yet come. And now 5 volts always and 3 volts always we got. Here from here POK we got enable 5, enable 3, through this always on from the IO we got. Okay, Now what we got 19 volts VB, and what we got is DC in, we got okay 19 also we got, and we charge 17, that's it. Okay, and PSID, and here is the battery voltage, SDC in we got, and here is the battery signals, clock and data system present. These all gone to charging IC and IO. These are the IO's first required signals. Okay, so just we will check what is the IO, page number 41. 25. Here is the MEC 1416 IO. So what are the signals at present is available. In next class we will check enter IO thing in S5 state. Okay, this one, and PCH voltages, and what are the voltage now generated, that where it has gone, those are PWM sections, right? So once it generated from the PWM sections, see here 1.8, 1, 3 volts always, 5 volts always, right? And the prime power good and so on, PSID, all the things we got, where it has gone, those things we will discuss one by one in next class. Okay, thank you very much. Now the time to generate the Excel. Okay, now what are the voltages we got in S5 state, those voltages we will follow, and using that voltages what are the signals entering in the motherboard, and what are the places it has gone, those things we will note down. See, as I told, first we will open an Excel. Here is an Excel. Okay, so in Excel what you have to do, first you need to check the voltage. Which voltage? First SDC in. This is the source, right? What are the voltage we got in the source? SDC in we got, 19 volts VB we got, and 17.4 bat also we got. So first we will take this voltage and where it has gone. See, I will copy this and I will paste it in Excel. First you have to make it as text. In general, to go to numbers, accuracy, state, time, text. Okay, now again you have to paste it, so you will get this data. Okay, now below this what are the voltages it will generate and where it will go, those things we will note down. First we need to copy this. See, I copied this, and we will search, Control C, Control F for search, and Control V entered. So here total 4 searches are there here. See, one is here. I already explained you how this one generated. In case the signal is not coming here, that already I explained you what are the logic circuits. You need to check this logic circuits. One common thing is these two are P channel MOSFET. Here gate voltage should be lesser than the source. That is the main common things that you need to check. Okay, once you check this output, you will get it here. So where it has gone, again this is the type C section. Again type it's a MOSFET 1 and MOSFET 2, the same logic as before we searched. And where it has gone, see here one more place it has gone. This is charging IC input for this adapter, pin number 16 it has gone, and AC in charge. See here, AC in charge, pin number 19, voltage divider, as a voltage divider it has gone. Okay, so it's very important AC is connected or not. Okay, next where it has gone, so that's it. So need not to worry about this. So here is the main one, what it's becoming, it's main becoming 1 minute. Here one more thing is, here also it has gone. See here is, this is the first CLR. Okay, here is the first CLR, it has gone, and it's becoming as charge SRC. See, this one we can copy and paste it in Excel. And here what it's becoming, here adapter charge, see, to V. Same AC in charge to C to V. Okay, this is over. Anything else? No. Then again we'll come to the first page, and second one is battery side. So here we will give little gap and we'll paste it here. So is there anything else here? Control F, Control V, battery side 3 places it has gone. Here it become as this one, right? So here we'll paste. So next, that's it. 2 over total 26 volts are there. Now 19B, what it will become? So 19B, we'll copy it here. Okay. Next we'll search Control F, Control V. Total, what are the places? 28 places. Leave it. Here 19 through this fuse. Through this fuse, what it becoming? This one. Okay. DC bat LED LCD. So this is LCD voltages. Next, what it will become? Here it's entering to the first dual MOSFET. Here is the output. So here is the PDB01 as input to the charging IC, DC in charge also it's becoming, right? Next, here PJP 301 it will enter and 3V win. See, some technician will get confused. 3V underscore V in is nothing but 19 volts or 19 VB. It may be battery voltage or 13.5 volts. It's not 3 volts. Okay, it's entering to the 3 volt section. That it means. Control C, Control V. Okay, next. Same thing is entering here 5V in, means 5 volts PWM IC is there, no? In that section it's entering. Okay. Here it's a 1.2 section. IC will be there, no? PWM IC. Here it's entering. Next. Same thing. Again it's entering. This is over. Again this one. 1 volts always. 1 volts always. See? Enter here. Next. Here it's becoming 19 volts CPU section. Next, CPU over. So V in, CPU. Here VCC GT underscore B plus. Control C, Control V. Next VGA. Next VGA over. Here this one converted as VGA over. Next 1.35 VGPU. Next, that's it. So 19 also over. Now which one? It's a next LDO will come, right? Once this what is that 19 volts will be entered to the step down IC, first we will get the VLP plus 3 VLP. This one we will copy and we will search. It has gone. So here we give up and here where it has gone. Control C, Control F, Control V. Total 8 places it has gone. What it's becoming? Here is the anode cathode. Here RTC diode. This also a reason. So we will copy it. Control V. Next, here this signal pull up, what it is, system press, power press, this power press. Next, see, always also, and this one also. So what it becoming, VC in 0, where it's going to IO. So total page number also we can copy. That will be better to identify which page number it is. Next, here is the birthplace, because this 3 volt section IC only it's generating, right? So next, that's it. 3 VLP over. Now 3 volts always, where it is, 3 volts always. Copy to the Excel, Control V. Now here, Control C, Control F, Control V. So total 105 places it has gone. Where it has gone, we'll check. We see, Wi-Fi RF enable, using that 3 volts always. Next, this is PCH. We are searching only 3 volts always. Okay, 3 volts always. Bluetooth enable. Next, PCH not required. Here it says input to this IC. Here we are alert. So we are alert. Input. Here SIO SLP LAN. See, these are the very important voltages according to the main voltage. See, signals always. TPM ID also a pull up from this 3 volts always. Next, no. Here this one is converting as 3 volts always DSW. Very, very important one, DSW. Next, PCH. No. Here, see all these voltages converting as on. VCC DSW on. This is the pull up. No, this is the main voltage here, and this also, this also. Okay. So next, USB. Here this one is entering here. So which signal it is? This one. STB P3D3 STB standby. This is HIC, later we will check. See here, this is the voltage, here is the 0, so it may be converting as this one also. Copy. paste and copy it here. Next, see CMP underscore V in. Next, VC reference 0. Next, lid close SIO. Next, breathe LED. Breathe LED, power LED, low activated from KBC. Here VLP and always also this one. So we can consider this voltage also through this. Thermal related information. This one, WAN, in out. Next, here plus LAN VDD 33. Here 3 volts always directly converting as PCH. That's a 0 ohms resistor, right? Same voltage will come. Otherwise, in low key actually, if it is not there, use Z7. Through this, it will convert V in out. Once enable, 5 volts always will come. Okay. More on signal, PCH prime enable. See, this is very, very important. Once this PCH prime enable comes, then only this one will convert. So PCH enable, this is a signal. Once this signal will come, then only PCH will generate. Otherwise directly we can connect it. In generally low key models, here Gen 9 models, here using this UZ1 only, UZ7 only, it's converting. Next, here 3 volts always, VS no, because here bias S3 has to come, this one over. So here CPS 3 volts always. Here max I2C, max I2C data, I2C enable, here data clock over, enable also over. Three volts EMMC. PSID. POK. Pull up for POK voltage. So power good. It's 1.2 V VTT power good. Pull up for this. Power code 3 volts always entering here. Prime power good, pull up. Here 2.5 volts V in. Here limit. That's it. Here is the 3 volts related voltages. Okay, in 3 volts how many sub voltages also are there? See this one, 3 volts PCH, DSW. These sub voltages we need to check one by one. Now these all are the voltage required, I mean generated, right? So here one more voltage is there, you can check this one also. Now Control C, I will check what are the voltage by this in the schematic. Control F, Control V. Here total 16 are there. So intruder, see one more signal from this one we need to copy. Intruder, next RTC cell has become as RTC cell PCH, correct? So this one we have to copy. Next here one more RTC cell PCH. This is over. This one PCH only. Here 3 volts always with signal it is V3D3 STB. It's a part of this RTC cell. RTC cell RTC VBAT. Next this is cell. See here power switch in and one more power switch MB. Here we will copy paste. Okay, next the signal name is VCI in 1. VCI in 1. Next, these are all patience work, so please give some concentration. If you give some concentration on it, so next motherboards will be very easy to do the troubleshooting. Okay, now this sub voltage over RTC cell, here PCH is there, just we will check any sub voltage or sub signal using this. Here Yes, reset. So again we'll make one more insert column, insert here, we'll paste this one. What are those signals here? SRT, RST. See, those all are important, right? We should not neglect on this. See, should not neglect. Next, what are the voltage? Here. Point will be there near the RAM section. JC MOS 1, always open, not solder. Next, this one only from the PCH. TC. Over. Now RTC cell over. Next, in 3 volts always, this one Wi-Fi, enable Bluetooth, alert, SIO plan, ID. This one we will check. This is main voltage. Here. Okay. This one Control C, Control V. Here SIO power button. Okay, next here also is there. Come to this PCH bat low. AC present. These are the power management of the PCH. LAN way cache. Next. Which one? VCC DSW on. This also belongs to this. PCIe way cache. Next, that's it. DSW on over, and this one Control C, Control V. We will check what are the sub voltages. Control F, Control V. It gone to IO. Here pin number 22 supply, 115 supply. Here is the supply. Model ID. Okay. Model ID and board ID. Okay, this is very important. And these are the signals here. See, P bat charge, SM bat. It's a battery charging voltage. Signal. Very important signal to charge the battery. These two are clock and data. Same thing, SML, SMB clock. These are the communication path. Some L clock. Here type C, SMB, DA data. It's a type C data. Type C clock. CCG 4. Okay, next, not there, next, power select, power select one also, no, this outputs, that's it. Next voltage, this one over VCC double N, it's a PCH plus 3 volts, always PCH. This is one of the important voltage in power plane, power rail. See, memory SM clock. So this one now, here we will paste. Now we will copy this, paste it here, data, paste, paste, paste. All data and clock through this voltage only, PCH voltage only, it's going to the motherboard. Okay, this PCH over, here GPP C5. Three volts SPI, it's a bias related voltage. This one we'll check next time. KB detect hash, keyboard detect, RTC detect, SIO extension way cache, NRB bit, USB OC3 hash, OC0 hash, OC1 hash, OC2 hash. Speaker is from PCH only. Okay, speaker. HDA SD out. PCH, direct input to the PCH, HDA, here same thing, engine, no, ME, APF, WP, PCH voltage, that's it. Anything else? Any important voltage? It is over. PSID, prime power board. See, these 3 volts always related, all over. So now next voltage, what it may be? 3 volts DSW over, PCH over. Now 5 volts always. Shall we check 1.8 volts prime? Okay, prime later we'll check. 5 volts always. We'll check now. What are the sub voltage? 5 volts always. Search. This won't be much. Maybe USB. This is the output from this only. Anyway, we'll copy this because all USB related and LED related signals will generate through this 5 volts only. Here is the pull-up power share V bus. Next, ambient light LED. It's the most important voltage once the signal will come. Now white LED bat. White LED power. Next, input and output 5 volts HDD. Five volts connection P. In out, but enable has to come. More back, or enable has to come. PSID path. Here is the input, is the protection. Birthplace. No. It's entering to somewhere. See. One minute. VCC core 1 as a supply, it's entering. That's it. 5 volts over. Next, which one? Here will be always over 1.8 volts prime. ESPI alert, it's a pull up. Next, project ID 0 and 1. I already told it's a 15 and 17 project ID. .8 AVDD. No, actually here it's a VS has to come. 1.8 volts always easy. It has given. EMMC RST hash. Pull up. .8 volts EMMC. .8 volts, that's it. Next 1.0 volts prime, this is the last voltage. Control V, total 28. Here XDP. No. Put here 1.0 volts clock. The clock. 1.0 volts clock 4. APLL. Clock 4 over 5. MPHYGT. While doing the bias editing, this all will come in the picture. Yes, RAM. APLL, copied, right? Yes. We reference CPU. That's it. See guys, if you do practice like this, initially it will be very difficult, but later on this is the output will give you the strength for troubleshooting. Believe in me, so definitely it will be useful, this kind of Excel. Okay, in today's class, that's it. All S5 stage voltages and signals we found. Okay, what are those? We already noted down. Now what are these signals, where it will go in next class we will check completely. Okay, thank you very much. Welcome to Pavitra Laptop Care. See, in previous class we have seen these are the voltages, basics and S5 state voltages and signals. Okay, once these all voltages are okay, then using this where it is here, it's a SPI. Using this voltage we will get the bias working state. So that also we need to note down. See here, that also S5 state, S5 S4 state. In some conditions S4 state won't be there. Okay, so only S5 state will be there. Now here 3.3 volts SPI. Using this, what will happen? We'll check one by one. Okay, what are the signals it will generate? See here, from PCH only this SPI generated, and here PCH SPI CS0 is the one signal. Next here PCH SPI D2. Next PCH SPI D3. Okay, this one came, and next where it will go? Here it will enter to bias chip, means it's a SPI flash chip. Okay, it's not bias chip, it's a it's a technical name is SPI flash chip. That's why its SPI name has given. Okay, so here is the input. Next, which one it will carry? This one already over. This one XDP SPI SI. See, next where it will go? Here it's entering to XDP. Okay, it's a scale, it's a PCH only. Here the 3 volts always, you see 3. TPM device, it's entering to TPM device also. That also we have to note down. That's it. Okay, SPI over. Now what are the things over in IO? See, 3.3 volts always, EC, PCH, 5 volts always, 1.8 prime, 1.0 prime. These are the voltages we got at present. Once these all are fulfilled, now IO will release what? RSM, RST. So where we have to go? We have to go to IO page. So this is the IO page. It will release PCH, RSM, RST. See, this signal, it's output, right? Control C, Control V. This is IO signal, output. Later we will consider, segregate all the pin voltages and signals. Okay, so here is the output. So where it will go? It will go to PCH. Okay, one signal will get output and the second one also will release. What is that? Now once RSM RST is generated, then it receives power switch in. Okay, now the term is power button. See, always you have to remember only in two conditions laptop will work. One is before pressing power button and after pressing power button. Here is the before pressing power button. What are the signals and voltages we have got? So whole thing we have noted down in Excel. Okay. Now the power button input, right? It's input to IO. Now power button in will be there, and next what it gives output. So the output is here. Somewhere the main output goes to PCH. See, 11 in the sense it's 11 page number, it's a PCH SIO power button. This is the output. Now once the output goes to where? PCH, then what PCH will give? That also very important. Now these signals will go, then see, bias is okay now. This power button also pressed. Now power button is pressed or not, PCH has to be understand, right? So that's why this voltage goes to PCH. Page number 11, directly it will go. Okay, so copy and paste. Here is the 11 is there. here is a PCH, it will go to here. Once it enters, immediately it will release SLP S5. See, nothing is there. SLP S4, this is a signal, it's going to 3 pages. And next SLP S3, this also going to 2 pages, and this also going to multiple places. First it will receive this one, SLP S5. So now PCH will give this one, and now it's a SLP S4 output, and now this one 3 also will note down, but before that in S5 state we will note down this one. This is S3 state actually, so this also we can note down, and this also we can note down, but this is the last state. Okay, now what we have to copy, this one we copy, nothing will be there, only 2 places, no, nothing is there. Okay, now what we have to copy, this one S4. Once a PCH release this S4 signal, then what are the PWM section will generate, that we will check. Here is a test pad. Okay, here it's coming out, and here it's entering. What is this? This signal is generating plus 1.0 volts VCC ST. See, using this, here one more I have to note down, this is SLP S4. Using this, what we are getting, see, this UZ1 will generate V out. V in is this one, it's a prime, 1 prime to 1.0 VCC ST, it's converting here, correct? See, this one we need to copy in Excel. So now this voltage released, and this one we got, and where it will go later we will check. Anything else in S4 state? See, one more thing is there. Here is the enable signal S5 to the RAM section. Okay, once this signal has come, then VDDQ will generate. See, this VDDQ will generate. So now we have to note down this VDDQ. Here the output is here 1.2 VDDQ. Okay, now we have to copy this one, will generate 1.2, copy and paste. So now we got 1.2 volts RAM voltage. Here S5, okay, it's not S3. S3 is too far. Now we are checking this S5 state, means it's a S4 state. S4 signal has come here, and it will generate 1.2. And next voltage, what is this? Check. See, one more voltage we are getting. What is that? It's a plus 2.5 VP. Any jumper? Yes, this one. Through this jumper, this is the voltage will generate. Now using that PCH output S4, we got 1.0 volts VCC ST, 1.2 volts VP, 2.5 memory voltage. Where it will go? It directly goes to RAM slot. Okay. Anything else using this? No. Okay. Now what we got? We got S4 sub related voltages. See, now we will copy this one. This one we will check where it has gone. Oh, it has gone 19 places. Okay, we'll note down this also. Place it here. We'll check any sub voltages are there. Here is the signal. See, here is the VCC ST power good signal. So this one we have to copy to paste. This is a signal by 1.0 VCC ST. Next, pro chart, processor heart signal. Okay, this one is by this one STG. What we copied now? Oh, STG is a different one. Okay, anyway, now we will copy only this one. Hot thermal trip. case thermal is increased, then thermal trip will happen. This one we will check how it generated. Now any other voltages? No. Here it directly goes to PCH 19 of 20. So here is the subvoltage SOG XDP TMS. Oh, sorry, this is VCC STG. So now 1.0 VCC ST, it has gone to input. Source. Here it has gone as an input to the PCH. No. Here is the input to this hardware processor heart. Okay, this is the output, the pull up. That's it. Okay, this voltage over, from where we have to calculate, so page number 25, PCH. Okay, now next signal is 60 over thermal trip over. Okay, now 1.2 volts VP, what it will do? So we'll check the birthplace. See, here it's entering through this coil, or this is the output. This is the output from the RAM section. Okay, next where it will enter. Here actually this one is converting as DDR. This one we have to take instead of this. Okay, now we will type this 1.2 volts VDDR. This one we will search where it will go. It's input to this particular file leg and it's generating 0.6 volts DDR VDD on. It directly go to page number 57. Okay. Next, see, this is the input to SKL RAM section. It's a processor section. 14 of 20. It's a processor voltage. Okay. See here. So 1.2 DDR VDDQ section. Next, this is a RAM slot section. Okay, it has gone to RAM slot. Here some capacitors are there. Here this is the pull up HDRAM RST hash. This is very important signal. DRAM RST is the pull up from this one 1.2 volts. 1.2 volts DDR. This is other RAM slot. Some capacitors, RAM slot. Here this voltage is converting as VCC SFR OC. This one we have to note down. That's it. 1.2 volts over. This one is 2.5 volts memory where it's going. If these are more, then we will note down. Here 2.5, paste it here, check where it has gone. It has gone to RAM slot only. Okay, it means DDR4 has 2.5 volts memory voltage. See, this also memory. Other than memory, it not gone anywhere. Okay, now this SLP S4, we got the RAM section. This RAM, what it does, it will generate 1.2 volts DDR using the S4 state and VCC ST also. This one will go to direct processor and this one goes to processor and RAM section, RAM slot, and 2.5 will go to RAM slots. Okay, now the S3 state started. Now this one is PCH, this one, this state, and here this state. Next this one is S5 state to S3 state, we can note down. S3 stage, once press the power button, this is the S3 stage we call. These all are S3 stage. Okay, now what we have to check. Now RAM we got from the processor, one more voltage we got, that one. See here, this is the RAM IC. Here is the pin number, page number 7. 0.6 volts DDR VTD on. One more signal from where we got, that we will check. Okay, this is I copied and pasted here. Here DDR VTD control. Once this enable comes, then only we will get this one through this VS. But which one has given here DD VTD control? This one will check. DDR VTD control. This is coming from the processor. Okay. So here immediately one more voltage is coming from the processor. When it will come, we will check. See here, we will note down VTT, DDR VTT control from the PCH. Okay, using that voltage, what we got? We got 0.6 volts. This one is the RAM section. It has gone to RAM section. Okay. Sorry, this one is here and this one cut and paste. So now what we got? We got SLP S3. SLP S3 here. PCH, this signal, what it does, that we will check. Later that 0.6 also we will check. Now this S3, what it will do? It's a total 10 are there. Here it will go to this and always. See, we got this one 3 volts always, and here this output we can copy. All system power good using SLP S3 means we will copy this one, then this one here we will paste, and this one we got, we will paste it here. All system power good. Next, using this signal, what are the voltage will generate? Here is the AND gate. See, S0 and S3 both should be matched, then only we will get this voltage. Next, this is the input. Yes, so VS we didn't get. See here, actually when SLP is 4 over, then we will get this signal. Here the conversion of 5 volts VS and 3 volts VS will be there. Then here is the 5 volts is converting to 5 VS and 3 volts always is converting to 3 VS, means through this we got plus 5 volts VS and 3 volts VS. See, this one is finally we are reaching S0 state. Okay, all related to this will be S0 state. So now here it mentioned S5, I mean 5 volts and 3 volts. Here always and 5 volts will convert as this one. So now here is the AND gate and S0, both AND gate will produce this voltage. Okay, so here is the int clue. Next, what signal it will generate? That's it. Now we will check this one. We didn't check this one. Well, check what are the voltages it will generate. 5 section it has gone. This is the output. See, here is the S3 state, correct? 0.0, this is the enable signal to this S3, and this RAM section will generate VTT volts. What is that? It will generate 0.6 VTT underscore VTT. So it means this one will note down here. So this one will generate this voltage. Okay, this one will generate this voltage. Now what happened? S3, all S3 state now ready. So RAM is in S3 state, SLP S3. Okay, now from S5 state to S3 state we reached. Now what we got? We got 5 volts Vs, 3 volts Vs, all system power good. Let us check this one will generate any other voltages or not. Here is the output. Here is the input to this 5 volts, 5 leg. And here is the VCC ST power good. See, this is very important. Then we will note down this, copy, and we will paste it here. Using this, what we got? We got this one. Okay, anything else here? It's a total 6 points. Here also one more. All system power good. 1.2 VTT power good. Here's the 3 volts Vs. See that Vs should be there now. Then Vs related voltages. It's a pull up. Next, this is the input to what? IO. See, here is the input to IO. The same signal. That's it. Now what we have to check? This one we checked. Now 5 volts Vs. What are the carried signals? This is S5 state, right? So here Control V plus 5 Vs. 24 places it has gone. So what are the pull up voltages? We will check. Here 5 volts become as plus 5 PVDD. What is that? That we will check later. Oh, here 5 volts VC should be here. Okay. Now any other signal? No, here 5 volts mode, 5 volts AVDD. It will convert. Next 5 volts, 3 volts will carry fingerprint VCC. Fingerprint VCC. See, both are carrying, any one will carry. Next VCC through this fuse plus touch panel VDD. Touch pad is there, no? That one will work through this 5 volts Vs. See, here is the fuse, 5 volts Vs. Next 5 volts, it's a KB backlight. Keyboard backlight will start by this. Okay. Here one more, it's a caps LED. Using this 5 volts only, caps LED signal will come. Now here fan, J fan 1, J fan supply. See, the fan will be there, no? Fan voltage also, this 5 volts. PS, caps over. Next Yes, ODD in the sense it's a DVD writer. If you have DVD writer, that is a ODD signal. It means this particular model has a DVD writer. Here it's entering to OCB, its output is HDD. Enable is 5 volts always. HDD enable PCH. Through this only it will come. Next, HDD over. Next, through this diode, what will happen? Through this diode, so here HDMI clock and HDMI data. So through this 5 volts it will generate. See, HDMI clock and DDC HDMI data. One over here all HDMI related voltage. Yes. See, all HDMI related, this is the main gate voltage. Once this base voltage will come, all will go to ground. See this, these are the path. 5ES, 5E HDMI through the fuse. 5 volts HDMI. Next VS is for VGA port. See, this VGA port also has 5 volts. Next, where it will go? This is the output. See, 3 volts, 5 volts always. 5 volts over. Then what we have to check? These 5 volts related voltages. Okay, next, which one we have to check? It's a PVDD not required, this one not required, ODD not required, HDD, these all are not required. It will go to only one places. This is the fingerprint. And all system power good also over. Now what are the things? Now 3 volts VS. Okay, now this one we will check. Now we have to check 3 volts VS always, not always, 3 volts VS. Now here it will enter to this IC, we'll check later. It is a pull up of DGPU power. Okay, DGPU power. Okay, next here is the power code of this one. Next here CPU DP clock, CPU data control DP1 DP2. Here Wi-Fi also, so bit 2 data and Wi-Fi RF enable. Here also 3 volts always also, this is Wi-Fi RF enable, and through this also it will come in low-key at. Next, here is the ECC output. See, this output will come from this. Okay, this already we got, but anyway, finally we will get it from VS. because this is the pull up voltage. Next, PCH SMB data and PCH clock. See, PCH data and clock, now communication started with the PCH. The processor started PCH communication related. See here, data and clock communication path. Next, memory. See, it will start talking with the memory also, RAM. Now what are the voltages has come, but now the what? Now it's a communication path started. Without communication, it will be dead condition. See, memory communication, now HDMI communication over, and before that PCH communication over. Now it's a memory communication happening. Memory, this one will enter as this one, PCH SMB clock. Actually this one we need to copy. Okay, this one here, and PCH SMB data. It's a bidirectional. Okay, next what we have to check. Next, this is the one. This is the pull up of this one, INT SPI touch. SPI touch. Here VS is the SDD enable PCH. I know you people not understanding what I'm doing, but this is must, you have to note down. Later on, again one by one I will explain. Once you make this ready, that Excel ready, then everything you come to know why this Excel is very very important one. Okay, it will be little boring, but you should do this. It's a starting only. Once you do the practice, definitely you will become a master, one of the master in laptop chip level service. Okay, here one DIMM. Here is a DIMM selection. Next, see, once you come to know, next I will compare with the other motherboard using this. Okay, it's board ID 2 and board ID 1. Yes, signal. Ready. Now you come to know SLP S3 has come, then only 3 volts VS and 5 volts VS generated, converted. So now board ID over. Here is the VS signal SATA LED. SATA LED. If you are facing any difficulties to make this Excel, then I will give my notes to you if you ask in Telegram. Okay, here is the power supply of this AND gate. Okay, the AND gate, and here system reset hash. System reset hash. System reset hash over. Here system reset hash over. Anything else here? No, again and again it's showing here. It's actually PCH clock signals. Oh yes. These are the pull-up. See, this is the pull-up signal. GPU clock request. Okay, this one we need to copy. That's why again and again it has come here. And one more pull-up is WWAN clock request. Next, this is the one more pull-up. And here one more pull-up. Request signal is entering to this clock signal section of this PCH. It's a processor. All communicating with the PCH. LAN, WLAN, GPU, SSD. How it will communicate? Later I will check and I'll tell you. It's a touchpad introduction. See, once 3 VS comes, all component will start working. The signals will start working. touch screen PD, DGPU work, now is there anything else here? Here WW CBL detect, cable WLAN cable detect, three volts will enter to this one. This is the dim one in the PCH sock section. Here capacitors, here dim. Yes, see these are the main signal in RAM section. SA0, SA1, SA2. Here is the SA2. Next set over. Now can you pull up? No. The prime to 1.8 VDD. Once this voltage will come, then this one will generate. So we'll note down. Here 3Vs DVDD signal. Okay, now this one is the pull up for fan torque. Okay, it's going to I/O. Here is the op amp input comparator. Actually, here is the input to the JIO USB 2 card reader. Here is the FPP. Already we copied when 5 volts VS came. Now this signal also belongs to that. Here FPR scan, fingerprint scanner. Here is the camera section, LCD section. It's a camera section. It's converted as this one. It's a pull up of this enable DBC panel enable. Next 3Vs belongs to this, means it's a T-pan VDD touch panel voltage, because your 5S also is the 5Vs. Next here DBC panel enable R already copied. Okay, next camera voltage. See, once 3Vs comes, then only your camera will work. Panel over camera, SATA LED. This is depend on this 3Vs only. Yes, the dash should come. Touchpad VDD. Here I2C touchpad communication signal. It's a SDA and SCL. Here is the supply to this device. Next, here is the cap LED hash signal. Go to here, and here is the cap LED. So here cap LED signal goes through this pull up. Next, here touchpad over. Once again I'll check. Touchpad over, clock and data. Next, THM SML, thermal related information, I think so. We'll check later what it is. Clock. See, here is the input and here is the output. Okay, let's get this. Next, nothing is there. Here is the pull up of SATA ODD present. Next, SDD detect VS is required. Next, here low key 3 WLAN 3.3 volts LAN. Here DDC. Actually, here is the gate voltage. So here is not required. Already 5 VS has taken. Here, what is that? WLAN connection. Here also it will go. Next, where it will enter, that section we will check in next videos. Okay. Next, here is the IS. Get a little big. What it is? Okay, let ISO light. Next, here is the output. SSD. Okay. SSD. VS underscore SSD already over. PL0. PEQ. CFG0. PL1. Next, CFG1. Next, so this one over here is the input to UT5. Here input, VGS output. It depends on the DGPU power enable. Maybe finished. Yes, 3 VS got forward. So now Here is the S0 state. Okay, S0 state. No, it's actually S3 state only. So when it will come, that we will check. So till now what we did, that's enough. Now in next videos, in deeply, we will check what is the S0 state and what are the voltages we will get. The processor voltages and all we will check. Okay, that's it, today's classes. Thank you very much. Don't forget to save this Excel. Over. Thank you. Now that time to check SLP underscore S0 hash. So what are the voltage will generate using this signal, we'll check. Okay, one by one. So now SIO SLP is 0, total 7. Here is the AND gate. See, we already got S3 hash. Now it's a S0 hash. Both AND gate will be positive 1 and the result will be also positive, right? So what we got? We got VCC STG enable, and finally what we got here inside we will put, and here this is UZ2. Here 1 volts prime already we have, 5 volts always also we have. So the output will be plus 1.0 VCC STG. Okay, this is the output from this. Okay, from this what will be the output, that we will check later. So now again we will check. This is going to UX1, okay, as input. Now again here one more VCC DSW on. This signal both are equal, right? So that's why this also I will note down, DSW on. Next, that's it. So now using this S0, what we got? We got this voltage. So this one we will check what are the voltage it will generate. Okay, now control V, control paste VCC STG. See, STG using this pro chart. It's a processor hot. Next, it is nearby. No. Next, STG SOC XDP TMS. Next, SOC TDI. SOC TDO. Okay, next where it will go? Here is the input to this one. 12 of 20 means it's a PCH. Source. Here again it's moving to SKL, BGA. Next, this is the one is converting as VCC IO. VCC IO, it's converted. Next, VCC ST. Okay, it's at as given, but anyway, already VCC ST, one more VCC ST we already saw somewhere here. Is that somewhere here? VCC ST, VCC GT. Okay, STG here somewhere. We'll check later. In this only, I think so. Okay, anyway, we'll check later. So one more VCC STG. This is already over. Next, see, IO both we got. Okay, that's it. Now what we got? We got this one, VCC CIO. So this one using this. Here, see, this is the main voltage to here DDR3 and 4, 3L also. Okay, this is SKL RAM section voltages. IO means it's a RAM section voltages 1.2, and here is the input output related voltages. Okay, here it's required. Next, see here it's entering. No, actually these are capacitors. Nothing else. Here EDP comp, it's entering to EDP comp. Okay, see these all voltages, after these all voltages, these all are input. Okay, some of them output also. So here nothing is not required. So here VCC ST already done or what? Okay, once again we will check this. ST is the output. See, all system power good. Once this one will come, we will get this voltages. VCC ST power good. Using this, okay. Anyway, we will note down. Control C. Here, Control C, Control V. Here, H positive. We already done this one. STG, okay. Here processor select went. Next STG not required. STG not required. STG not required. CST source. See here SLPS4 is converted as VCC. We already done this one. It's not required. Okay, next, see these all are the inputs and outputs and basic voltages in S5 stage, S4 stage, S3 stage and S0 stage. Now till now we didn't get the core, right? For core what we have to do, that let us discuss, let us check. Now I am going to save this. See guys, here 1.2 volts VTT power good. See, it's released from RAM IC. Okay, once this release, here we got two signals. So one is all system power good and one more is IMVP VR on. This is the last signal after getting the sleep related signal, means it's a SLP S0 state. That signal, after that here is the output from this side. Okay, this where it will go, that is the main important point. See, we'll copy this, we'll check where it will go. IMVP, this one I noted down here in Excel. So where it will go, only 3 points here. See, this is the input from 11th page, means it's a processor. From processor RPCH, SOC will give the enable CPU signal. See. This is the most important signal. Enable CPU. It means it will enable the CPU. Okay. Now this one will come to this, and what will be the voltages? What are the things you will get? So here we reduce the page. This is the CPU IC. Now enable signal will come according to the requirements. What voltage will generate here? This is here is the CPU output. What output? One is VCC core. So here VCC core, and this side also VCC core. Okay, 2 VCC core we got. Okay, and next what we'll get? VCC GT. Next VCC SCA. SAGT core will generate once we get the enable CPU signal. Here is the PWM 2, it's a GT sense. Okay, GT sense. Here I'll tell you in deeply next time. It's a V core signal, V core. Okay, here is the SA sense. How this one will work later I will tell you. The main point is our IMVP and we are on we are on. Once this signal will come, what are the voltage it will generate. See, once this one comes, this one already generates this kind of voltages, main voltages. Okay, now again we will check where it will go and what it will generate. IMVP also we have to check one more time, because one more signal, power good signal is there. Using that, what it will generate. See, this is the core where it will go. These are the capacitors. It's a 42. This is the core 42. It will convert as VCC core 42. And any special is there? That one we will check. More VCC core 42. This one we will copy. Next, what it will generate. See, here is the one more important voltage. VCC core entered CPU power. Okay, CPU power. See, these two kind of processor. Next, core 42 also generated, same thing only, VCC GTX. Okay, GTX. It's a graphic core. Here is the VCC core entered CPU. VCC nothing but it's a CPU VCC. VCC over. Next, this one GT. We'll check one by one. GT generated here. Capacitors. Here GT will do this one. This signal also we have to copy. What it will do? It will do this one. It will convert to 42. Means 42 processor is there. No? For that it's required. It's a graphics processor. That's it. See, one of this. GT supply. In supply. K52 also it will generate. See here. 52. Next, K52 supply, that also GT. See here sense. This is GT. See, now CPU received core VCC IO GT. GT over. Next, using SA. SA generated capacitors. Here one of the power rail. Supply. That's it. Okay, now IMVP power on, VR on is there, no? Now one more voltage it generated. Which one? All system power good. Where it has gone? It will go to, where it will go? It goes to, see, using this only, this VCC ST power good will generate. Okay, if we consider this one the main, then H VCC ST also will generate. Okay, now where it has gone? It has gone here, all system power good. In this, it has gone to pin number 73 IO. Okay, one more input. It has gone to IO input. Save. See, once it entered to the IO, what IO will do? IO will release immediately one output to see number 11 means it's a processor, right? Reset out one output will released by the IO. In Excel we'll put what it will do. It directly goes to where? To the processor. So output from the IO, it goes to PCH. See, this is the PCH. Okay, what is that? Actually, it's a PCH power. Okay, enter to the PCH power. Okay. Anything else? Reset one. Here hash has given. So sorry, by mistake I typed. Here 7 places. Or so nothing else. Next, what will be the output? The reset out is out from the IO, and at that same time one more output will enter from the IO. What is that? What is that? What is that? System power. Okay, now everything is okay, right? Reset out also okay. Now system also okay. That directly goes to where? 11. It's a CPU. Now this voltage also will go to processor. System power okay, and reset two outputs from the IO. This is IO output. Okay, next IO output. These two output goes to processor. Then what will happen? We'll check. This one will copy. Anything extra using this? See, these two signals, reset out and system power okay. These two, once it entered, what CPU will do? Finally, the PCH will release PCH PLT RST. System power management will release PCH PLT RST. Finally, this is the final output. Actually, not only this one, multiple are there, but according to the first, this is the final output. PLT RST, where it will go, we'll copy and we'll paste. Here somewhere will be the adjustment. See, PCH PLT RST from the 42 page number. PCH PLT RST. Here is the AND gate. Both are PCH PLT RST. Those things will convert as a PLT RST hash, and here it will go these areas. Okay, this is the AND gate, and here is the output where it will go. PCH using AND gate. So this one will be the final output. Here what we have to do? Here we will type here. Next, this PLT RST will go. Where will go? Here is the AND gate. Total 18 places. The output. It will go NPCT. What is this? 650. It's not there actually. It's a TPM device. UX1 is the TPM device. Okay, it will go to TPM. Okay, later we'll check where it will go. Second one is it will enter to debug connector, and next where it will connect, this is WLAN connector, PLT RST. Next WWAN connector. Now PLT RST is UL1 RTL. Maybe this is audio RTL. Okay, Realtek, maybe LAN, sorry, LAN IC. So it's related to LAN, WAN, WWAN. Okay, next it will enter to SSD. Next it will enter to where it's eMMC RST. See, using this input, we already have this one and this one. It's a 1.8 prime eMMC RST. Okay, this is the output. Next, PLT RST DGPU hold RST. This is from graphics. Okay, see, this is the processor only generating. So the output is PLT RST VGA. It's a graphics. This goes to IO. Correct. So this goes to IO. Next, where it will go? That's it, guys. From beginning, okay, from charging IC to core, okay, all PWM section will generate, and finally it gives the PLT RST signal to some particular points, means particular devices, LAN, WAN, and what we have seen, all the places it will go. Okay, so here is the Excel. This is very useful one. I will show you in future how it will be useful. If you do one or two Excel, then you come to know what are the status. In case if you don't have any schematic or any board view or anything, so then this will be the useful to identify the troubleshooting in other other motherboards. That's the reason I told you to do these things. So now from here to here, PLT RST. Okay, we noted down all the things. Still many are there that I will tell you what are those. Okay, now that's it, today's topic. So next video we will check in thoroughly what are the missing points. So here is the main signals from the beginning to end, what processor will give as the output, Okay, that's it. We'll see you in the next video. Till now we have segregated the voltages, in what state what voltages it will generate and what signal it will generate, right? So now what we have to do, just we will check the schematic, overview of the schematic. So what pages, what it contains, that much only we will see in this video. Okay, now this is the cover page number, total 65 are there. So number 1 is cover page. In this cover page, model number, all information will be there about the processor and all. So what are the present one, what are the absent one, so all information is here. So next, second one, here what it contains. See, this is the SOC, PCH, and this is the processor. So this complete SOC, this is a combination of PCH and processor. What component it connect? See here, bidirectionally. These all will depend on this Excel voltages and signals. Okay, still more are there, but we will do all the things. I will arrange what are the voltages, what are the order wise. Okay, order wise I will arrange the voltages, and if anybody wants, please put it in Telegram request. So definitely I will share this Excel to you people. Okay, now this is the CPU. Once it receives all PWM voltages and signals, it will start communicate with each other, with the component devices. See here, it's a GPU, page number 44 to 48, 49 to 50, it's a VRAM details. Here is the RAM details, here is the port 1 USB details. These all are the USB details, USB 2, USB 3, EDP, DDI. DDI is the max HDMI section. Okay, so here is the VGA and HDMI section. So here is the type C max, it's a type C. Here USB PCI section, even SATA and all, it's a PC, it comes under PC only. This is the audio related. eMMC, FFS, 2.5 SSD, HDD, ODD, all the section will communicate with each other. See, these are the bidirectional. Here is the SPI ROM 16 MB, it's a page number 8. Okay, here is the 26 TPM devices. See, that BIOS will communicate with the TPM as well as this processor also. So here SMSC KBC 1416 is the IO. Okay, make 1416 NU. Here this one will connect with the keyboard, page number 30, fan, and thermosensor. This is a different model. According to the model it will vary, or maybe it is in data board. Second part, here you can see the power state. Here is the state and here is the signal. So in S0, DS3 to S0, what are the signals, what are the condition? Here is the high when S0 state will come. See, including clocks, everything will generate. Here is the USB 1 to 10. So what it contains, pin number 10 will contain this one, and 8 this one, 1 is this one, like this. Here is the USB 3, here is the USB 2 1 to 10, and here is the USB 3 1 to 6. Actually these all are the PCI, and here is the SATA. See, SATA 0, SATA 1, what it contains, SATA, HDD, ODD, SSD. Here is the PCI it has content, not SATA. Here NVMe is there, no, it's a PCI. Here is the star mark given, so it means it may be present or it may be absent. Here is the board ID. Board ID is very, very important. So what are those board ID or model ID? Here the pull up and pull down, two registers will be there. That condition it has given. What are the values? Okay, pull down always it's 100 ohms, and pull up will be this type of ohms. Here EVT, DVT, DVT2, pilot. These are the model number, model ID. So what it contains, one more thing is, here is very, very important, voltage rail. See, till now in Excel we found all kind of voltages. Total 26 are there. All 26 we noted down in the Excel. Okay. So even more are the those are there. So those things later we will check. Okay. This is high speed mux. So what are those high speed? All information is given here. Okay. It's called index and configuration. Next, this is very, very important. What we saw the adapter conditions. So adapter and battery side, it will give the 19 VB. Okay, this 19 VB will enter to these kind of blocks. Okay, these kind of ICs, these sections. Here one thing you have to note down, here is the peripheral devices. See, the blue color one is peripheral devices, and here is the CPU power. This orange color, everything is CPU power. Green color is GPU power, means it's a graphics. See, what are the main CPU, it will enter, the voltage will enter to the CPU. Those are 1.2 DDR, DDVTT prime, here VCC IO, MPHY, VCC ST, and so on. Here this over, and here 1.8 volts prime and 2.5 memory, VCC GT, SA, and VCC core. Anything else, it's a CPU related over, and GPU related is the green one, 1.35 GPU, here's a memory GFX, and here VGA core, and here 1.8 VGS, here EMMC. Okay, anything else? No. And next, here also it's a 1.95, and next one is peripheral device power. So what are those? These are the peripheral devices: LCD, RTC, 5 volts always, RTC, VCC, 3 volts always, 3 volts always, VS. See, all blue marked are peripheral devices. So the main thing is that 19.5 volts will enter to this section, and then CPU voltage will generate. So using this one prime, again CPU voltage will generate. This one is GPU voltage. And here using this, here is the two GPU and one is peripheral devices, LCD. It will go to LCD. Using this, here 5 volts always will generate, it's a peripheral one, and again this all are the peripherals, these all are the peripherals. So 5 volts, it mainly belongs to peripheral, means all USB, SSD, VDD and all. Okay, see, these are those things. Here type C also 5 volts, it's a peripheral devices. It will be belongs to 5 volts always. Next, here 3 VLP. 3 VLP, it's LDO, only it belongs to RTC section. And next 3 volts always, see these sections it will enter. These are the peripheral voltage, and here is the CPU voltage, here is the GPU, and here is the peripheral. And same thing, 19 volts will enter here, and here is the CPU and VGA. Okay, so here only you can identify where 19 volt sections will go, 3 volt sections will go, and 5 sections will go. Okay, now actually this one is power rail. Okay, now this is very, very, very important. Okay, because this is SM bus block diagram. This is the communication channel. Using this only, the particular KBL, it's a processor, will communicate with this what is the devices. Here is the DIMM A, DIMM E, two slots are there, no, DDR4. So here is the what is that, maybe fingerprints and VGA. Here is the KBC. It's a IO controller, thermal section, TP touchpad. It's a battery connection, charger, MUX, Type C. MUX is belongs to this Type C only. So PD section, what we call, no, that is a PD and MUX. Here Type C connection. These are Type C. It will talk through this Type C and charger and battery. So once it will talk, then only it will decide we have to charge the battery or not, battery is present or not. All the information will come through this, what is that, talking areas, talking communication signals. So this one is over. Now actually the concept you need to understand, because here is the sock blocks will be there, no, using that block where it will enter, those things it has given. See, here is the page number 33. This sock blocks are, one is DDI. Using this block, HDMI will connect. Here CPU DP also is given. This also is HDMI section. Is the 39 DP is display port. Okay, and here also display port. This also belongs to HDMI. And here is the EDP section. See, page number 28. We will check when page number 28 will come. That belongs to this EDP section, like that. You have to check. So all these signals, here is the single, I mean it's only output. Here is the bidirectional. Here is the bidirectional is the touchpad. Okay, there is a soldering point will be there that you need to check. Here is the inputs. So these are the blocks. Almost 24 to 26 blocks will be there. What are the important? Those things here it has given. Okay, here is the CSI block and EMMC block. That's page number 42. These are just overviews, but in deeply in particular section I will take, for example, EMMC, how it will work, what are the input voltages required, what are the signals required, those things in future videos I will explain other things. Okay, now just generally I am explaining what are the pages. Now it's a 6th page, total 65 pages we need to check. Here is the page number 42, it will go. So this one is DDI, EDP, CSI, EMMC. So here this section belongs to RAM, DDR section. This is the PCHSKU. Okay, UC1 is nothing but is the sock. This is the RAM section. See, RAM 0.6 volts. It's what's that, from CPU only this voltage will generate. No, so that's why in this page only you will get this information here. Okay, this is DDR4. See here 2 of 14. Here SPI flash. SPI flash means it's a PCH. Here it will go to TPM section and as well as this bias IC. What is that? It's not bias IC, it's a SPI flash IC. Okay, this one belongs to here. It will communicate this one, SPI touch, SPI flash. Here is the C link. Here not given. So this one is LPC. LPC is nothing but IO. It's page number 25. Okay, here SM bus, all SM bus, SM clock. See here DGPU, thermal, SML related information you can see here. So next, what is this actually? This one, see, 3 VS we got, 3 PCH we got, so all related signals you can see here. That one is SPI, SML, SMB, LPC section. And now this section is LPSS and ISH. Okay, so exactly these are the page numbers 44, 28, 26 and all. Some of the logic circuits also it contains the voltages and all, even signals also. Okay, that's why page numbers are mentioned here. So here is the VRAM ID, VRAM ID1, VRAM ID2. Okay, see the in the motherboard you can see the RAM chips. So those are here 2G, DDR-G5. Okay, these things. And here is the ID path voltage divider. Through this voltage divider only it will recognize its ID1 and ID2. So here it has given GSPI, SPI, I2C and UART ISH. This section is SSI, C and USB sections. It's a PCI and USB SATA. Everything it contains. See here it has mentioned GPU, LOM, WLAN, SATA STD, SATA, ODD. It means DVD writer. It's a PCI SSD, PCIe SSD. Okay, here is the Bluetooth Type C, CCD, card reader, WLAN. All connections. Here is the page number 26, 39, 28, 2734. Fingerprints, touchpad, all information will come from this one, because I already explained you is a USB 2. Some of them are USB 3 and some of them are PCI. Here is the USB 3. These are the USB 3 and these are the USB 2. Okay, this section is PCIe, USB and SATA. If any problem with the SATA or USB section, PCI section, here you need to check the signals. Okay, what you have to check, that also I will explain. Here clock signals. See, the clock also one block actually. Here is the crystal. What crystal? 24 megahertz. When it will generate, when it will active, those things I will explain in future classes. See, here is the crystal input. Here clock signals. All clock signals will generate. Here one more 32.738 crystal also is there. That also will generate here. Okay, here is the AND gate, PCH, PLT, RST. PLT, it will generate by this signal. So here system power management, see, it's a very important section in SOC, because the power should go to this particular block, then only it can the particular devices will work. Okay, those things here it has given. We already discussed multiple things. See, S0, S3, S4, S5, almost all PCH voltages we already discussed. Still many are there. That slowly we will check all the things at a time. We can't do, right? So slowly we need to check. See, all system power good, how it will come and where it will go. Those things we'll discuss. This one is clock PM RTC section. Here this one is CPU miscellaneous JTAG. JTAG also very important, but some maximum motherboards JTAG won't be there. Okay. See here SOC. So here is the Pro chart thermal information. Okay, touchscreen information. Here is the project ID. What kind of project it is? It's 70 inches or 15 inches. Those things, all information will be available here. Here SDIO, audio section. This completely belongs to audio section. So audio section is the page number 23. When page number 23 will come, we can understand this one. Okay, the signals should pass. See, the two signals will pass to any device ID. One is TX and second one is RX. RX means it's a receives. Okay, TX means it will transfer. TX means transfer, RX means receive. TX plus and TX minus, these two signals will be very important. Okay, in any PCH or CPU to identify the devices. So those things also we will discuss. Here detection point. See, these are the detection point. LED blue light, KB, Q, WLAN. These are the detection point. So here miscellaneous tag, SDA, SDI something. Here this is the reserved signals. So we will discuss later what are those. Here is the crystal 24 megahertz. Okay, this is CFC and reserved one, CFG. Here primary CMC connection. What are those? Is XDP one. So XDP connections router. This also we will discuss. Here is the CPU power. CPU power, main thing is VCC core. Here see, some information is given. Main function is CPU. What will be that? CPU VCC core. Sometimes you may get 0.3 volts to 1.35 volts. Sometimes it will be very less, 0.5. Some technician will complain, actually this is only 0.5 is coming instead of 0.1, sorry, 1.0. Actually 0.9 and 1.0 is the standard one, but usually 0.3 to 1.35 you will get. Okay, in older motherboards you are getting 1.8 till 1.8 volts. So this is the VCC core main supply to the CPU. VCC core sense and all, when it will generate, that also I will tell you. This is page number 60. This one is core IC, that CPU IC what we call, no, that IC sense. Okay, so through that IC only this VCC and all will generate. So this page number is 15. It's a power VCC core. Next is the VCC GT. What is this? Here is the power of VCC GT. So that CPU core which I told you, know, that one will generate VCC GT core and SA. Those things it will connect here. This is CPU, this sense. Okay, this through this sense only it will continue. So here means CPU VCC GT also 0.3 to 1.35. Okay, next this section is CPU power section 1.2. It's a DDR section. Here is the input output section. It's 1 volts SCA. SA sense also is there. Okay, through that sense only CPU IC will work. So next VCC STG, VCC SIO memory. So PCH power, CPU power, okay, CPU power, it's 1.0 prime. And see what are the PCH powers. Here only you can identify those things. 1.8, this 3 volts always PCH, 1.8 prime, PCH 1.0, and so on. It's a clock 2, clock 4, clock 5. These all are here only, clock 2, clock 4. What are those? Here only. See, here is the connected one. How it will convert all the things it has given here. Okay, this is SDA, digital audio. Okay, this is PCH power. So next is the ground. It should be present. Okay, then only the complete circuit will happen. This is DDR, dim reserves. See, it's a DDR section. It's a slot 1.2 volts, and here 3 Vs. See, 3 Vs. Once you get the 3 Vs, then only this slot will work. Here 2.5 memory and 1.2 and some clock and data should pass here. Okay, in deeply we will check later. This is a dim 2. Okay, here UX1 is the TPM device. Okay, what is the TPM? So we will see. Actually on the motherboard it won't be available. So this section is TPM RTC. These are sub voltages. See, RTC section, you can see here how RTC VCC, what the signal will come here and how this one will generate. All the things deeply we will check. Main RTC section. Here only it has given, it's a TPM section, RTC section, audio section. This is audio IC UA1. So how it will connect, what are the input outputs, we will check. Sometimes audio also will be faulty, right? So that also main importance we have to give. So here see this one. Here is the audio jack, universal. This is the audio jack. Here is the audio jack. How it will come? See, this is the jack. Okay, next this one is very important one, IO MAC 1416. These all we discussed, almost all voltages we discussed, input output everything we discussed, almost all are there. So in deeply I will explain you page by page. You see. Okay, this one is a model ID and board ID. So here it has given, you see MAC 1416. In this page USB 3 port, USB 2 port, card reader also. Here USB 3 port. See what are the issues belongs to the USB 3 port 1, port 2, port 3 like that. So here you can see is here is the port 3 card reader. That issues you can see. See 3. Now this one is, so what is this? Actually from low key something is given, USB port only. Here also USB port. What it is exactly? Check. Fingerprint. Okay, what it contained in the motherboard. On the motherboard everything we'll check. So next fingerprint. Next is LCD section. This is the output section from the all what is that, from the CPU. CPU, if you are consider CPU is a circuit, so in that circuit output we will get through this LCD, HDMI section and DP. It's what the digital ports, some VGA sections ports. Okay, here is the LCD port. See what it contains. It contains camera and mic, everything is there now. Here is the camera. So here is the touch screen also one of the screen outputs. So how it will generate, what are the important signals, we'll check. Okay, now is the power LED power button. See that also very important, right? See power button, how it will generate. See here is the pressing power button. This main voltage goes to ground, then only it will consider as a on or off. See here is the connector PJPWR power 1 and here is the power 2. Next here is the lights, LED lights. So what are those? Battery LED, power LED, battery LED. How it will generate? Usually 5 volts, using the 5 volts and some signals. See from the IO. So page number 25. Okay, exactly depth we will go one by one. So this also one kind of LED. Okay, now Here is the backlight, keyboard backlight reserved. How backlight will work? See, through this Vs only it will work. Which voltage is required? 5 Vs is required. Here is the keyboard mean touchpad. Okay, touchpad. Here is the touchpad. Here, what are those? Keypad, touchpad, and thermal fan section, thermal section. Okay, so how it will control the speed of the fan, everything we can see in this. Temperature, alert. See what are the registers. These registers also very important, we will discuss later. R28. Here is the SDD and FFS. We don't know, I don't know. Here is the SDD. SDD means it's a hard disk. So we will check one by one. What is that? Here is the SATA. Here is the connection, SDD1. Okay. Here is the local. Two models are there. No, in this model it will be like this. In this model it will be like this. Here connection it has given FFC, means it's a connection actually. Through the strip will come. Okay. This one what it contains, the pin. Okay. Next. Here which one? Here FFS, ODD, SDD. We'll check ODD means it's a DVD writer. WLAN, see WLAN, what are the voltages and how it looks. What are the connected device? Here it's from 11 and 10, we already discussed. Okay, the processor signals will come here. Next, this one is WLAN connection. Next, see, this is very important. Here is the coil. Okay, sometimes you won't get the HDMI, so this coil may be the issue. You can remove this and you can direct it. So that tricks also I will explain you. This is the HDMI section. These all from CPU side. See, number 6, page number 6. Here is the HDMI connections. HDMI shifter connection. Here VGA connection, WWAN. See, WWAN and VGA connection. Here is the VGA connection. It's coming from 39 page, 8 to 20, 21. Here it has given WWAN, VGA. Next is the LAN chip, how it looks like. So what are the voltage, from where it's coming? It's from 11. Okay, processor only. LAN trans. See, these are the speed. And LDO, these are the zeros and present, not present. Signals, R plus, R minus, I'll tell you later. This one is RTL, it's a LAN IC. Here, this is very important one. DC to DC. 5 volts Vs and 3 volts Vs. How it will generate? See, here is always and here is the Vs. Through this, once this signal will come, this voltage will generate. Okay, here also 3 volts always, 3 Vs. DC to DC. Here is the 3 volts always, it will convert as PCH. Here 5 volts not given, DC to DC. And here is the SSD path. See, key M. SSD, PLTRST, last signal. Okay, it will work through this PLTRST NVMe section. Here the UT1, UT and all, it's a type C. Cypress PD, it's a PDIC and type C controller. UD1, 2, 3, all we'll discuss later. T4. And here UD2, the same things, type C. Okay, this one I will tell you. Dual roll mux, it's a type C related one. Here type C connector, top to bottom. See, it's a type C connection. DSLR we'll discuss later. Type C. Here actually what are the signals, which one is the first and which one is the last, that information it has given. So what it is, it's a platform power sequence. We made that Excel, no? All details through this only we can get it. The information, main information. So here is what it is, it's EMMC is not connected, so that's why nothing is there almost. Here is some signals. Okay, next it's a GPU. Main GPU voltage 3 volts, 0.95 volts and 1.8 GPU. How it will generate? Input is Vs, DGPU power enable will come, then output 3 VGS we will get. Okay, here also same thing, 1.0 prime will convert as 0.95. Here 5 volts always is the enable signal. Here 1.8 prime will convert as 1.8 VGS. So these are graphics related, graphic chips related signals, voltages. Here is the GPU UV1. This is a GPU, two types of GPU. So same things like CPU. This also has multiple blocks. Here also PLT, RST, VGA signal will go. The voltage just now we checked now, so that voltage it is. Here is the PCI DP. The same thing is continued here. 1B, it's a GPU section. See, these are the blocks. See, here also memory is there. What is that? VRAM chip will be there. No, those are memories. Okay, next is a function, main function of GPU. Here is the not connected device. Here is the ground, power, ground. Here nothing is there. Here is the function of GPU. See, this VGA core, VCC core will be there. No, like that, it's a VGA core. This is for graphics. Okay, what are the capacitor has to be used? These are the this. Where this is mentioned, those capacitors should be present. Okay, here this means this coil should be there. Otherwise, it will be not available on the motherboard. Here also same thing. Okay, these are GPU related signals. So power for graphic chip. Now this one is RAM, I think so memory. Yes, VRAM memory. So these are it's what is that, UV1C, and here UV12, UV14, 15. These are RAM chip, VRAM chip. On the motherboard you can see nearby the graphics. 1 MB, 2 MB, GB also. See here what it is, it's a screw point and miscellaneous nodes. This is not required. See, power up, power down, when you press the power button and when you press the power down button. Some instructions has given, portion reserved. Here DC in, battery connections, DC in we already checked multiple times, need not to worry about this. DC and battery section. Here is the type C section, how this SDC in will generate. In this charger IC, see PWM section will started here. This one is 3 volts always and 5 volts always. Here is the RAM 1.2 and 6. It's a RAM 1. Okay, RAM IC. Here is the, what is that? 1 volts always. It's a prime, 1 volts prime. Here 1.8 volts always means it's a prime. This one is 2.5 volts circuits. These are the sub circuits. Here is the IC for what? Power CPU. Power CPU IC. Okay, this is the continuation part. It is here. See, one more driver IC will be there. Through that only VCC core will generate. Here VCC core will generate. VCC GT, VCC SA. Through this IC. Next, this is CPU core. Next, here is the capacitors. What are the capacitors? It connected. Okay, next is the power. Okay, here is the VGA core. VGA core is the graphic voltage. So here is the graphics voltage. See, power VGA. Next here 1.3 volts, it's main voltage related to the graphics. Power plus 1.35 volts, 65, that's it. Okay, this general instruction, I mean it's an overview of this schematic. Till now, what are the voltages we got in Excel? We already noted down. So using that, what are the components in what pages it contains? Those things just now I explained all the things. So now one by one we will go. For example, it's HDMI section or SSD section or what is that SSD or WLAN section, otherwise DD when DVD sections or maybe LCD sections. Those things one by one we will check what voltage has to come and what are the signals has to come, what are the problems you will face. Those things we will discuss in next videos. Thank you very much. Now we have done much work, right? So we have see in S5, S4, S3, S0 state what are the voltages will come, all the things we noted down in the Excel. See what I did, I noted down all voltages, all signals in one Excel. This is voltage tree and next one is MEC 1416. This is very useful Excel. So don't forget to do this kind of things, because once you try your level best, definitely it will be useful in your lifetime. That is 100% sure, because I'll tell you in this video why it will be useful. Okay, see, this is IO. Okay, IO has total 128 pins. General instructions I'm giving here, any IO, whatever it may be, any IO, it has some pins. It may be 136 or it may be 128 or it may be some other pins. This is the IO, embedded controller. Okay, so here one major thing is you have to check here, it's a input, output and bidirectional. First supply should be there, right? Any IC, any I2 components, you should give the supply. Then according to the supply and according to the what you are giving the inputs, according to that inputs it will give the outputs. Okay, sometimes it will be working through the bidirectional and sometimes it will be in only one directional. That may be input and it gives the output. Now the question is from where you have to start. See here one more thing I did. This is SOC, complete nodes of SOC. Okay, see this is, what is that here, the blocks, what I'm telling you now continuously, blocks. You have to practice it, because if you come to know one block, then other blocks all are very easy. First you have to start. Okay, once you start, then only it will be easy, otherwise 100% it will be difficult to you people. Okay, see now HDMI section, simply I'm telling you, it's a N0 P0. That is one concept. Again N1 P1, same thing. N2 P2, N3 P3. That's it. Actually, it has multiple thousand number of pins. It has, right? So all are like this only. So one negative and positive. Negative and positive. What is that? It gives one side. It's a transmitter side. It's a negative, positive, and it receives the communication. Will happen. No, it should happen. No, it receives from other end. Because the main thing is in schematic you can see in schematic what will happen. Here is the bidirectional, here is the SOC, one positive negative it will transfer, and from there receiver side, what in case this section will work, just example I'm giving, this is a device. Okay, I'll give the best example of what is that, Bluetooth, Wi-Fi. Okay, Wi-Fi LAN has to be connected to this SOC, right? The main thing is supply should go to this particular WLAN section as well as this also. In case all signals and all voltages are good, then it has to start communication, correct? So through that communication only the SOC will identify that particular communication path, the USB 2.0 into 1 is connected to this Bluetooth device, and what information I have to get, those information will pass between them. See, it's a bidirectional, one is wireless and this one is SOC. Again, here is the SOC, here is the camera, here is the SOC, here is the touch screen, here is the sock, here is the fingerprint. One sock as connected to the multiple devices. What are those? Fingerprint, touchpad, camera, touch screen, camera, Bluetooth, SD card. Okay, so many things, so many devices. Even for communication and for programming purpose, it has connected to BIOS also. Okay, and for keyboard communication, it is connected to this I/O. The main thing is, first you come to know from where you have to start. Let us start. Okay, the basic thing is, see, now you forget all the things. The procedure, the main procedure from where you have to start, that I am going to tell you now. Okay, see, now the basic thing is, the sock will be connected to the multiple devices. Okay, what are those? Here it has given 100%. You have to follow those things. Those things are here. See, HDMI here, where is the where it is? HDMI port, HDMI, correct. So it gives some positive and negative, positive and negative. Using this positive and negative transmitter and receivers only, it come to know the mutual understanding between those two parts. In case any connection will get cut, so there will be no communication. If there will be no communication, there will be no port availability. Means working function won't be there. Correct. So like that, all blocks here, EDP section. Okay, here DP and EDP section. Here also same continuation. And in this block, eMMC, and in this block, DDR4. It's a RAM communication. See what will be there. What are the bidirectional? Those are talking. Okay, those talking communication. Now what are the output is there? It's a required clock. So before communication, so what are the things? Some signals is required. It will pass from sock section to RAM section, and RAM is okay. Then what it asking? First it will understand and it gives some other. See, input means it comes to the sock, right? So it gives the appropriate output from slot. That is called communication. Okay, here also RAM communication. See, entire sock I made Excel. You people also please give concentration. So it's very easy. Don't make it as a complicated thing. It's completely easy. Okay. So the thing is, little bit interest you have to give. That's it. See, here is the clock section, and here is the system power management section. All I not left even a single block in sock. So all blocks already taken notes. And after this, DDR4 slot will be there. No, that the RAM slot voltages also I took. See, dim one only I took, but 1 and 2 both will be same almost. Okay, here bidirectional means it's a communication path. Okay, now this Excel, how it will be useful? It will be useful to identify the supply of this particular I/O. See, now I chosen the I/O. These all pins are supply. It's very easy, right? So first you need to check the supply part. Next, supply over. Next, input. What are the inputs are coming to this particular I/O? See how many? So many are there. Here if I select this, total count 36. 36 input it receives. And next, what? Output. Okay, only one will select. How many output from this I/O? See, so many. Total 50 outputs. Okay, 50 plus this one. Total 53 outputs. Okay, those are what the voltage it contains. See, that also I mentioned here. And what is that? It's S5 stage or S0 stage. That also I mentioned here. See, once you note down this, so definitely what are the KB Lake processor, what it receives, almost all will be same. Little bit alteration will be there. That's it. Little bit. Okay, 99% it will be working in the same manner. There will be no changes. Okay, now see, this is the best example I showed you. This output, and what are the communication path? That's called, it's a bidirectional. Correct. These are the bidirectional. Through this SMD clock and data only it will communicate. See, easily you come to know, right? See, SMD data clock. Here is a, what is that? It's a bidirectional. Some little bit are bidirectional. One is this are programming level, it's a bidirectional. Data clock and programming things are bidirectional. Okay, this is the most useful for this particular Excel. Okay, now without delay I will start how to identify and what are the sections. First we need to confirm. See, the main thing is any laptop, what I'm going to tell, in that process only it will work. Maybe little bit, one signal after pressing power button it may come, or before pressing power button it may come. So here in this particular schematic they have given a clue, that is 41 page number. See, what is the clue? The clue is, first you noted down all the voltages, S5 stage 2, S0 stage, all voltages, signal, input, output, bidirectional, everything from the IO and this one block, what is that, KB leg blocks, and voltage tree over and RAM section over, right? Still more are there, but for example I have taken only 4 things. Now you will be getting confused, which one is first, which one is last. For that, answer is here. See, here the main first thing will be first one. See, first 1A, 1B. 1A usually what is that? RTC section. Correct. See, RTC means the cell will be there. Now, see, you need to do the practice of this. Please write down, note down. You have to do this minimum 10 times. It's like a school, okay? This is actually coaching classes. This is like a school. You have to behave as a student because you have to learn more. If you really have a goal to learn, so definitely you have to do these works. Then only it will be useful to you. See what I'm telling? This is the first. Any laptop you go, any laptop motherboard you take, the first procedure is RTC section. First you need to check RTC section is good or not. Next, adapter section, that is the source. Source should be there, right? See, that is 1B, 1A means the cell. That should be pakka. In case this section is short, entire motherboard, if it is working also, there will be no use. Okay, that's why it's no use, that I will tell you. In any PCH, the VCC RTC section is very important part. It's a block. In case RTC block only, it's beginning of the motherboard and end of the motherboard. It will be very important role it does. Okay, so that's the reason RTC is very important, because initially the date and time, actually nowadays it's a different concept will be there, but anyway the date and times and the bias, all connected input output it will check, no? So from that part to completely the display part, what are the connections are connected, what are the resets are there, everything will note down by this RTC block only. Okay, that's why it's very important. See, generally this is for 1A. Second one is, what are the source you are giving in the laptops. See, this is a laptop motherboard. Without source, this one won't work. The main concept is providing the current in a appropriate circuits. See, here the multiple pins are there, IO, but it contains multiple circuits. What are those complete circuits? In future you can come to know, but the main concept is input you have to give. Here is the type C, okay, and somewhere next side will be the power source. See, here BJP DC you have to give, and here is the battery. These two are power source, correct? So then one constant voltage we will get, that may be because of battery, or that may be because of adapter, or that may be type C. Those all are very important. That's the first thing, correct? This is the first. Next, second, what they mentioned here. See, once 19 volts will be generated, then it will goes to particular sections, PWM sections or whatever it may be. Some sections it will go. Generally, not only this particular motherboard I'm talking about. Any motherboard, the main source is the first thing. RTC is the first, second one is the source. That also comes under first only. Okay, that enters some sections. Then immediately the IO communication will start. Okay, IO communication will start when once 19 volts enter to the 3 volts and 5 volts IC. So it means here is the second part. First one is charging IC. Charging IC should allow this voltage here. The first MOSFET, second MOSFET and discharging MOSFET. These three things will work through the charging IC. But battery charging it won't allow. Means that is a not important thing. That won't start because of this IO. If IO is not active, how they will communicate? It will the charging IC will communicate with the battery. Correct. So that's why the charging, discharging and all won't consider at the moment. It will produce only 19 VB. That may be the voltage from the battery or that voltage from the adapter. Adapter is type C or normal one. Okay. Second part is 19 volts enters to this. These two are single IC. In single IC it has dual channel, then you will get 3 volts, 5 volts always. Here separate IC they have given for 5 volts separate and 3 volts separate. Once 19 will enter these 3 volts and 5 volts, immediately LDO will release. LDO will release. What is that? 3 VLP and 5 VLP. That again it will go to the IO and IO will active. Once IO will active, again it will come to this charging section and the battery and the adapter and the IO. These three will communicate to each other. They will talk to each other. Once you connect the adapter, then what it will do? It will charge the battery and it will check the battery condition. It will charge or not. That decision will be taken by these three because of the bidirectional. Okay, it will communicate to each other. Then here the first part, once you connect the adapter, light will glow. Light will glow because of this 5 volts and 3 volts supply. Okay, now the LDO first, next 5 volts LDO is the first, and next enable comes. Okay, through this 19 volts only enable 3 volts and 5 volts will come. Sometimes after pressing the power button this 5 volts will come, or before pressing power button both will come, or any one will come, or both won't come. Depends on the condition. That is the only variation in any motherboard. In this motherboard immediately it will generate. Okay, but some motherboard some variation will be there. This is the second part. Okay, through this 1 volts prime and 1.8 volts prime through this IC. Once this 3 volts power good is good, then it will produce 1 volts prime and 1.8 volts prime. Okay, now it's the second one. Second A it has given. See, immediately these are fraction of second it will work. Here 19 volts, immediately IO will activate and immediately light you will get. The power LED you will get, right? So that's because of these two. And immediately what will happen? So here the one signal IO, the state of charging IC is good and 3 volts 5 volts also good, then immediately it will release SIO SLP sus ash signal. Once this output comes from this IO, then what it will do, it will go to this circuit. The circuits I told you, this complete circuit, this particular section gives 3 volts always underscore PCH. Got it? So once this will come, it will active the PCH. Correct. See, now the second part is this one, and second A part means after this, after 3 volts 5 volts this signal will come, and next 2A over. Now any 2B is there. Let me check. Here only 2A. Correct. So means after this 2A directly they move to 3. What it is? See, once this PCH will generate internal logic, due to that internal logic, high low or some enable concept, the DC to DC some voltages will be there. That ICs will generate some other voltages. See, through this 3 volts always, it will convert as 3 volts always DSP. That will enter to the PCH. See, now what are the voltage generated? One is RTC section generated, and 3 volts 5 volts also entered. 3 volts here it's converted, always only convert as a SPI. That also same thing only, but after some components it will generate as this one. Then the name PCH it enter to this section, this block. Okay, now the importance is number 3. After number 2, 2A, number 3 is entering to the PCH. Now first part adapter battery 19 volts we got. Using this 3 volts 5 volts LDO we got. Immediately the IO will activated, and next once these all are activated, then immediately we got this one 3 volts PCH generated. See, this one is later, actually fourth one is later. 2A PCH voltage is generated, and after that 3 volts always immediately always DSW and SPI. SPI means what? It's a bias program related thing. Now only see, immediately after 3 volts 5 volts immediately bias related signals also entering to the PCH. RTC 3 volts always, 5 volts always, 3 volts SPI, 3 volts PCH entering, and now PCH is getting active. At the first stage, first the active part is this RTC second, then second IO, third again PCH through these signals. Okay, after this 3, where it will go? Again it will come to prime underscore power good. See, when it will come? See, after this always this 1 volts and 1.8 volts prime will generate. This power good, this particular circuit's power good is okay, then that will enter to IO. Okay, number 4th. Next, what will happen? Number 4 only here, right? Anywhere is there? Just to check. Number 3 over, number 4 not there. Now here is the number 4 prime. It gives the information to the IO. Now IO, what it will consider? So it will consider now prime related also over, I mean prime related are good. Next, immediately what it will generate? 5A PCH RSM RST, and what are the things will generate? It gives output as PC RSM RST, PCH RSM RST. Anywhere it is there? 5B. See, once the output from the IO, the signal goes to PCH, and some other places also the PCH DPW OK, power OK, D power OK, the basic power OK, that signal and RSM RST signal goes to the PCH. Understood? These all are S5 stage. Okay, S5 stage. Once it entered the 5B, next 6 will release. From where? See, now PCH received this. Next, what will happen? Number 6. Find out, it's a 6B. What about 6A? 6A. Here not there. Here. 6B. It is. You're able to see the 6B. Now it 6B, 6A. What is this? This is very important thing. See, first basic thing is, in any motherboard, one concept is adapter battery is connected, 19 volts generated. Using that 19 volts, immediately those all are at a time will happen. Immediately 3 volts 5 volts will generate. LDO is connected to the IO. IO will generate, what is that? Some signals it will produce, and it passes to PCH. Okay, some of the PCH power are some signals it reduces. See, power means 3 volts PCH, and always DSW information goes to PCH. Then finally the sum, what is that? Sus it will release, and using that only PCH will generate, and here RSM RST from the IO it will go to here PCH. But one thing you come to know is power button is the 6A. Means before pressing power button you will get RSM RST, DPW OK, PCH power OK, and always DSW, prime 1.8 volts, 1.0 volts. These are all voltage you must check. See, most of the technician, what they will check? Only 19 volts they will check, 3 volts always they will check, and next they 100% won't check 1 volts and 1.8 volts prime, in case if it is available. These 2 volts are optional. Some motherboard doesn't contain this. Okay, just I told you, all functions are same. Now what they will do is, they will stuck here only. They will think, see, amp is going to 0.025, and again it's not taking any load. Why? Because you are not checking any further things, right? So now the 6A, before pressing power button, these all sections you must check. And what are the communication will happen? Those things you can check through this. See, 3 volts always DSW, EC, DSLR. When it will come, without pressing power button only will come. Correct. This PBAT always. See, if you request for this Excel, definitely I will send to you. Okay. See, all are before pressing power button only. Okay. Now the sixth part is power button. Power button once is pressed, IO will recognize now power button has pressed. So the information has to go to PCH, right? So that's why here is the 6B. SIO power button is pressed. That information it's passing to where? Here 6B SIO power button. Along with this, lid information also will pass to PCH. Okay, power button out means power button has pressed. Lid also okay. Lid related information also good. Then it will enter to this PCH. Now PCH what it got? First it got RSM RST and D power okay. And here what is that? Now it's a power button also okay. Lead information also okay. Thermal related also okay. Then what it does? Number 7. See, it started now. Number 7. First PCH will release S5 hash related. Okay. See where it will go, that you need to check. Now the output from PCH released which one? S5. Okay. But the thing is here it has S4 also. That's the reason in some of the motherboard S4 won't available. Only S5 will be available. Here actually both are available. That's why it's not much importance as given here. Okay. They have given more importance to this S4 stage. S4 hash. Okay. Now 7 here 7 over. Now again what you want here? See 7 7 7 7 here not there, right? So 7 here over. Now 7 over 8. See at a time one first it released S5 hash. Okay. Next immediately S4 hash. Using this S4 hash signal, this section will produce VCC ST. Okay. This is one of the most important voltages. Okay. Once you press the power button, the PCH first it will consider all this related, power button related, lid related, thermal related, RSM RST related and DSW related, all are okay. Then it will release S5 hash and S4 hash. Sometimes S4 won't be available, that's optional. Okay. Here it's available. Because of that, in this circuit 1.0 volts VCC ST is available. Okay. Now at the same time it will go to other two circuits. One circuit will generate 1.0 and other circuit will generate what is that 2.5 V volts. It's for memory. And other one will go to AND gate. Okay, AND gate it will go and it will be reserved because one more section has to be come. That's why. Okay. Now what it will do? It will be waiting here. Okay. Here it will go the B section. It goes to RAM IC. Okay. So here this RAM IC 1.2 volts VDDQ generated and here power good of this particular IC, the 6. It's a VTT power good. This also generated. Now next this one VTT on from where it's coming. See the VTT control is coming from the processor. When 8C is good. See power good is okay. No, not actually this one. It's actually these two voltages are generated or these are ready in this particular circuit. Then what it will do? 8 on this voltage from this CPU. The logic circuit is there that I will show you. At the time it will work. Okay. From CPU this particular 0.6 enable signal will pass to this section. Okay. Then it will go to DDR4 slot. Now 8 sections are over. Now the term is there any IO will work in that conditions? No, only power button stage, that's it. Right. Now 9th stage is SLP S3. Still one more output will release from the PCH. Now the processor will release this one. Okay. Before that or that once it generated VCC ST. Now 9th point is S3. S3 will generate the most important voltages. It will convert. It's actually enable signal. it converts 5 volts always to 5 volts Vs and 3 volts always to 3 volts Vs, DC to DC converter. When this signal will come, and the same SLP S3 will be going to AND gate, and it will be waiting for one port, I mean other port, it will be waiting for other port. Okay, ninth one is this one, 5 volts Vs and 3 volts Vs will generate. And next what will happen here, see 9B, when this at a time, this also will release. This AND gate both will be high, then it will release 1.0 volts VCC STG and 1.0 VS VCC IO. Okay, this is the 9B. Is there any IO now? 9B? No. IO part till now it won't come. I mean, after releasing that S3 SLP series, till the time IO won't enter. Okay, after this all, the 10th one. What is the 10th one here? 10th A. IMVP we are on. See, this is the most important signal. Before older motherboards, the IO will be generating a VR on signal. But now PCH is generating VR on signal. This is processor IC. Once this VR on is entered to this, when these IO related voltages and STG related voltages has to generate. See, most of the technicians, those all are doing advanced level chip level services, they won't check this one. They will check only 3 volts VS and 5 volts VS, and finally they will stuck, see, we are not getting any SA, we are not getting any core, or we are not getting any GT, because you are not checking this. Okay, this part also you need to check. Okay, this is most important. Here is the AND gate. Okay, through this AND gate only, SLP S3 is completely okay and S0 also okay, then only you will get VCC IO and STG. Okay, IO means that all connected devices has to be okay. So then finally 10A, this voltage will release to this CPU section. Once CPU section, this enable signal comes, CPU IC section, then these all voltages will generate. What are those? Core, SC and GT. Okay, these all are not simple. Actually, once you get this, immediately you won't get the display. Still more are there, more work are there. Okay, so see, this is very, very important. So once you get the VCC IO and all, its AND gate is enabled, then once it releases IMVP VR on signal, see the most important enable signal. Once this enable signal enters to this particular CPU IC, then this CPU has 3 phase. One is SA and other one is core and other one is GT. So that I'll show you in future classes. Just you have to understand the concept of working concept of any motherboard. Okay. Now these 3 will enter. 10A. So over here, and anything is there here, so anywhere, see, all will enter to the CPU also. See, VCC STG we got, VCC ST we got, SA, prime, core, IO, GT, all will enter to the CPU. Still CPU won't work completely. Okay, it will be waiting for some other voltages also. Let us check what are those things. Now 10A over, anything is there here? 10. See that in case PCH related all voltages generated, the main thing is one minute, I'll show you this one. 10B, run power all system power good. Run power all system power good. Actually, after this AND gate only you will get that particular signal. That one through the logic IO will release, receive. See, here is the 10B. Run power all system power good is okay, because here it got the core, SA and GT. See, once we receive this SA, GT and core, that's not a main thing. Okay, that's not a main thing. Once after receiving these signals, we should get these signals to IO. IO is very, very important, because see, after all this work, again it will start one more work. It will receive this one. After this, then final reset, the signal, reset out signal, it will release. Which release? This IO will release reset out signal. Where it will go? It will go to PCH. Okay, one reset will done here, and again IO, what will happen once reset is okay? Immediately system power okay, because here reset has done, right? Once reset has done, all core, RV, SA and all will be, GT and all will be good. So then system power OK signal, the IO will release. Okay, once IO releases this system power OK, that part also will enter to this PCH, system power OK. Now CPU come to know from the IO the system power is OK. See, now reset also over and system power also over from the IO. Then finally the PCH what will do? Pin number, see, it's a point number 13, PLT RST. From the block of PLT RST, it will release this signal out. Okay, this signal out. This signal is the most important signal because this is the last signal of this particular motherboard. Not only signal, after that you need to check all signals related, means that communication related. Then only what I showed here, those things will happen through this complete blocks that I told, n plus n minus. Those things will work after that. After what? PLT RST. Otherwise it won't work. We won't get any kind of signal here actually. In DSO or anywhere you go, we can't see. In some of the pins we can see. This plus and minus, transmitter and receiver, we won't see. Okay. This is the most important part. Please give some concentration. Please study and please practice it 1 to 13. If you know these kind of signals, then this Excel will be 100% useful to you. Okay guys. So here is the conclusion of this particular procedure, working procedure of any motherboard. Because see here some signals may be vary here and there and some signals won't be available or some additional signals also available. Okay, so carefully you need to note down these kind of notes. Then you come to practical things and you have to do the troubleshooting. Okay, see problem will be there in VLP, then you are checking in core section, there will be no useful. Correct. In case of core section problem, then you are telling VL is good and 5 volts also good and 3 volts always also good. No use. You have to understand all signal level also. 100% technicians, 100% I'm telling, so many technicians will get failure to know these kind of signals. In YouTube, they will check, oh yeah, someone told it's a PLT RST has to come. Someone told it's a reset out will come. But you won't be knowing. Nobody will teach you when it will come and when it will come. When you have to check and when you have to check. If PLT RST not coming, so then motherboard will return it. Not like that. The complete process of this particular motherboard, you must understand. Okay. This processor by processor is generation vary because of overheating. Okay, in the first generation and second generation and third generation we are getting more heat. To reduce the heat, the generation has started, and increase the options, the generation has started. See, it has multiple security system also started with the latest motherboards. That's it. If you have any doubts, please contact me. Thank you.